welcome to YouTube Developers Live.
自己紹介はいいただきます
Oh, Amy Hardy's.
أوصيت السنة وتويت
This week, neither one of us are wearing pants.
We have an audience question. How does that affect the way you evaluate potential investments, especially at the seed level?
Welcome to Google Developers Live at I/O 2013. I'm Louis Gray, head of GDL, and joining me today is my co-host Daniel Seberg.
Louis, thanks so much for having me here at GDL Live at I/O 2013. This is actually my second I/O, and I believe it's your fourth,
It's
right?
my fourth I/O. I went twice as press, and this is my second year here as Googler. I'm really excited about what we've got in stage for GDL at I/O. We have exclusive interviews kicking off from the stage in Moscone, really back to back, right between every single session, so not a single minute is wasted for those of you on the live stream. Really excited about
absolutely.
that.
We've got 5,500 folks here, but lots more watching wherever you are. And part of my job will be to not only be here with you chatting on occasion, but to actually go out and talk to the developers in the sandboxes, our partners, learn from them about what they're working on, and bring that here. We'll see some of that content today and then some of it tomorrow as well.
Absolutely, I'm looking forward to that a great deal. You're going to be talking with partners from Google+, Drive, Maps, and YouTube. And while you're away doing the hard work, I'm going to be back here holding down the fort. We're going to be talking with Megan Smith of Google X to talk about moonshots. We'll be talking to people on Blink, Performance Alley, Ingress, and some really hot topics that everybody wants to know about.
Yeah, a fantastic keynote, of course, to kick all of this off. We've got a lot of work to do. We've got an amazing lineup. I feel like I should go roll up my sleeves and kind of get at it here, right?
Absolutely. So I definitely appreciate you joining me. For those of you on the live stream, we definitely want you to follow Google Developers on YouTube, subscribe so you don't miss a single moment. I'll be right back here in a couple of minutes with Megan Smith of Google X to talk moonshots.
The actual moonshot is wonderful, inspirational, poetic, beautiful, involved great technical challenges, genuine heroism. It brought the world together. But think about the Polynesian islander on the dugout canoe, deciding one day they were going to go that way. No one had ever been that way before. No one even knew if there was anything that way before. It was amazing, and it changed the world.
People can set their minds to magical, seemingly impossible ideas, and then through science and technology, bring them to reality. And that then sets other people on fire, that other things that look impossible might be accomplishable.
Galileo is such a hero, in thinking big, and what he represents to me is both curiosity and wonder that humanity had, that he had, that pushed him and drove himself to invent and work on the first telescopes that allowed us to see the moon, and here we are.
These aviation pioneers were figuring it out as they went. No one really knew how to build an airplane, right? No one knew how to fly an airplane. It was amazing and crazy and wonderful, and they wanted to explore.
Many years ago, the great British explorer George Mallory, who was to die on Mount Everest, was asked why did he want to climb it. He said, because it is there.
There's so many challenges in the world, and you can feel daunted by that, and sort of oppressed by that, or you kind of say, how might we think differently about this?
Everyone else in the world is working on the next 10%. If you can be the one that delivers that 10 times improvement, you have a chance to really change things.
If you want cars to run at 50 miles per gallon, fine, you can retool your car a little bit. But if I tell you it has to run on a gallon of gas for 500 miles, you have to start over.
You need a lot of courage in this work, and you need a lot of persistence. One of the things that's really critical is not only having the courage to keep trying every day or thinking big, even if you don't really 100% believe it's possible, like you might think this might be possible, have the courage to try. That's how the greatest things have happened.
You don't spend your time being bothered that you can't teleport from here to Japan, because there's a part of you that thinks it's impossible. Moonshot thinking is choosing to be bothered by that.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Humanity's progress has been a series of amazing, audacious things, from the very small and personal up to the great, big, and grand. And we are a species of moonshots. And to me, that's like the really amazing, poetic, and inspirational thing.
I think our ambitions are a glass ceiling on what we can accomplish.
When you find your passion, you're unstoppable. You can make amazing things happen. It's been true through all of history.
I believe in the human spirit, and I believe that there are always going to be crazy people who will get out of bed one morning and say, you know what? I think I can build a space elevator, and let's go and do it. But I think that if we become afraid to take these great big risks, we stop inspiring people. We stop achieving things. And the biggest nightmare scenario is that we won't have what it takes to solve the really big challenges.
When Kennedy said that we would put a man on the moon, it's about the fact that he said, we don't know how to do this yet, and we're gonna do it anyway. And that sends chills up everybody's spine. Because if that happens, what couldn't we do?
Welcome back to Google Developers Live at I/O. Welcome, Megan Smith.
Thank you.
And
It's great to
really,
be here.
thank you for joining me. I'm really excited about moonshots. We've been talking about some really incredible things. We just heard from Larry about all the work that Google has been doing. We heard from Vic and Sundar, and really trying to change the world through technology. Can you tell me a little bit about what a moonshot is?
Sure. Sometimes we think of it as 10x better versus 1x better. And in fact, we just watched this film with some of us talking. Often doing a 10x can be not easier, but easier than you think than 1x. We just try to look at, I think I have a graphic. We launched a thing called SolveForX, which is trying to get more moonshot thinking in the world. And sometimes you think about there's a huge problem in the world. If you put up the graphic, there's sort of 3 circles. Technology that maybe it appears like science fiction, but it's coming online, or there's a new way to think about some technology, and let's apply it in some way. Not unlike the original moonshot. We want to get here by the end of the decade, get started, start with Mercury and move.
And now the initiative SolveForX really tries to solve global problems. One thing that really excited me about Google in the first place was that we take on these things that people say is impossible. How do we let the impossibility of things get in the way? What do people say that they can't do? And what do you think makes Google a great place to say, yes, we can do this?
We stand on the shoulders of giants and amazing moonshot folks. I'm from Buffalo, New York, where Nikola Tesla took a moonshot to use Niagara Falls to light Buffalo years ago to demo modern electrification. So many people have been thinking like that, but it maybe hasn't been the majority. And certainly Larry and Sergey, in founding Google, thought about, what's the big idea? What can we do? They were passionate, of course, about search in the beginning, but have taken us in a lot of directions. I think also in some ways, there's some moonshot work around how we do our work, how we collaborate. I love that Larry just did a full open Q&A, very transparency, as a fundamental thing, and collaboration.
That's something that's really important to us in Google Developers Live. I want to break those barriers down so all of the people on the live stream can not only see us and talk to us, but engage with us and have that kind of Q&A that we honestly get as employees from Google to hear from Larry. It's really exciting to see Larry and all the other engineers engaging with developers here. When I look at Google and we talk about moonshots, obviously things like self-driving cars come to mind, and other bits like Gmail. It wasn't too long ago that Gmail came out. It came out on April Fool's Day of all things. I didn't even know if it was real. But they promised us a whole gigabyte of email when everyone else was offering 20 or 40 megs. What is your thought in terms of what are some moonshots that Google's done so far? And what comes to mind in terms of something that we can really deliver on to change the world?
And there's a range of moonshots that Googlers have taken, and I always think that moonshots are both the idea and the people, or the team. Who and what are never separate, but maps and geo would be a good example. This incredible team of Keyhole and Where2Tech, other small acquisitions we made, and the teams came and we got together and really pushed it, wanted to have free, full mapping to everybody, and some of the things we've just seen demonstrated are on that path of really thinking big.
And you talk about big, it's really incredible to think about the millions of miles that are in Street View, and the fact that just a few years ago you wouldn't have thought of having the entire globe in a little smartphone in your pocket that you take with you everywhere. And the moonshot really kind of takes the impossible, the incredible, and makes it real and makes it happen. For somebody who's going to the SolveForX website, how can they get started? What is it that they can do to find other people with similar dreams like them?
Right. On our website, the main thing is we want people to put up proposals. What are their moonshots? We want to celebrate people in process. Of course, we want the historic stuff and hear what great people have done and inspire us that way. But also, let's help people and teams in process, and let's get inspired by each other to think of new things. So a lot of things to watch and collaborate on there. And in general, Larry's saying, think big. That's what we're trying to do. The other thing that we're trying to do is that ideas come from everywhere. Bill Clinton says 21st century is really about creative collaboration. Back to the Maps example, we are doing things in Maps, but then there's things where people are adding edits and things on top, layers, amazing innovations. Above that, Ushahidi is such a fabulous innovation on top of mapping to help with crisis around the world. So collaboration together, and I love that we're on Developers Live. because it's all about the interconnection of us. I have to give a talk this summer called The Next Greatest Generation. I think the next generation, the greatest generation, is actually all of us networked.
Right. And so one thing, honestly, when we look at Google's a business, we're not a nonprofit. Is it possible to do a moonshot without first thinking of revenue? Like, how can we do something that is not only incredible, but does it have to make money? Like, how do you separate the business side of things from the actual want to change the world ideals of doing things?
I always think, there's for-profit, nonprofit, but there always need to be revenue coming towards something, even if it's gifted revenue, donations, or philanthropic, or Kickstarter-like things, or others. So I think the most important thing is not to start with the money, to start with the big idea. We did that with Google. We've done that with so many products, and then the money can follow if it's incredibly valuable. And sometimes innovating how the money should follow is a big part of the design. The internet is such an example of freemium. This idea that free things and then add ways to pay for some part, or media-based advertising, etc. So there's a lot of different models out there that you can use. But I think the most important thing is find something you're really passionate about doing and something that's really needed in the world. Those two things together, let the business plan follow.
Now, as Vice President of Google X, you see incredible things every day. Things that the world knows about, things that I know about, and then things that almost nobody knows about. And you must have an incredibly busy time. Now, what else are you doing at Google I/O in addition to speaking with us today?
Well, the Google X team is here with Google Glass, of course, and Larry was talking about, the self-driving car ambitions. And then we have a lot of other things we're thinking about and working on. We're still cooking them. They're still early. So we're working on those. And then, of course, Self-Rex of sharing this. I'm also personally working a lot on diversity, and we have a session later today at 5:30 on live stream that I hope people join. 7 tech makers and a microphone.
Yeah,
the women tech makers live at AIO.
We've had a number of sessions on women tech makers on GDL. It's been really a key focus for us to make sure that we're highlighting incredible women.
Right.
I was really pleased to make sure that you went first and would be our first guest. Not because you're a woman, but because you are an incredible executive who has a proven track record, who happens to be a woman. And you're doing a lot of great stuff with WTM, as we call it, with Women Tech Makers, and I'm glad that that's been an incredible focus.
Yeah, and Larry was just answering a question about getting more girls and boys, but girls into STEM technologies. I mean, there's so many jobs open that we don't have people for. We need a lot of people to come into our field, and this is a friend of mine, Nicholas Negroponte, once said, have you ever had a job? Meaning sort of, this is passion work that we do. It's not like required work. And so for young people to know about this work is really important. And the visibility of technical women is important, because technical women, for whatever reason, through media and others, have not been as visible as they should be, including later today we're going to talk about a history story at 5:30 at Pacific that nobody has ever heard pretty much at scale, so that should be fun.
Sure. Well, I definitely appreciate you coming and talking with me. We're going to be producing a lot of exclusive interviews with Googlers throughout the day. On Google Developers Live, we're going to be highlighting some of our partners in the sandboxes, and we have a lot more content. What we're going to be doing right next is we're going to be going back to the sessions, so start to see the live sessions from all the streams that you're looking at from Android, Chrome, and other technical topics. And then we'll be right back here at the GDL at I/O stage around 1:30 to talk about Blink with Chrome. So
Cool.
Thank you very much,
Winston.
Megan.
Thanks everyone online for joining us.
that scaled to the demands of our workload, to search, to Gmail, to apps, to everything. And last year, I invited Stephen Levy to come by and have a look at our infrastructure. And he called it the mother of all clouds, which is kind of true because we've been working on it for 14 years. So for 14 years, we've been building the largest, fastest, and most cost-effective infrastructure in the world. For over a decade, we've been building our servers, we've been building our data centers, we've been building our networks. You use this infrastructure every day, probably, because you use Google products, and so you know how fast and reliable it is. And building such an infrastructure is really a huge task, and sometimes it's a huge headache. But for me and my team, it's a huge challenge, and that's what makes us get up in the morning, come to work, to go and make that infrastructure even better. And with the Google Cloud infrastructure, you can now use that same infrastructure for your own applications. But before we get into that details, let me just show you a few pictures of how this actually looks. Here's what looks like a room of servers, but it's actually from our networking room. Our networking rooms are larger than some other people's server rooms. Here's another look at the networking room where we connect our data centers together. Here's a row of servers, each server built by us and optimized for performance and cost. So maybe they're not pretty, but they're fast and very effective. Here's a row between, here's the inside of a server row. So on both sides, you see the back of the servers. They push their hot air into this plenum where it gets cooled again. Here's a server room in Finland where we converted a paper mill into a data center. And here's a mechanical room in one of our data centers where all the cooling water comes together. Blue pipes deliver the cool water to the floor. Red is the warm water coming back. And here's some cooling towers in a data center. We use cooling towers where we evaporate water to cool our data centers in an environmentally friendly way. In fact, we spent a lot of effort to make our data centers and our cloud as environmentally compatible as possible. So we've been leaders in data center efficiency, for example. Our data centers use only half as much of energy as normal, average data centers. And that's good not just for the environment, it's also good for you. Because less overhead means less cost. And we pass these savings on to you in lower prices. We're also the first internet company that's gotten ISO 14000 environmental certification for our standards at the data centers. And we're proud to have been the Cool IT leader in the Greenpeace leaderboard for 2 years in a row now. So when you run your applications in the Google Cloud, you know you're not just getting great performance, but you also get great environmental performance. And we're continuing to build this infrastructure. Just in the last 12 months, we announced data center expansions in the US, in Europe, in Asia, and in South America for over $2.9 billion. So clearly, we see a lot of growth in demand for our services, but we also wanted to make sure there's enough room for the growth of your services. We also run one of the world's largest networks. We're the only company that's not an ISP to own and operate submarine cables, for example. So here you see some pictures of the Unity cable where we organized a consortium to build a new cable between the US and Japan that today serves several terabits of capacity between those two places, just in time for Gangnam Style, I guess. So our network spans the globe, and it includes one of the largest, if not the largest, CDN. And we peer with virtually every major ISP worldwide. So we can hand off your bits to the end user ISP in one step, and therefore have the best performance and speed. So you know that you're not just getting the best performance inside the data center, you're also going to get the best performance between data centers and to your users. And our network is not just big, it's also one of the most advanced networks you'll find. Well, today, many are talking about introducing software-defined networking, we have been running a software-defined backbone for over 2 years. Our OpenFlow-powered backbone, which you see here, connects our data centers and provides much better performance and cost than our previous backbone. And so when you run your application on a Google Cloud, you'll benefit from that backbone as well. And of course, we work not just on physical infrastructure, but also on software infrastructure. And I'm especially proud that we can really claim the best track record of any company in building infrastructure software. Here's just a few examples from the last decade or so. In 2002, we built GFS, the Google File System. And GFS was really the first file system to scale to data center size. We had to build it because no existing file system could really handle our workload. Remember, to build web search, you have to first build an index. And to build an index, you have to store your own copy of the web in a file system. So that's why you built GFS, which later, a few years later, inspired Hadoop file system, HDFS. But we're not actually using GFS anymore. We moved on to Colossus, which is its much more capable successor. And that's what's actually powering cloud storage today, and also pretty much any other storage at Google. Now, why did we retire what arguably was one of the world's most successful and most capable file systems? It's because we're building for the future, and we wanted a file system that was more capable, a file system that can handle workloads and storage pools at least 100 times bigger than GFS, a file system that has higher availability with multi-master and fully distributed directory, a file system that understands Flash, and so on. And we also learned a lot of things in the 13 years since we started using GFS. And all of these things have flowed into Colossus, and therefore we've retired GFS. For another example, 2004, we created MapReduce, which of course inspired Hadoop and the whole big data industry. Similarly here, we have a lot of MapReduce still running inside the company, but we're not actually using MapReduce anymore. We use Flume, which makes it much easier to construct sort of large pipelines of MapReduces. In 2006, we created Bigtable, which is probably the world's most scalable NoSQL infrastructure, and very likely the most battle-tested NoSQL infrastructure there is. Almost everything at Google uses Bigtable. So Gmail, web indexing, G+, if they use a NoSQL system. So pretty much everything runs on Bigtable today. But of course, we're already working on making it obsolete. And last year, we talked about Spanner, which gives you a similarly scalable and similar performance system, but with transactional consistency. So I hope you're catching my point, right? Not just once, but several times, we wrote an industry-leading system decades ago, only to retire it because it wasn't good enough anymore, and we wanted to get something even better. And so we've been around the block, more than once, and that's what you actually see in the quality and the performance of the public cloud infrastructure, even though it's just, not even a year old. So we spent the last 14 years building these great systems with the scale, performance, and value that we needed internally, and now we're making them available to you. In fact, in just the less than 11 months since I was here at Google I/O announcing our cloud, we've launched over 160 improvements to pretty much all of the systems in the cloud. Now let's take a look at what our users have done with that cloud. MapR broke the minute sort for only $1,200 using Compute Engine. The previous world record was held by custom hardware costing hundreds of thousands of dollars. So even in a release software, we're delivering world record performance. Snapchat, probably one of the largest, fastest growing consumer services out there, is delivering over 150 million snaps per day on Google App Engine. Songpop scaled to over 80 million users on a cloud platform, 1 million daily users using App Engine and data store and cloud storage. Scalr, the performance of Compute Engine lets Scalr dream about things that they couldn't dream about before, even though they've been providing systems management software for many other cloud providers. The simplicity of our infrastructure lets Udacity focus on doing courseware rather than being a sysadmin or dealing with their, administering their systems. And for those of you watching from Europe or here from Europe, you'll know that the Concours d'Eurovision is one of the largest TV events in the world, a song contest. And just 2 days ago, the semifinals ran, and the software for the user participation in those semifinals was written by our two partners, Scalr and Grand Centrix. They delivered 50,000 requests per second at really great and consistent latency on Compute Engine. So our customers are using really all parts of our infrastructure. Let's take a quick step back and look at that. Our cloud platform is a comprehensive, integrated platform with compute, storage, and application services, an extension of our internal infrastructure with strong connections to other Google services and APIs. And so as thousands of Google's engineers improve this infrastructure for Google, you will benefit from those improvements as well. So you can use what we use. So you can build your software and run your business in the same place that we do, with the same performance, scale, and value that we built for ourselves. So now that you've seen our past and our vision, let me show you a few things that we're announcing today. Let's start with Compute Engine, because many of you want and need access to raw VMs. That's important. We announced Compute Engine a year ago, and we've rolled out a ton of improvements since then. Now today, the standard unit of measure for compute is an hour, regardless of how much time you actually use. So if you have a 15-minute job that's done after 15 minutes, you still pay for 60 minutes, which increases your actual cost by 4 times. So just think about that. Imagine making a 15-minute phone call, and then you get charged for a full hour. It makes no sense. And starting today, you won't get overcharged like that on Compute Engine. We're introducing sub-hour billing, which means that you have the value and the flexibility that you want from the cloud. And specifically, we're billing in 1-minute increments with a 10-minute minimum. So you really pay only for what you actually use. And thank you. So sub-hour billing really changes how you can think about building your application. So suppose you have a MapReduce and it's running for an hour, and that's too slow. And suppose you want to make it complete in 15 minutes. Well, it's easy. Just add 4 times as many servers. You get charged for 4 times as many servers, but only for 15 minutes. So you end up paying basically the same thing as before, yet your job runs 4 times faster. In other cloud providers, you'd have to pay a 4 times premium for that extra speed up, which really doesn't make it a viable choice. So the sorting world record that you saw before, now instead of $1,200, only costs $200. So that's really value, performance, and scalability all in one place. But sometimes you need only a little bit of VM. Maybe for testing or for an application that just doesn't need a lot of CPU. So we're introducing smaller micro instances. They're very cost-effective ways to handle these workloads. But unlike other providers' small instances, these instances still have predictable performance, not just best effort performance. So just as sub-hour billing lets you scale up a workload, these instances let you scale it down with predictable performance. We also have advanced routing that lets you connect your on-premise infrastructure with an encrypted VPN to the cloud. Very easy to use, very straightforward. Now you can combine, you can have applications that really span both infrastructures. Persistent disks are a big portion of the value in the infrastructure, right? You want to attach persistent VMs to persistent disks to your VMs. And our persistent disks are limited to 1 terabyte, which, even though it matches what other providers have, isn't really enough. And so you ask to make them bigger. And you were right? 1 terabyte isn't really big enough. So starting today, you can have 10 terabyte persistent disks. And I'm especially proud that we were introducing this 11 months after we first announced Compute Engine, where other leading providers, after 7 years, have not managed to have persistent disks larger than 1 terabyte. So speaking of storage, if you've been using App Engine, you loved Data Store, because Data Store is basically Bigtable, a NoSQL data store that is very, very scalable and very, very easy to use. So the App Engine high replication data store has been incredibly popular. This data store today serves over 4.5 trillion transactions per month. That's trillion, not billion. So it's been incredibly successful. It's twice the load that it handled less than 11 months ago at Google I/O. And now you can use this data store from anywhere as a service, the Google Cloud Data Store. So whether you build your application on App Engine or on Compute Engine or elsewhere, you can access this data store. And because it's NoSQL, it has fast query response time, no matter whether you have a 10K row table or a 10 million row table. So you can use it from any language and from anywhere. Speaking of App Engine, as you know, App Engine has been around for a number of years and provides a scalable, very easy to use, managed way to build applications without the hassle of managing servers. It now has over 3 million active applications, so active running applications, making it one of the top Google services. And it has thriving communities around Python, Java, Go, but it's missing one of the most popular languages on the web, one that powers 3/4 of all websites. Well, starting today, PHP developers can get the benefits of App Engine. So with App Engine, this isn't like your existing PHP stack. So with App Engine, you don't have to manage your PHP stack. We patch it and manage it for you. And because it's App Engine, if your site gets no traffic, it costs you nothing. But if your site gets a lot of traffic, we can scale it up fast. And by fast, I mean fast. We scale up new instances in fractions of a second, not in minutes. And these instances are not shared. They're securely isolated. Static caching is built in. The data you store is automatically replicated between multiple data centers. So this isn't your daddy's PHP server. In fact, just this weekend, literally this weekend, we helped someone port their existing PHP website to App Engine PHP because they were anticipating a flash crowd, which in fact did happen. It took only a few hours to port the site, including turning on PageSpeed service. And the result was that they had a highly scalable site where a cold page load was 4 times faster than before. So PHP has never been easier to use and run. Speaking of App Engine, still, a lot of you write large applications on App Engine. And we've made it much easier now to have such large applications because you can build modules inside your applications. And these modules logically separate your code. They let you develop with independent teams. And you can, at a fine-grained level, control the versioning, the ACLs, the updates, the quotas, and so on of these different modules. And in fact, you can use different languages for these different modules, all in the same application. And they all share the same backend data stores. So writing large applications in App Engine has never been easier. All right, well, actually, it can get even easier. As you saw in the keynote this morning, we're making it even easier to write mobile backends. Many of you already are using the Google Cloud as a backend for mobile applications. And with the tools you saw this morning in the Android, in the keynote, we're making it even easier for you to interface with your backend and to generate a lot of code for it. You'll see that later in this, you'll see it live later in this talk. But we know that some of you actually don't want to write any code. So we also introducing the mobile starter kit, which is literally a no server code solution. You get a backend, a mobile backend, with push notifications and authentication, and you don't have to write any code. Well, you do have to write code, namely the code for your client. That's the code you want to write. Right? No overhead. The cloud really doesn't get easier than this. Finally, last but not least, we know that a lot of you care about security, and in fact, a lot of organizations require their infrastructure to be certified. So I'm happy to announce that we have ISO 27K security certification for all of our cloud, compute engine, app engine, and storage. And this is just one example of our commitment to security, and you'll hear more about that later this year. But now let's see this cloud platform in action. So Greg will show you how easy it is to build an application and by mixing and matching the different components of our infrastructure. Greg.
Thanks, Urs. As Urs mentioned, I'm going to spend the next 25 or so minutes building out an application that uses some of these new features of the cloud platform that we announced today. And because this is a developer conference, we're going to spend the next 25 minutes looking at code. I also want to introduce Brian Lynch, a solutions architect on the cloud platform, who's going to help us as we go through this. So let me start by describing to you what this application that we're going to build is. There we go. We're going to build a video sharing site for I/O attendees. This is going to have a site that allows us to upload videos, view videos, comment on them, and it's going to have a mobile companion as well for us. So let's start by looking at the architecture we're going to use to build this application. There's going to be a web front end that's written in App Engine that does sort of the heavy lifting. We're going to use a variety of data storage technologies, from Cloud SQL to the Cloud Data Store to cloud storage. There's some processing we're going to do with Compute Engine, and I'll talk about that when we get to it. And then finally, we're going to build a mobile front end using the Android tools to tie the whole thing together. So let's start with the App Engine front end. As Urs mentioned, App Engine was originally built to take away the tedious, error-prone grunt work from making a global-scale, highly available application. It's hugely successful with 3 million active applications. And as Urs mentioned, there's big communities around Java and Go and Python, and now we've added PHP to the mix. So we're going to use PHP to build this particular application. So let's take a look at PHP on App Engine. We'll switch over to the demo machine. And what we have here is a laptop with the Cloud SDK installed. We're going to use my favorite text editor, in this case Sublime. And we're going to start by creating sort of a hello world application, the simplest PHP application we can think of. So we'll put the PHP tag, and we'll do a call to PHP info. For those of you who don't know PHP, PHP info basically returns a bunch of information about the environment you're running in, the server environment, the configuration, and all that. So it's one line of code that'll generate some interesting content. Now, as Urs mentioned, we are striving for a 100% compatible version of PHP here. So for many, many applications, there are absolutely no code changes. But App Engine actually adds extra value on top of PHP. So let's look a little bit at the configuration information that we need to provide for App Engine. Some of this is what you'd expect for App Engine, the project ID, the name. Those of you who use App Engine know that App Engine provides built-in support for versioning and rollbacks. So you can deploy new versions of an application. If they don't work, you can roll them back instantly. So we've given this a version number. We've put index.php as the name of the script that this will run. So with that, we've built our application. Let's flip over to the terminal, and we will publish that app using the standard App Engine tool. We'll tell it that the runtime for this particular language is for this project's PHP, and we'll give it the name of it. And up it goes. So App Engine's collecting the resources, it's compiling the PHP, it's uploading all of that into the application, it checks for the deployment to work, sure enough, and the app is up and running. So let's pop over to the browser and look at this. So here's the PHP info. It has all of the information that we would expect, that we're running on Linux. Later on down, it'll list the version of the frameworks that are installed. I'll point out the server API line showing that this is actually running on an App Engine PHP server. So that's a hello world, but now let's actually turn around and build our application. And what's PHP without SQL? Luckily, with the cloud platform, we have Google Cloud SQL. Cloud SQL is a cloud-hosted service that marries the industry-standard MySQL front end to a highly available backend, all running on Google-managed, Google-hosted infrastructure. As a developer, I don't have to worry about configuring this MySQL. I don't have to worry about deploying it, maintaining it. I just use industry-standard tools like JDBC, Crystal Reports, Squirrel SQL to manage it. So to help get us started, we pre-populated a Cloud SQL database with some videos that we took in the week running up to the conference. So let's take a look at that. We're going to switch over to our command line. We're going to use the Cloud SQL command tools, and I'm going to specify the name of the project and the name of the instance of Cloud SQL that I'm running on, and then the particular database I want to look at. So we connection, and now I can use just standard MySQL type commands. We'll show the tables. You'll see that there's a table of videos, a table of users. We'll select the first, 10 or 50 videos from the videos table. And what I want to point out here is, of course, there's an ID. You'll notice that what's stored here is a URL into Google Cloud Storage. We're actually storing these videos in cloud storage. So let's actually start to build out the application to query these. To make it a little bit simpler, we're going to switch over to the desktop, and I'm going to drag and drop in a bunch of CSS and HTML and JavaScript to make the application look pretty. And we're going to look at one particular bit of code, which is the code that queries the MySQL database. If you know PHP, this code should look very, very familiar to you. This is standard PHP MySQL code. The standard connection string and a standard query. But there are advantages of running with Cloud SQL. We know that this App Engine app and this Cloud SQL are part of the same project because you told us that. That allows us to automatically configure the firewalls to allow those two to talk to each other while keeping them isolated from other traffic and other projects that are running on the infrastructure. It also allows us to place those instances in our infrastructure in a way that reduces latency between them. Because again, we know that this particular Cloud SQL database and this particular application are running with each other. So let's go ahead and run this app. And so now I've got my nice pretty CSS and HTML. We've retrieved from the database the URLs, the thumbnails for all the videos. So we'll just pick one at random there. and we're retrieving the video, and yep, there's Joe waving at us. So that's a simple use of querying a Cloud SQL database. Now, this is a video site, and it is 2013, so clearly I have to have comments on a video, right? In fact, I expect this site to be wildly popular. I think I might have thousands of comments for every video, and I have thousands of videos. So clearly I need a very low latency, high performance data store to hold those comments. Now, fortunately, we have Cloud Data Store, our built-in NoSQL database. As Urs mentioned, we're currently handling over 4.5 trillion requests a month. I think that's enough scalability for the comments we are going to process. So let's take a look at that. If we flip over, this is a little bit of code from App Engine that accesses the comments in the Cloud Data Store. You'll notice, again, it looks very familiar to you if you're a PHP developer. It's retrieving a little bit of information from the HTML page, so it's getting the comment. It's retrieving a little bit of information from the session state, so I know the name of the logged in user. It's constructing a comment entity. It's putting in the text, the current date, the user, and then it's calling the put method to actually take that data and store it into Cloud Data Store. Once it's stored, if we scroll down a little bit farther, we'll see the code to retrieve it. It's creating a query for the comments. It's filtering it by the video ID. It's ordering it by the date it was added. And then it's actually taking that and putting it into the HTML page. So we already have some comments we added. So let's flip back over and see what people think of Joe's waving. And they seem to like it. Brian, what do you think of Joe's wave? Great wave. Great, so when he hits enter, we'll create that, post it into the data store, pull it back, and there we have it. So now we have App Engine accessing a very highly available, highly scalable global data store. So if we flip back to the slides for a sec, let me sort of recap what we've done so far. We've built a front end using PHP, the language that powers 3/4 of the world's websites. We've accessed data in a variety of forms. We've queried a database in Cloud SQL using just the plain old PHP MySQL integration that I'm used to. I've used cloud storage to access potentially terabytes of data that I've stored in actual videos. We've used a NoSQL database in the Cloud Data Store to store and update comments. So that's a pretty good front end so far. But you know, behind most of the most popular websites out there, somewhere there's some heavy-duty processing going on. That could be analyzing log files. It could be building recommendation engines to tell you that if you like A, you might like B. It could be processing media, whether that's audio or video. In our case, we want to allow our users to upload the videos in any format, and we want to transcode that to a variety of formats for a variety of devices. That sort of work is a really good task for Compute Engine. It's spiky computationally, right? So it only happens when somebody actually uploads a video. It actually is CPU intensive. And so it's the kind of task where I want the cores I want, when I want them, and with the performance I expect. So it's a really good job for Compute Engine. Since the last I.O., we've been very busy hardening the Compute Engine service, rolling out new capabilities for it. So let me give you an update of what Compute Engine looks like. So let's switch back to our Cloud Console. And this is, for those of you who have noticed already, we've rolled out a new version of the Cloud Console. Compute Engine now appears in it. I think the console looks great. So let's first show you the user interface for creating a new instance. So to create an instance, I populate it with all the things you'd expect. I give it a name, a region. I apply metadata to it. If Brian scrolls down, we look at the machine types. We've been busy expanding the range of machine types we offer. So we have everything from 1 to 8 cores, with disks, without disks, high memory, high CPU. So pretty much whatever the type of load you have, we've got a machine type there that's suited for it. Now, in our case, we're not going to create VMs with the user interface. We're going to create them programmatically via the REST API. because we're going to have App Engine orchestrate these virtual machines. App Engine's going to be the one that creates VMs as we need them and kills them when we don't need them anymore. And for everything you do in the Cloud Console, there's a corresponding REST API that lets you do it. So we've got a quick upload page here that we've created. And it's a simple HTML target that allows me to drag videos in. Now, we could drag one video in and watch what happens, but one video, I mean, that's not really Google scale, is it, right? You guys just saw maps of the Earth, so I think you expect a little more than one video. So let's drop 1,000 in. Now, VMs take 20 to 30 seconds to spin up, which may seem fast to you, but to us, that's still too slow. But while it does that, let me just talk to you about what it's doing. We could have App Engine just fire up one VM and tell it encode 1,000 videos, but that would take a while. What I really want to do is have a fleet of virtual machines that I spread the work out to. And that's exactly what the App Engine app is doing here. It's firing up a bank of VMs. It's using our Compute Engine management APIs to monitor the CPU load. If the CPU loads are all busy, it fires up more VMs so the job gets done quickly. If the CPU load drops, it gives that VM more jobs to do. When it's finally done, it goes through and it shuts down all the VMs so that I don't pay for the usage anymore. And this is a good example of why fast startup and sub-hour billing is so cool. I can literally throw cores at a problem because the VMs start up quickly, they do the work, and I only pay for the minutes that I'm actually running them. So I think by this time we should have some VMs up and running. So let's pop back over to the console, and you'll notice down there, there's the list of our VMs. They're in alphabetical order, not the order we instantiated them. So if we scroll down, yeah, you see the green check marks. Those are VMs that are up and running and are processing work now. And if you scroll back up to the graph, you'll see that we ran an earlier test run a little bit earlier, and you can see the CPU spikes from those jumping up. And more importantly, you see them going back to 0, right, when the work was done. You know, at Google, we say faster is better, and we certainly take that to heart in Compute Engine by having fast startup times, consistent performance, and sub-hour billing, really letting you do things that weren't even economically possible before. So let me go back to the slides for a sec. Recap where we are with our application. We've got a front end written in App Engine and PHP that handles all the website. We've got a variety of data stores in Cloud Storage, Cloud SQL, Cloud Data Store. And we have a backend in Compute Engine that does video encoding for us. But there's more we can do with Compute Engine here. Remember I talked about those comments that we've had in the Cloud Data Store. Well, as the owner of this site, I'd like to actually know whether on balance those comments were good, bad, or neutral. And furthermore, I want to use Compute Engine to do that analysis. Now, in the past, the Cloud Data Store was only available to App Engine. But as of today, that data store is open to everybody so that I can access the same comments data that App Engine was using from Compute Engine. The nice thing about the data store, it was developed for the kind of data sets that we encounter at Google. As we do things like web search and maps and ads and Gmail, we needed a very high capacity data store that had very fast performance. So you get consistent performance on this data store whether you're accessing a megabyte of data or a terabyte of data. So let's flip over and look at how we're going to do this. We wrote a Python script that analyzes the comments. We'll take a quick look. So we're going to SSH into that machine. So why don't we go back to the text editor real quick so we can show the code. So this does some very simple analysis based on the words that are included in the post to find out whether it's net positive or negative. If we scroll down a bit, we'll see the code to query the database. So there's query response equals database.run query that retrieves the data. And then there's some similar code that writes the data. You notice it says datastore.blindWrite. In this case, we're the only ones accessing the data store. So a blind write is just fine, right? I don't have to worry about multiple writers. if I did care about that, I could just as easily wrap this up in a transaction and get that transacted protection as well as this way. So this is our simple video or comment analysis. Let's go back and actually run it on one video to see what it does for one video. So we're SSH'd into our virtual machine. And we're going to run this Python script, and it retrieves all the comments very, very quickly. For each comment, it determined 0 is neutral, 1 is positive, -1 is negative. Now, that's fine for one video, but I've got 1,000 videos, and I have 1,000 comments on each video. So this starts to look like a map-reduce sort of job, doesn't it, right? Phase 1 being analyzing all the comments. Phase 2 being to collect that information and come up with an aggregate answer of whether a video is good or bad. So we already have a 10-node Hadoop cluster up and running on Compute Engine. And just to prove that this, really is writing to the data store, let me flip over to the data store viewer in the Cloud Console, and we'll look at the comments database, or the comments data store. So we've got a query written. So just to see, these are all the IDs of the videos and the number of comments they have. And you'll notice there's no column there for a sentiment. We haven't yet calculated that. In fact, because this is a NoSQL database, we don't even have a schema for columns. In fact, if I were using a SQL database, this would be really difficult because I would have to push a schema change through the whole system just to start calculating sentiments. The nice thing about NoSQL databases is you just start writing new values and they automatically appear. So let's fire up the Hadoop job, and let's start processing these for all of the videos. Now, as Urs mentioned, we run a lot of MapReduce inside of Google. So we've really tried to optimize our data center to run MapReduce jobs really well. So our job is running. The map phase for each video, it retrieves all the comments. It does a quick analysis on whether it's positive, negative, or neutral. The reduce phase then collects those results for all the videos and comes up with an answer for each one. So the map is done. The reduce is started, so let's flip back to the console and rerun the query. And you'll notice we have total sentiments now calculated. It's a new column that appeared. We've calculated all that. Some of them look awesome. Some videos got a 31. Some of them, maybe not so much. I hope Joe's the 31 and not the -4. So sure enough, the values are calculated, and they appear in the data store. So if we go and look at, the last thing we did was we updated our PHP page to actually retrieve that value that was calculated. So if you scroll down, you'll see it's now positive. So here we had App Engine entering comments in the data store, Compute Engine reading those values, writing a sentiment value back, and then App Engine seeing that sentiment and placing it in the page. So you really get to use each service for the job it's best at, but have a consistent set of data stores that you can access across all of those. So let's flip back to the slides. So that completes our web app. So let's turn our attention to the mobile companion. You know, we're all walking around with incredibly powerful video devices in our pockets, so of course we want to be able to take video and upload them. And in fact, what I really want to do is make it super easy for my mobile developers to access the code that I've written inside of App Engine. And Cloud Endpoints does that. Cloud Endpoints makes it super simple to write back-end logic in whatever language you want and easily expose a nice, friendly client-side interface. You don't have to worry about data serialization. You don't have to write OAuth code. You simply write server code, and then you get a nice client library for it. So to do that, we've written some back-end code in Java, taking advantage of the feature that Urs talked about of breaking App Engine apps into subcomponents. We've written a second component in Java. We need to switch the switcher. This component does two things. First, it returns a URL into cloud storage for the mobile device to upload to. Second, it provides an API here you see called upload completed that the mobile device will call when the video is uploaded. And when that's done, the App Engine server sets a title, creates a thumbnail, basically populates the metadata about that video. So I'm pretty happy that does what I want. Now, Those of you who've noticed will notice that we're not in Sublime anymore. This is the new Android Studio mobile IDE that you heard announced earlier today. Based on IntelliJ, I think it's a huge step forward in terms of providing a great development environment for Android. Now, I'm a cloud guy, so my particular favorite feature here is this. I can right-click on my server project, and down there there's cloud endpoints, and it says Generate Client Libraries. That's all I need to do. The tool will then generate for me a client-side wrapper that gives me a nice, clean, type-safe interface to my server-side logic. So let's look at that client-side code. And you'll notice this code looks very much like the server-side code. There's upload completed. It takes a bunch of parameters for a URL and a thumbnail and a string. So by calling that, I don't have to deal with the authentication. I don't have to worry about how do I serialize and marshal data back and forth between the client and the server. So we're actually going to run this application now. I've got an Android phone here. So if we switch over to this. Hello. Is the phone dead? The phone turned off. You rehearse for almost every eventuality in these things, but somehow the phone being turned off was not one of them. While that's coming up, let me mention a couple things. There are breakout sessions on all the topics that we're covering today, including mobile development with the Backend starter, PHP on App Engine. There's a complete breakout session on that. There's a breakout session on the Cloud Data Store as well. So if you want the nitty-gritty from the developers on any of those technologies, definitely those breakout sessions are where to go. I don't have my phone here. Toss me my phone from my bag. I have the app on it. So we'll take one more time for that to boot. I'm going to go through this because it's worth seeing the mobile device. There we go. There we are. Unfortunately, I'm about to expose Brian's unlock code. So if you happen to get his phone, you now know how to do all sorts of things. So here's our application. It's staring up at the Elmo. I'm going to put my head in it. I'm going to hit the record button. You'll see it starts recording. You'll see the blue recording bar going across. Okay, it's finished recording. Connecting server for URL, so it's making the first call. Could not upload your video. Let's try it one more time. Yep. Ah, yes, now we have connection. Let's see how Verizon does. There we go. So it's recording now. Connecting the server. Uploading the video. Yes. Persistence pays off. I'm going to do one more of you guys just so that you're memorialized in my keynote demo for the time when my phone didn't work, of all things. So I'm taking a video now. Everybody can wave. Very nice. and it's going to do its thing, connecting to the server, uploading the video. Let's flip back to the actual site. Let's look at the videos. The most recent one uploaded is, yes, me looking, unfortunately, right up my nose. So that's, if my parents are watching, I apologize now. So let me, oh, there we go. That's a better one. Let's go back to slides. So that's really just one example of what you can do with the cloud platform. I want to point out one more that I'm not going to build, but I want to draw your attention to, and this is the Data Sensing Lab. Those of you who've noticed have seen these little signs around Moscone Center. We've deployed 525 sensors around Moscone that measure things such as the temperature and the humidity and sensor mats of how many people are walking by and the noise level, how loud is it. And then we've built a system using the cloud platform to collect that data, to store that data, to analyze it, and to visualize it. So if you go to the sandbox right now after this session, you'll be able to see this data in real time and sort of play with and visualize a very large, very rich set of data. Well, there's also going to be a session where the authors of the Data Sensing Lab will walk you through what they did, how they did it, and how they used the cloud platform. While you're at the sandbox, please take the time to stop by and look at our partners. As you know, even as much effort as we put into the cloud platform, it's not just us, it's also our partners that help make this real. In particular, there are 16 partners who will be in our Somebody double-click the button. There'll be 16 partners in the sandbox. These aren't marketing people, these are developers. So you can go and ask your technical questions. They'll tell you their best practices they learned from running on the cloud platform, and so that's a great resource as well. With that, we'll turn it back over to Urs, and I'll wish everybody have a great I/O.
Thank you, Greg. So, you've heard a lot today and saw a lot of cool new things. Just to recap, you've seen the Cloud Data Store in action in the demos and accessible now from anywhere. You have sub-hour billing, so you pay only for what you actually use. You have shared core instances for the times where you just need a little bit of CPU. You have advanced routing to connect on-premise and off-premise. You have 10 times larger persistent disks, and you have PHP on App Engine. But there's one more thing I'd like to talk about it. And in fact, it's something that I wish we had in 1999 when we started Google. And it's something that we've been working on for a very long time. And it's something that's just a start, but something that I believe will change the face of computing over the next decade based on the work that we've done in the past decade. Something that will make Google better, but will make the life of developers better, and it will make the web better. So I'm very, very excited that tonight, starting at 6 p.m., Compute Engine is open for signups to everyone. So, yes. So head over to cloud.google.com, sign up, give it a spin. I'm excited to see what all of you do on top of this platform. So thank you for coming to Google I/O. Thanks for coming to the cloud session. Have fun at the other sessions, and have fun in San Francisco.
from Moscone Center here in San Francisco. We're here to talk about Blink. I'm Louis Gray, and I'm joined by Alex Komorowski and Paul Irish. Welcome, gentlemen. Thanks for joining us.
Absolutely.
Real quickly, we want to talk about Blink, brand new rendering engine. I want to give your guys' take on what's been introduced.
So Blink is a new rendering engine. It's based off of originally off of WebKit. It's a rendering engine that's open source and it's used in Chromium and Chrome.
So you said open source. Is it a Google product? Open source? Like, help us out.
It's it's operated within kind of the Chromium open source community. So there's Chromium, which is kind of the open source implementation of Google Chrome, they're basically 99% the same. With a few very small differences. But Blink is an open source project and likely even we expect it to be used in Opera's products as well.
Sure.
Yeah, so it's open source, and one of the things that one of our main goals with the project is to be as transparent as open as possible. So we're trying to have as much of a discussion in public channels. We've already seen a lot of really good engagement from people from other companies, from other organizations and web developers on these threads, sort of providing their feedback about features we're thinking about implementing, and it's been really great.
Right, so how does a new rendering engine benefit consumers anyway? Is it going to get faster? Like, what's going to happen?
So as it starts out, it's based off of WebKit. So it's basically, it was about, as of a month ago, it was almost exactly the same. Since then, we've been optimizing some pieces on our side, and it will continue to get faster. And over time, however, a stronger, faster rendering engine allows you to do new things, so allows developers to build better experiences. It allows them to be faster, so consumers' web pages will just appear faster and do more things.
Like one of the main things that we'd like to, that we focus a lot on is speed, right? And so when I'm scrolling a page on my phone, I want it to stick to my finger, and I want that experience to be fantastic. And with Blink, we have the opportunity to make some really kind of radical changes to the infrastructure of how a browser's put together to really deliver a fast and awesome user experience.
So one thing that's really interesting, you look at the web, and it was talked about today in today's keynote. We're on the 20th anniversary of the introduction of the web. And one of the things that's really helped the web grow and just work on practically every device is standards. And so with the introduction of a new rendering engine, is this a situation where web developers and app developers who code for the web are going to have to make two versions of their product? Like, what does that mean for a developer side?
There's no big real changes. The Blink is dedicated to just supporting an interoperable web, and that's something that we believe a lot in, and it's having a compatible interoperable web. So for developers building for the web, you build to web standards, you build just as you did, and you're going to expect it to work.
And I think back many years ago, different browsers were very different. I think in the past few years, the different rendering engines have gotten closer and closer, and a lot closer, as everyone really is taking standards very seriously. We're also investing, we're very excited to invest more in testing, so helping write tests with standards organizations and other browser vendors that all the browser rendering engines can run, and that helps verify that these things are interoperable. And so the developers only have to they don't have to write totally different versions for different browsers.
In the past, developers have known about like browser quirks and things like that. And over the past few years, they've been less and less because browsers are running the exact same tests, even though they're different products.
Right. So this is a situation you used to have like modern browsers and non-modern browsers. Is Blink like a cut above? Is it going to be the most modern browser?
It certainly moves fast, and it gets new features all the time. But it's really you're gonna get a consistent experience when you're coding to the new features.
And I mean, although the goal is to build the best possible rendering engine we can, but what's great about the open web is you have all these different compatible rendering engines, and so this is very healthy competition to spur innovation throughout the ecosystem.
So one thing we've talked about before, I mean, since Blink is still fairly new, and we're talking a little bit about the new features that are going to come out. We expect the community to respond really strongly. One of the questions I have around browsing is we have so many people who are browsing on mobile these days relative to the desktop. How much did the advancement of mobile usage of browsing impact the decision to look toward Blink? And do you think that mobile users can see the benefits of Blink as quickly as desktop?
So I think if you saw the keynote this morning, Linus talked a lot about how the future of the web is mobile. And so we take this really seriously on the Chrome team. Now, the reason that we started Blink actually came down to the fact that Chromium's multi-process architecture is just different than the other WebKit-based browsers, and it led to complexity in the code base. And that was primarily the thing that drove us to make this decision. But yes, we care very deeply about mobile, and we're excited about the different kinds of things we can experiment with.
And when you look at the complexity in the code base, I remember when we launched, we had our initial blog posts and the reactions to it. A lot of discussion was taken to kind of getting away some of the cruft or older code that was available in WebKit. How does that benefit folks as well? Is it just easier to develop on it with fewer lines of code? And what are we getting away from?
I want to point out actually that WebKit is an amazing code base, and it's an amazing community. And what we were trying to remove were pieces that just weren't relevant to Chromium. And so when you have extra stuff in a code base that you aren't using, that's code that has more surface area for bugs. It takes longer to check out as a developer. It takes longer to build even. And so it was removing pieces that didn't apply to Chromium, but were still very nice pieces of code, like JavaScript core, for example.
Yep.
And one of the things, I mean, you mentioned code and cruft. One of the fun things I've seen bump up in coverage of Blink is vendor prefixes. For those of us online who don't know what a vendor prefix is, what is it, Paul? And why do I care about a vendor prefix?
So vendor prefix, the idea behind vendor prefix is a way to kind of insulate users when browsers want to introduce kind of new experimental feature. And they want to be able to have a little bit of freedom to maybe change it in the future, and then browser vendors will kind of work together to standardize it, and then the prefix that's in front of it will disappear, it'll graduate. Now, that was kind of the idea behind it, and it sounds good. But in practice, over the past few years, it's kind of not worked out, and it's had some kind of harmful effects on the ecosystem. So one of the things with the introduction of Blink was that we were able to take a policy and said that we're not going to be introducing any new vendor prefixes. It's painful as a developer to deal with having multiple vendor prefixes, and we're not going to add any new ones, and we're not going to introduce new features that have this. And this is a similar model to what Mozilla with Firefox has gone towards, and also the W3C CSS working group has kind of said that this is a direction that makes sense going forward.
Now, Blink is still fairly new. I know a lot of people often when something comes out right away, they say, how can I get my hands on it? And because Blink is an engine and not an app, it's not like you can just download Blink and start playing. But so if you want to get your hands on it either as a developer or as a user, what's the best way to do that?
So again, from the very beginning, it was literally just WebKit, and then we've been developing in a slightly different direction. And so all the newest versions ever since April 4th, I think, when we announced Blink, have been using Blink. It's just that it's not really that different yet. It's getting more and more different. And so those versions will become on the stable channel of Chrome in a number of weeks.
The Chrome beta has Blink in it, and Canary has Blink in it. So if you want to try it out, but
it's not going to feel very different.
No. And as a Chrome OS user, do I get access to Blink as well, or is that a separate branch?
Yep.
So, I mean, I'm using my Pixel here. I use Pixel practically every single day, as often as I can.
I love mine.
And so one of the things that's been really cool for me for the Pixel, I know we have a conversation about that tomorrow, is you're finding more and more web apps are replacing the things that I traditionally had to use a desktop for. Is that part of also our consideration as we build a new rendering engine to enable what's next in the world of web apps?
Absolutely. We believe very firmly that the web platform deserves to be as powerful as any other native platform. And so we've been pushing within the ecosystem, within the standards bodies, and really drive to make the web platform as powerful as possible. So.
Absolutely. Well, Paul and Alex, I appreciate you guys coming down today. I know you have a very busy Google I/O, really one of the hottest topics that's out there for the web and for Google in general. For those of you on the live stream, stay tuned. We have 4 more sessions coming your way, whether you're on the Android channel, Chrome channel, or the technical ones as well. And we'll be back right after those with more programming at Google Developers Live at I/O.
and show you just enough code to give you the right set of context. Before we get too far into it, allow me to introduce myself. My name is Jonathan Berry. I'm a developer advocate on the Google Plus platform. If you have questions about the session afterwards or want to learn more about the Google Plus platform and just generally talk to somebody on the Google Plus team, add me to your circles. That's a link to my profile. That's the best way to get a hold of me. And yeah, I'm responsive, and you can ask me technical questions or anything else. I'm also joined by my colleague from Google Plus.
Hi, I'm Reema, a technical leader in Google Plus platform.
Awesome. Thank you, Reema. So today's agenda, we're going to cover 4 main areas of the Google Plus platform. The first and most important is the Google Plus sign-in button. This is a widget, a plugin, a snippet of code that you can add to your applications to enable users to connect their Google accounts to your services. And with it, we add a little bit of Google magic that we're going to show you in a little bit later. Once the user signed in, they've granted access to their Google profile. So you can start integrating that profile, making a personalized and engaging experience, and a returning user. With Google Plus sign-in, we also introduced a new form of sharing, a type of targeted sharing that enables users to reach out to their friends on Google and then bring them back to your app in an engaged way so they can start using your application in a social way instantaneously. And the last piece we're going to cover is what we call app activities. This is a way to enable you to write activities to Google that users are doing within your app, and then Google will surface those activities in meaningful times across Google at the right moment for the right user. Great. So let's start thinking social. I work with a lot of developers, and they tell me the same thing. I want to use social platforms. I want to integrate social into my applications, but I don't know where to begin. Let's pause for a minute and think about what does it mean to be social in our daily lives. It's really about 2 things, people and connections. So similarly, to enable social within your applications, it's about bringing people and connections into your apps. And the reason why you want to do that as a developer is to acquire new users and increase engagement. And in fact, with the Google Plus platform and Google Plus sign-in, the features we built were targeted to make sure that we can help you get new users and increase engagement. And throughout this talk, we'll mention those features, where they help you get new users and increase engagement. And a bit of a spoiler, it's all the features, all right? Great. So let's talk about the Google Plus sign-in. And where it starts with a button. The Google Plus sign-in is a button you can add to your web apps, to your mobile apps, Android, iOS. It's a plugin, it's a widget, it's a piece of HTML that enables users to connect their Google account with your service. It's a seamless experience to allow them to authorize you to start accessing their profile information. And when you add the Google Plus sign-in button to your apps, you can be confident that users are going to start to use it as a way to log in. That's because Google is a trusted brand, a brand built on privacy and security. We have things like 2-factor authentication, multi-login, and the controlled sharing of circles that get carried over with the Google Plus sign-in product. And as a developer, Google handles the authorization for you, which is a very complicated problem that we help you solve. So the user clicks that button, and we take them through the authorization flow. Here's the authorization screen that a user might see if they're using Jolie Cloud. And there's 3 major sections. There's the branding at the top, the set of permissions you're asking the users to confirm, and the ability for them to accept or deny your request. Let's walk through each part. So the top is the branding. This is controlled by you as a developer to let the user know who they're about to sign into. Now let's walk through those permissions. The very first line is the basic Google Plus API permissions. This enables you as a developer to access the user's public profile information, things like their first and last name, their profile picture, their Google ID, and anything else they might have enabled on their profile to be public. But it also includes the people that they follow in their circles. This is a flat list of the people and the pages that they've added on Google+. And you'll notice there's an edit list option. This is the very first place that we provide control and trust to the user so they can say who you as a developer know about in their circles. This creates confidence for the Google+ sign-in as a login solution. The next line is another permission. This is actually the Google Drive permission. So with Google Plus Sign-In, we enable you to use multiple Google APIs in a single authorization flow. This is very powerful because Google provides a lot of great services that could benefit you as a developer, and the user only has to authorize those services in a single dialog. The next line is their Google email. This is their official email they use to log in every single day. There's not a form field they might mistype that email or a spam account they might want to not deal with if they register for your service. So you can trust that this is their real Google email. So if you have existing user accounts and you see this email, this is most likely that user. And if you get emails from other networks, you can use that as a join to combine user accounts. And the last bit is the permission to write app activities on behalf of that user. And like the list field, the user can control just exactly who can see their activities and which activities are being written on their behalf. So now for that magic, a little bit of the Google magic. When a user signs in to the Google Plus Sign-In button, and you have an app in the Google Play Store, if that user has an Android device, when they click that button in that flow, we will ask them, would you like to install this Android app as well? And Google handles that for you. So we're pushing your Android app directly to engaged users who are already connected with your service directly to the phone in their pocket. They don't even have to take it out. This is the #1 easiest way for Android developers to acquire Android users. And this is one of those features that seeing is believing. So let's watch a short clip from one of our integration partners.
The main driver behind our success is having a product that's easy to use and delights our customers. Over-the-air install provides users with a seamless experience. They create their account or log into it for the first time, and our Android application is automatically installed on the user's smartphone so that they can have a delightful first-time experience.
Awesome, huh? And as we saw in the keynote today, if they've logged in already on the web, they have that Android app on their phone, they're seamlessly signed in with seamless sign-on across platforms. Now, we've been out for about 2 months now, and we're seeing fantastic conversion rates for users. So we announced just yesterday that 40% of users who see this dialog say yes. And that doesn't include the users who already have your Android app installed. So this is a #1 way to get new Android users. So now I'm going to turn it over to Redeema to show us some of that code to add the Google Plus Sign-In button to your applications.
Thank you, Jonathan. When we designed Google Plus Sign-In, one of our key goals was to reduce integration complexity for developers. It really is amazingly simple to integrate this into your application. For example, we use OAuth 2 to allow the user to authorize your app, but all the implementation details are completely hidden away from you. You don't have to worry about any implementation detail regarding OAuth 2. This integration simplicity has been extended across all the different platforms that we support, be it web, Android, or iOS. If you remember nothing else from this talk, please remember our developer site, developers.google.com/plus. We have quick start, sample code, reference material to guide you through your development. Let's quickly talk through all the integration steps. The very first step is to go to the API console and register your application. On doing that, you will receive a client ID. Please make note of this client ID. We will use it in the sign-up process to identify your application. Now let's take the web JavaScript library for an example. What does it take to put that button on your web page? You need to load a single JavaScript library from Google, and you need to add markup on your page where you want us to render the button. That's it. We take it from there. We will parse your page and render the button based on the configuration options that you specify. The button will be rendered localized in the language of the currently logged in Google user, and we also allow you to use custom styling to tweak the look of the button. All we ask is that you respect our branding guidelines. These are posted on the developer site that I mentioned earlier. Let's talk through the different options that are available. By specifying the gSign-In class, you tell us where in your DOM you want us to render the button. Remember the client ID we just fetched from the API console. You need to specify that here so that we can identify your application. So when you walk through the consent dialog, we saw that your app can ask the user for certain permissions. Plus.login is the very basic scope for Google Plus platform integration, which allows you to fetch the user's profile data, meaning their name, profile URL, age range, gender. It also allows you to fetch the people in the user's circles. In addition, it allows you to write back different activities that the user is taking within your app back to Google so that we can surface it in interesting and relevant contexts. Your app may require additional permissions. So for example, if you need to access the user's files, you would ask for the drive scope here. Suppose you use Wallet as part of your payment solution. You would also ask for the payments.makePayment scope here. By specifying a cookie policy, you allow us to optimize performance by caching OAuth2 tokens by storing cookies on your site. The complete documentation for this is available on our developer site. Remember these app activities we keep talking about that you can write back to Google? Using request visible actions, you specify what are the different activity types that you would like to write back. There are over 10 different activity types to choose from, and you can specify more than one activity type here. For example, if you wanted to write back user purchase events, you would specify the buy activity here. You can specify a JavaScript callback that will be called on a successful auth result. This could be as a result of the user clicking accept on the consent dialog, or as a result of auto approval in case the user has ever authorized your app before on Android or web. In any case, in this callback, we recommend that you hide the sign-in button, and you can go ahead and personalize your app to give the user a better experience. So here is the code snippet that you would need to add to your page to load the JavaScript library we talked about earlier. This is the same +1.js that we use for all Google Plus plugins, including the +1 button. So if you have integrated +1 already on your site, you would already have this code snippet and you don't need to add it again. +1.js parses the page and renders the button based on your configuration options. As Jonathan just showed you, one of the most amazing features of Google Plus Sign-In is driving over-the-air installs of your Android app right from the sign-in flow. It's completely trivial for you to set up. All you do is specify the app package name, and we will take it from there. We will decide how and when to show the dialog and all the different error conditions. As I mentioned earlier, this integration simplicity extends across mobile platforms as well. On Android, we provide Google Play services. This is a background service already running on most Android devices that lets you easily make Google API calls. This means that to invoke the sign-in flow, you call connect on the Plus Connect library, and the sign-in flow initiates. Similarly, we have a native SDK for iOS. To start the sign-in flow, you would need to configure the GPP sign-in shared singleton instance. Then you can go ahead and make authenticated calls once the user authorizes your app. So now that we have an authenticated user, Jonathan will tell you more about how you can personalize your site to give the user a good experience.
So the user is connected with your service and has allowed you to access their Google account. So at this point, you want to start personalizing that experience, integrating their Google information to make their logged-in view personal to them. You can start integrating their profile to make it an engaging new user experience. You can streamline registration, or you can even forgo registration altogether and start pulling their profile and making them a new user. You could also start using their circles, the people in their circles, and suggest content and connections based on that data. So let's take a look at two examples. So this is Flixster.com, who's already integrated Google Plus Sign-In. And this is one of my real accounts. You can see they pulled in my profile information, so I know it's which account I'm logged into. They have my first and last name that they've pulled in directly. I've never typed that in. And behind the scenes, they're doing a few other things which are not clear here. But they have my Google email. So they're actually sending me email notifications when videos and films that I'm tracking are now in theaters or available to purchase. On the side, they actually pull in my Google Plus circles. These are friends of mine who are using Google Plus Sign-In and are using Flixster. So this way, I can start tracking their activity and see what they're doing right on Flixster. And this is a pretty powerful integration, integrating circles to help me discover my friends. But using that same data, you could have a more meaningful experience. Let's take a look at Banjo. Banjo is another integration partner of Google Plus Sign-In, and they do something very powerful here. What they do is they take a bunch of different social networks, and they do joins across those networks, and they help me discover people I might be interested based off of my social connections. So by taking the people in my circle, these connections that I talked about earlier, you can make for a more meaningful experience. This is an engagement tool. You can use social connections to help users discover new content, whether that be new people to follow, or maybe a new interesting video that their friends are watching right now. Again, this is helping those users stay longer and interact more deeply. Ridhima, to see some code.
Thank you, Jonathan. So now that we have an authenticated user, we can start making authenticated API requests to fetch their social data, like their profile data or their friends. We have client libraries in all major languages and native SDKs for mobile. Once again, let's look at web for an example. So for our client libraries, we have built on common infrastructure that we call the discovery service. Using metadata, we dynamically build native methods for an API. This means that you only have to use a single client library for any Google API call. So if you're making any Google API calls in your application, you would already be familiar with these client libraries. Loading the +1.js code snippet defines the GAPI global object. We can use this now to load different client modules. In order to make social API calls, we would load the +v1 module here. If we had wanted to make calendar API calls, we would have loaded the calendar v3 module here. Loading the +v1 module defines the GAPI client plus object. Now, if you want to fetch the user's profile data, you would call people.get on this object. You would need to specify the user ID which you want to fetch data for. If you want to fetch data for the currently logged in Google user, we provide you a shortcut me. Similarly, if you had wanted to fetch the user's friends, we would call people.list on the same object, again specifying the same user ID parameter, for which you again have the shortcut me. In addition, you would need to specify the collection visible parameter to fetch those friends that are visible to your app as selected by the user. Now that we have defined the function, we can execute it, providing a JavaScript function that will receive this profile data and actually personalize your app. Now that we understand how personalization works, Jonathan will tell you how Google Plus Platform provides interactive sharing.
Thank you, Ridhima. So if your application has content, users want to share that. And as a developer or content creator, you want them to be sharing that content so you get more users. But we've noticed a problem with social sharing today. Let's say you convince somebody that this is worth sharing, and they'll share it out to their networks. Their friends may see that on their already busy stream. If something really catches their eye, they may click on that link and go to your site. If it's a video, they might watch it, they might drop out, and you'll have a bounce rate. But you really are not getting the kind of engagement that you're really looking for. So we set out to do a new type of sharing, a form of targeted sharing that enables users to reach out to their friends on Google and then bring them to your app with the mindset to already start engaging. And we call this interactive posts. Let's walk through an interactive post. So the first thing you'll notice, this looks like a social share. It has a share button. There's a link associated with it, and it's very similar to the other types of shares we do on Google today. But the most obvious difference is a big button, a call to action button. This is a button that when it shows up in the stream will stand out, and it's clickable. So if a user sees that and is interested in the description and the copy, they will click on that button, and it will take them somewhere. Where we take them is a deep link that you provide. Whether they're on mobile or web, we will route them to the context that you specify. And that should be the context that I originally shared out the interactive post. That deep link will also take them directly to your app. And if you don't have the app, we will help you get that. We'll help that user get your app. So interactive posts is not only a great way to increase engagement through a targeted share, but it's also a way to capture new users. So a few more things about the interactive post. As a developer, you can pre-fill the text. So you can set up the context of the share. And if a user likes what they see, they can go ahead and share it, or they can edit it. What's really important about an interactive post, besides being targeted and interactive, is that it is user-generated. So when one of your friends receives an interactive post notification, they know it actually came from you. So that helps with conversion and making this share a more meaningful share for both the sender and the recipient. The last thing I want to highlight is the names at the top. So when you share, you have a target, you set the recipients. But as a developer, you can pre-fill the recipient targets. And this includes email. So if you already have users in your system with email from a username password or through another social network, you can target and pre-fill across networks via email. Extremely powerful, especially for marketing, especially for growing your cross-network user base. So let's walk through a scenario of an interactive post. And we're going to use OpenTable as an example. And OpenTable has integrated Google Plus sign-in. And we're going to do just a little bit of role play here. So fast forward 3 days. We're all done with I/O. And the team wants to go out for a delicious dinner to celebrate a successful event. There's a fantastic ceviche place just down on the Embarcadero. But I want to make sure that the restaurant has options for everybody. So I start reviewing the menu. Looks good. There's vegetarian options, of course, ceviche, and a little pisco sour for those of us who need to relax a bit. And I want to share this out with the rest of the team so they can decide if they want to join. So OpenTable has integrated an interactive post button. This is a customizable button that looks right in their UI. When I click that button, I get that familiar dialog we just saw a moment ago. They have that view menu that when my friends see it and my colleagues see it, they'll know that there's a menu on the other side. So I go ahead and share it with Redeema. Redeema has her Android phone in her pocket, and she gets a little buzz. That buzz has a notification that somebody has directly shared something with her, which is an interactive post. It's a notification that actually stands out above others so that she knows that there's something waiting for her, like a direct message. She clicks on that notification, and she's taken to the stream where she can see that full share with the pre-filled text that OpenTable provided, the image, and that call to action button. When she clicks on that call to action button, there's a deep link behind it, and we take her directly to the context that OpenTable wanted her to, which is the menu that I was originally sharing. So now she's in OpenTable, engaging directly, reviewing the menu, and can confirm that reservation at a later point in time. We have over 100 different labels for our call to actions. These are configurable labels, and we're seeing developers adding multiple types. Because this goes beyond a standard social share, there's an action associated with it. So let's say you're a publisher site and you have video content. You might want to have a watch button, where users click that button and they're taken to a video that starts automatically. Or you have sorry, that was a podcast one. We also have listen and watch. Let's say you're an educational site, and you want to take users straight to the content so that to avoid registration, you might have a learn button. And if you have your own commenting system, you would have a comment and reply. Or of course, there's e-commerce solutions where you want to have a user see that buy button, see something they like, and when they click it, they're taken directly to the checkout page with that item pre-filled. We're also seeing partners combining it in multiple different ways and intelligent ways to make it part of your app. Not just a little share icon off the center, because they want to drive users to share more targetedly. And just like the rest of the platform, it's very easy to integrate. So back to Redeema to show us that code.
Thank you, Jonathan. For interactive posts, we've built on existing Google sharing plugins and APIs, and all of our client libraries and mobile SDKs package it up for easy integration. We have built-in deep links. This means that no matter which device a user views an interactive post in, on clicking it, they will be taken to the right context within your application. Once again, let's take the web as an example. Just like the sign-in flow, the interactive post flow starts with a rendered button that you can configure through markup. Now, we've omitted some of the fields here, but if you look at the important bits, the call to action label can be specified by an enum, and the complete list is documented in our developer site. We just saw a preview of all the different actions that you can take. It could be buy, comment, view, watch, listen, you name it. The call to action URL is the URL at which the users will be taken to if they click on the interactive post on plus.google.com. The deep link ID takes the user directly to the right context within your application if they click on the post in one of the mobile versions of Google+. You can predefine a pre-filled text that will be populated in the share, which of course can be edited by the user. You can predefine a list of recipients up to 10 users. It can be specified in the form of Google user IDs or any email addresses. Do you notice some familiar fields here like client ID, scope, request visible actions? These are all similar to the sign-in flow. That is because the interactive post also takes the user through the sign-in flow if they have not already signed in. This is especially useful for the use case in which you want the user to sign in only when they want to share. So this is yet another way we help you get more signed-in users. For comparison, here is a snippet of the interactive post integration on iOS. As you can see, the syntax may be different, but the core pieces are exactly the same. So this is amazing for developers, since if you understand how interactive posts work on one platform, you can easily integrate it into any other platform. Now that we've talked about sharing, Jonathan will tell you how you can write back different app activities that the user takes within your site back to Google.
Thank you. So you have a logged in user, and they're taking all these actions. They might be uploading content, they might be reading, they might be creating new things. And all these actions are happening within your application, but other users don't know about this. It's not discoverable. So with Google Plus Sign-In, we enabled something we call app activities. It's a way for you as a developer to write to Google so that we can surface those activities to other users across Google at the right time. We actually demoed this integration just the other week at TechCrunch Disrupt. So here's how one such integration would look like. So let's say a user is searching for Fandango. Fandango has integrated Google Plus Sign-In. All those activities that users are taking within their app, they're sending to Google. And Google is aggregating those activities, anonymizing them, to show other users what is trending on Fandango. This way, other Fandango users might discover new interesting content based off of Google users as a whole, or even help Fandango get new users by discovering their brand. These are clickable links in the knowledge cart that, like we saw before, are a deep link, which would take the user directly to Fandango, to the right context, to the video, where they can start seeing the trailer or even purchasing tickets. This is the direction we want to go with this product. We want to help you to surface your apps in more meaningful ways across Google by making those activities users are taking in a social context useful for others. And this is the very first place that we're integrating app activities. And just like the rest of the APIs, it's very easy to integrate.
Thank you, Jonathan. So now that you have a signed-in user, you can write back different app activities that the user takes within your site back to Google. And as Jonathan just showed, we can surface them in interesting and relevant contexts. We have already seen that we have client libraries in most popular languages and native SDKs for mobile. All we do now is use one of those client libraries and call an API to write these moments back to Google. So here's a sample of our Python client library. To write an activity back, you would need to specify the activity type. Again, for example, if you wanted to write back user purchase events, you would specify the by activity type here. This should be an activity type that you have already configured in your sign-in markup, and the user would have explicitly granted access to this type when they see the consent dialog. In addition, you would specify a target URL, which should contain the schema.markup for the activity type you have just specified. Now that we understand how the different pieces of the sign-in flow come together, Jonathan will summarize all that we have learned today.
Great. So let's do a little bit of a review. We saw the Google Plus Sign-In button, the easiest way for you to acquire new users by enabling them to connect their Google account with your app. We saw how you can take that user and create a personalized experience with their Google profile and their connections on Google. We talked about how you can increase engagement by using interactive posts to get users to bring their friends back into your app and interacting immediately. And the last bit we just talked about are app activities that we can use to surface relevant information across Google. Now today, I went through everything very quickly and very briefly. There's a ton of detail to make this an awesome integration, depending on your platform and your type of integration. So throughout the rest of Google I/O, we have sessions on every feature in great detail, from beginning with Android to best practices across the web, and boot camps, code labs to get you started and get you finished. So I suggest if you're interested in any of these topics, that you attend one of these, and if you're in the live stream, a lot of them will be available to watch as well. A quick credits to the images I used earlier. And I want to thank you for getting interested in Google Plus sign-in. 3 important links before we take questions. One is our developer site, which you've seen already. It's developers.google.com/plus. That's the overall developer site. We use our Google Plus page and our Google Plus community to engage with conversation and answer questions about different topics. So I suggest you add the Google Plus developers page to your circles. And the last is our Stack Overflow page. This is where we do a lot of our support. So if you have technical questions that you can't figure out through the documentation, this is a great place to go. Again, my name is Jonathan Berry, joined by Radimya Kidia, and we thank you. Awesome, so we have plenty of time for questions. So for those who are here, come up to the mic. I'm going to try to figure out how I can do the online thing in a second. Let's start left first.
One puzzlement that I've had is the sign out from the app. I don't know whether it's best practice because you can have them sign out completely out of Google or just sign out of your app. And how do you serve that to the customer so they understand if they're going to sign out of their Google account or just out of the app? And what's your recommended best practice for that?
So that's a great question. It's about sign out. We've seen a few different implementations of sign out. A lot of you developers just want to keep it logged in. Right? As long as they're logged into Google, they want to keep them logged into your service. But some users expect sign out. We made it really easy to disconnect. So when they want to disassociate their Google account with your service, we have an API that makes that easy. And we've seen already developers implement their own form of sign out. It really depends on their logic, how they treat a user, what it means to be signed in. Is it in the browser? Is it in the server? And we actually have a session on best practices where we talk about it, as well as authorization, where we talk a little bit more about sign out. But it's entirely depends on your integration.
Well, I guess, let's say a person's traveling, they're at a hotel, maybe they just signed out of your app, but they're still logged into their Gmail. Someone could go access their mail. Or they're at home and they're doing their daily activities and they sign out. You just signed them out of their Google account. So, you have to, how do you deal with that? It seems like it's confusing to the customer.
Typically, especially the services that do really care about sign out, is they track it themselves. So they'll use their own sort of cache, whether that be a cookie or local storage, to say this user signed out. Or if that user is in the server, then they're going to basically disassociate that server, that currently logged in session. So we can talk about more after, depending on how your app is built.
All right, thank you.
Sure thing. Let's go.
Yeah, I have a question about Android, but I guess it applies to any application. Let's say I want to use other Google APIs like tasks or Google URL shortening and stuff like that.
Mm-hmm.
Can I use this and then add another scope and then ask only one set of permissions to the user, or it's something different and then I need to ask user multiple things like give me access to your Google Plus profile, give me access to let me put tasks or something like that.
Yeah, great question. The question is, can I use multiple scopes at one time?
Yeah.
And the answer is absolutely yes. We showed some snippet of code.
Mm-hmm.
Basically, when you set up the sign-in button, if it's Android, if it's iOS, it's web, you pass in multiple scopes. So we show the user an expandable dialog with each line representing a scope. And also for the mobile context, especially on Android, they also approve the hardware permissions as well,
Mm-hmm.
that same single dialog.
So is there any reason to use the other Google account authentication process from the services? Like, it seems like it's better to use Google Plus, right?
So you mean the local account manager?
Yeah.
Oh, that's more of that's the current way, right?
Mm-hmm.
And now the Google Plus way gives you a lot more user information, so more about their profile, more about their connections. So you can make a lot more meaningful social app versus just knowing their email.
Mm-hmm.
So with Google Plus Sign, we provide you access to all those additional pieces of information about the user.
Okay.
So we recommend you use Google Plus Sign for that.
Cool, thank you.
Great presentation, really exciting what you're doing. My question is basically the same as what he had. Just want to make sure to clarify though. So my question is, if I start with a certain set of scopes and then I want to escalate the user later, like I want to start with a certain set of scopes that are very limited, and I escalate, do I have then 2 OAuth tokens that I'm managing, or is it a single OAuth token? Because I could see that if I'm having to manage multiple tokens on my app side, so is it a single OAuth token that will be resolved at the end, or is it multiple, and do I have to do work? Can you just talk a little bit about that?
So you will get 2 OAuth tokens. We recommend you keep the later one because it will have the greater set of permissions and revoke the older one, and then go ahead and use the later one.
Okay.
And we're also looking at how to make that a better experience.
Yeah.
So keep following our blog and our Google Plus page to learn more about how we're improving authorization and APIs.
Yeah, I built an app for GitHub, and I have like 400 OAuth tokens in there, and I didn't realize I was doing that. So that's something that, yeah, great.
Cool.
Thanks.
I like your app. This way.
So what about a sort of progressive enhancement? I wouldn't allow people to log in with any OAuth provider, but if they have a G+ account, get the additional capabilities. How would that work?
So when you mean any OAuth provider, do you mean outside of Google or?
Yes.
So we've seen a few solutions in the marketplace. Typically, it depends on which type of networks you're trying to target. If it's business-oriented product, if it's consumer-oriented product, if you have your own OAuth provider. But we think options is a good thing, but not too many, because that creates the paralysis of choice. So we're seeing usually, maybe 2 providers in a single dialog, depending on which are your 2 greatest networks, and you just can provide them as options. And then on your back end, you basically have a table of a user, and it's this social login versus Google social login, maybe username and password, and you can just kind of keep it as a unified record.
So I would have to have a sign-in with G+ and a sign-in with Gmail if they just had a Google account.
Oh, I see. No, so one thing that I hope I can convey is Google Plus Sign-In is the way we want developers to allow users to connect their Google account with your service. So think of Google as a Google sign-in. It's a Google Plus Sign-In with signing with your Google account. So you should use Google Plus Sign-In as your Google way to authenticate. If you want to, let's say, support GitHub, then you could provide that as a secondary sign-in option and combine the user accounts that way. Cool. Question?
Well, I think you might have mentioned this, but really simple question. When you mentioned that for the deep links, if you don't have the app, does Google Play do anything to carry that referring source through the installation process?
Yes.
Yep, absolutely.
Okay.
So on Android, if I'm on the Android app, the new beautiful Android app, I click that deep link. The user doesn't have your app installed. We'll take them to the Play Store. We'll prompt them to install it. When they're done, they'll get a notification saying, do you want to continue to that deep link? So they'll actually go exactly to the right deep link, and we'll pass the deep link to your app. Even on iOS, we help the user go to the App Store, and we help them get to the final deep link as well.
Okay, how does that work on iOS?
We can talk more about the
Okay.
specifics, but essentially we take them to the App Store, and we use the paste bin to get them as a saved link, and they can go all the way through. So mostly they get there.
Okay, thanks.
Cool.
I was wondering, how flexible are the actions or contexts? I know there's probably a standard set, but is there a way to extend that set?
Start at the beginning again, sorry.
Is there a standard, how flexible are the actions or the deep links, the contexts?
Okay, so the interactive post, the call to action labels. It's a fixed set. We have over 100 of what we've heard of the most common, and we're always up to add some more ones that you think would help a larger population. Cool.
Hi. Basically, it's very exciting to see the sign-in process to give access to developers for actual user data. When would you think that we'd be able to get access for like friend data, so we could build smarter algorithms for finding out friend affinity or content analysis and things like that off of, say, like the pages that your friends actually like on Google+?
So in the beginning, I talked about security and privacy. And the model we're building right now is the user has to authenticate, and we're being very conservative on what user data you get. So when a user does sign in, we allow them to give you access to their flat circles. And that includes the public Google ID, first name, last name, and profile picture. I don't know if we're ever going to go to that direction, but we'd love to hear your use cases and see how we can make them happen.
Sure.
Cool. I think we're done for time. I'll be around here after the talk, and of course we have our sandbox where you can ask me and the rest of the team more questions. Thank you, everybody.
Thank you.
games that are out there. You got Project Ingress, and you have a Field Trip, which isn't so much a game, but both of them are really tied to discovering the world around you. So I want a couple questions to start us off. First of all, what is the Niantic project? It is part of Google, right?
Well, we try to keep it a little bit mysterious, but yes, it is part of Google. We're kind of like a little startup in Google, and I guess the goal of the Niantic group is to explore these kinds of applications in mobile that use location and explore this area of ubiquitous computing, things that are telling you about the world around you, helping you explore, but without necessarily using an app in kind of a conventional sense.
Now, you have a history of working with startups anyway. I mean, you came from Keyhole with the Google acquisition of Keyhole and really became kind of the backbone of Google Earth and a lot of the other work that we've done. It really seems you have a passion for maps. Help us understand how both of those projects, Ingress and Field Trip put together, are helping Google's location information get better or helping users know more about their world.
Yeah, I mean, I love maps. Obviously, I came in 2004 with Keyhole and was the product lead for that part of Google for about 7 years. During that time, I used to daydream about other things that we could do with the mapping data and the resources. And one of those things was a game, and as smartphones started to proliferate, I felt like the time was right to tap into all of the mapping data that we have and to create an awesome game for mobile that would encourage people to really get out and explore their world. And that's really kind of the spirit behind both Ingress and Field Trip.
So let's talk a little bit about Ingress. What is the deal anyway? For those who haven't played it, how do you describe it? And what's the difference between the Resistance and the Enlightened, for those who don't know?
Well, the story behind Ingress is, it's a science fiction themed story that really puts a layer of reality onto the world around you. So there's a mysterious energy that's been tapped into in a lab in Geneva, Switzerland, and through the story of Ingress, you begin to learn a little bit more about that energy. It's called exotic matter in our world. And as it turns out, it's all around the globe, and it's concentrated in these places called portals, which often are pieces of public art or museums or historical sites. And you use the Ingress application on your Android phone to discover those places in the real world and then to tap into them. And you can mine virtual objects, you can interact with them, and you can try to take control of those locations for one of two factions, the Enlightened and the Resistance.
And so as a player, you pick a team and you go find these portals and you have to blow them up and use up your XM energy and all of that. Now, poor me, I find myself often trying to take my level 3 or level 4 skills. I just can't blow up a level 8 portal. When you look at Ingress, is there room for the novice player who's just starting it now or wants to get into it? Or have all the places basically been locked down by the hardcore players?
No, there's definitely room. One of the things that we didn't expect with Ingress was how much teamwork and collaboration would end up emerging. But we found that people really love getting together and playing in groups and having meetups. We're having one here in San Francisco this week, but we have them all around the country, all around the world. So it's a great way for a new player to kind of get into the game, would be to meet up with other Ingress players. And some of the more senior players really love taking a newbie under their wing and showing them the ropes and also helping them level up in the game and become powerful enough to start affecting the real global battle.
And you have something special going on here at Google I/O, is that right?
Yeah, there's kind of a game within a game. So we're doing two things. We're doing Operation Fan Out, which is all I/O attendees are able to take part in that. And if you level up during I/O, you get a really cool Ingress t-shirt. If you show up as a level 8 already, we have a special level 8 t-shirt for you. And we have another thing that's open to non-I/O attendees as well. It's called Operation Bowstring. And that's being played out across San Francisco, and it culminates in an event on Thursday night at Cupid's Span, which is down in the Embarcadero, with a meetup over at the Alchemist bar later.
Now, Ingress right now is Android only. Field Trip is available for both Android and iOS. How do you see that the users of the different operating systems use the apps differently?
Yeah, I guess if you were to look at Field Trip, it's available for iOS and for Android. It's rolling out globally today, actually. Initially, it was a US-only launch, and then the UK. There are subtle differences. We've noticed that Android users tend to spike on the weekends, and they're out using and so maybe exploring more than their iOS counterparts. I don't know if that means that Android users are more into exploration than iOS users, but yeah, there are small differences.
Should we expect to see even more products coming out of Niantic Project?
Well, you never know. I mean, we are looking at a range of technologies in this mobile space. We're very interested in wearable computing and what you can do with it. But the things that we're putting all of our energies behind right now are Ingress and Field Trip.
So I should expect to have Ingress on my glass like any day now, is what I'm hearing.
Well, I think that Glass would make an excellent platform for some awesome games. So we'll see about that.
Yeah, absolutely. Now, one last question before we wrap. Niantic project as a startup at Google. Do you have more freedom to do more things? Like, what does that mean to be within Google, but also be within this tiny little enclave?
It was a great opportunity. It was set up by, with Larry's support so that we could pursue this area and, across kind of ideas and concepts from mobile to social to geo and try to weave those things together in new ways to explore what could be done to create apps that were really native to kind of the new wave of devices that will be coming, wearables.
Excellent. Well, I appreciate you taking the time, John. I know we've been real quick jumping into Ingress and Field Trip. For those of you who haven't downloaded those apps already, definitely check them out. We have more exclusive GDL.io content coming. We'll be talking about Google Now with Bears Gultaken at 3:25. So please stay on the streams and enjoy your sessions. We'll be right back.
Hi everyone, welcome to Actions in the Inbox powered by Schemas. I'm Shalini Agarwal, this is Claudia Cherubino, and we are really excited to be here today to tell you about a cool new feature that we are launching in Gmail. So let's start with a show of hands. How many of you send emails to your users asking them to do something? All right. How many of you care if your users actually do what you ask them to do? Perfect. Okay, so then you know that today we have a problem. Email is not efficient. It's like a scavenger hunt trying to do anything. For every email that you send your users, they have to read the email, figure out what they need to do, open a bunch of tabs, decide to take the action, and then do it. It's a lot of steps, and each email takes too long to process. That's even if the user decides to open the email in the first place. So let's go ahead and see this inefficiency in action. How many steps do you think it takes to rate and review a restaurant? First, you get the email. Second, you click on it, you read it, and you decide that you're going to click on a link. Third, you click on the link, you open the tab, and you wait for it to load. Fourth, if you remember your login information, you enter it here. And fifth, you do what you wanted to do in the first place, which is rate and review the restaurant and click submit. And then sixth, You close the tab, and if you remember, you go back to your inbox to process the next email. It's a very cumbersome process, and users get lost along the way. This inefficiency is only made worse by the sheer volume of email. As a product manager at Google, I get a lot of email. In fact, I counted, and in the last week alone, I received 2,124 emails. During this session alone, over 100 million emails will be sent. Your users are out there doing this scavenger hunt right now. Between email inefficiency and email volume, it's no wonder that a lot of emails go unanswered or unopened. You are probably tracking your own stats and see some of that today. But today, we are introducing a solution. We're adding actions to the inbox, making email smarter. Now, your users can get the gist of what you're trying to tell them and take action without ever leaving the inbox, without even opening an email. So, remember the 6-step process that we talked about? Let's see what that looks like with actions in the inbox. With actions in the inbox, we're taking that 6-step process and turning it into just 2 steps. We'll take a look at it with a demo. Last night, I ordered food from India Clay Oven and via Seamless Web. Today, Seamless has sent me an email asking me to rate my experience. Seamless has added actions to their email. So I see the email, Seamless, asking me how was India Clay Oven, and I get this handy button on the right-hand side that says review. I click on it, and I get this beautiful overlay that gives me the key information I need, India Clay Oven via Seamless, a beautiful picture from the restaurant, and a quick rating widget. So I can go ahead and click it 5 stars and enter a comment. Spice-tastic. We'll definitely be back. Definitely order again. And I hit post review. On the back end, Gmail has now sent this rating to Seamless, and I'm done. That's it. 2 steps. Now that's efficient. Oops. Let's go back. So we've enabled actions in the inbox through the power of schemas. You guys already know about schemas. They're an important part of the web today. You add markup to your websites to improve your search results. Now, you can add markup to your emails to enable these actions directly from the inbox and deliver them to Gmail. You can deliver a slice of your app to Gmail starting today, a product with hundreds of millions of users. Over the coming weeks, we'll be rolling out 4 different kinds of actions. We've already talked about rate and review, and now we'll talk about the one-click action, the RSVP action, and the go-to action. And, of course, we'll do it through demos. So, as you can see here, I've gotten an email from Google Offers about an offer from American Apparel. Because they've added schema to their emails, I get this one-click button that says Get Offer. Because I shop at American Apparel all the time, I'll go ahead and click the offer. One click, without ever leaving the inbox, I save the offer. Now, let's go over to offers.google.com, reload the tab, and there it is. I didn't even have to open an email, and I've been able to save my offer. Now, one-click buttons are my favorite action because they enable the widest variety of use cases. So let's look at a second demo of the one-click action. I use a service called Esna to manage my communications. And they've sent me this email telling me that I have missed a call from Claudio. And because now seems like a good enough time as any to call him back, I'll click this one-click button that says dial. Now, on the back end, what's happening is that Gmail has notified Esna that I want to initiate the call. And they've initiated the call between Claudio and myself. As you can see, my phone is ringing. I'll go ahead and pick it up. I don't know if Claudio is going to pick it up. We'll find out.
Probably not.
So he'll be receiving a call any minute now that I've picked it up. And there we go.
Okay.
Woo! Hey, all right. One click directly from the inbox. The third type of action is the RSVP action. As you can see here, Clarence has invited me to a taco night, which is my favorite type of event. And I get, because Calendar has added actions to the inbox with some markup, I get this RSVP button right here. Similar to rate and review, when I click on it, I get the overlay showing me the most important information, the fact that it's a taco night hosted by Google Calendar. It's on Tuesday at 7 p.m. It's at Tortilla Heights, and one person's already going. I don't miss a taco night, so of course I'm going to say yes, and there it is. I'm done. Let's go over to Google Calendar and make sure that my response was recorded. Here it is, taco night. I click on it, and there it is. Yes, I'm going. The fourth and final type of action is the go-to action. The go-to action is reserved for the most complex type of actions, which really cannot be handled from within the inbox. So flight check-in, as you can see here, the last email from Oceanic Airlines, I get a button on the right-hand side. They've used the go-to action. When I click on this button, it'll take me to a deep link on their website to check in, where I can select my seat, I can tell them how many bags I'm bringing, and whatever security questions I might have to answer. And that's it. Those are the four type of actions. However, sometimes no action is required. Sometimes your users just need key information from you. So for these situations, we've added structured interactive cards. The first one that we're adding is for flights. So when users get flight confirmation emails, check-in reminders, or updates, they get this beautiful card at the top of their email that gives them the airport details, the flight details, their connection times, as well as a real-time layer on top of that, telling them if their flight is on time, delayed, or hopefully not canceled. Flights is only the first card we're adding. Over time, we'll add more cards, such as events and hotels. So, by adding schema to your emails, you can enable these actions and cards in Gmail. However, you can also enable experiences for your users across Google. When your users use Google Now or Google Search, they will get the information that you send them at the most useful time and place. I'll leave you with one last thought. This is a developer platform, and the power of it really comes in how you decide to use it. We'll be rolling out these features over the next few weeks and be adding more over time. Now, I'll hand it over to Claudio to tell you how it all works.
Thanks, Shalini. Well, thank you. I haven't done anything yet. Sorry. So I'm very happy to be here. I work in the developer relations team for Google. And one of the questions that I always get when talking to developers like you is, how do I get my app into Gmail? It's a common request. I understand why you want to be in Gmail, why you want your app in Gmail. And today, we're finally introducing a way for you to do that. And what we're introducing is super simple. So not only we're giving you this opportunity, but we're giving an opportunity in the easiest possible way. All it takes is some markup that you have to add to your emails. So you have your emails. You probably already send emails to your users. So you have an HTML email with your content, your regular content. you don't have to touch it. You don't have to do anything with the content you're already sending. All you have to do is adding some markup, some extra markup to the same emails, and then clients will render that for you. So you add some markup at the top of your email, at the bottom of your email, in the middle, somewhere in your HTML, and clients like Gmail will render it for you. I said clients like Gmail, and I will go back to this, because this is going to be an open platform, and Gmail is starting to launch this in the coming weeks. But we expect other clients to implement this technology too. So what happens when you add your schema is that we render it as the corresponding button or drop-down or piece of UI or card, whatever corresponds to your markup. And one important thing to note there is that the UI is consistent. So Gmail will always render an event reservation, RSVP drop-down with the same UI, regardless of who's the sender. So your user will not be confused by messy UI or a piece of interface that do not really belong to Gmail. The client controls the experience, and that's really important for the users not to be confused and to use this technology. So you add the markup. It's going to be a few lines. I'm going to show that. And we will render it. And the one thing that I just mentioned is that this is based on an open platform. We're building on top of schema.org, which is a broader initiative, open initiative for a vocabulary of entities that we're building on top of. So the types we're defining, the types you will use in your markup, are the same types that you're already using if you know about schema.org. Well, let's show an example. This is how it looks like. And I actually have 2 different formats, because we support 2 different formats for this markup. The one on your left is the standard schema.org microdata. If you know about schema.org and semantic web, you've probably seen this. You've probably implemented this. You've probably added this to your HTML. It's pretty easy to understand. It's an XML-based language. Actually, what you do here is that you add some properties to your HTML. And these attributes will tell us what the item is. And in this example, we have an event. And then what properties the event has. The start time, the end time, location, and so on. The same thing can be also expressed with a different format. There is also another open standard. It's called JSON-LD. It is not XML-based. It's obviously JSON-based. And we found that this other format, this alternative format, is easier to read for humans. There are libraries to write both, so you as a developer can probably easily write both. But for a human, the one on the right, it's easier to write. So as you can see, those 10 lines and the ones on the right are just easier to read, tell us that this email is about an event. And that event starts at this day, ends at that date, and there's also location. And we will render it as an event should be rendered. So we have different markup for the 4 different types of actions in structured data like flights. I will show you an example of each of them. And I would say that all of them are like shorter than 10 lines. At least, well, no more than 20 lines. So we have four different types of action, and we'll see them one by one. But all of them follow the same structure. So you will see that there are common sections every time I introduce a new type. And the sections are essentially 3 sections in each markup. So we usually have a section at the top that is about the entity you're defining. And that is, for instance, in the example we just saw, to describe what the event is or what the flight is. So the entity you're talking about. And that has properties that you can see from schema.org, from the vocabulary we're using. And after the item definition, we have our first addition to the schema, which is actions. Actions have different types and have different names. So if you want to implement the RSVP action or a review action, those have different types. And you have to specify that there. But then, in the third part, you describe what the handler is. The handler is used to tell us what to do with the action. So you've seen Gmail sending requests to you when the user performs an action. Those requests will be sent to a URL, to an endpoint, to a servlet, to somewhere you tell us. And that is where you define it. Let's go on with a real example. The first type of action I'm going to show you the markup for is one-click action. This is what Shalini called her favorite, because this is super flexible. Gmail renders these one-click actions as buttons. When the user clicks on the button, Gmail will send a request to your endpoint. So how this works in the microdata, in the markup you see, in this example, I'm showing an email that is about a movie. And one action you can perform with one click is add to your queue. So at the top, you will see some information about the movie title, and maybe the cast, maybe genre, all the other properties you want to add. And then we have the action. The action in this case is called save action. There will be a list of all the supported actions in the docs that we're launching right now. So at the end of this talk, I will give you a link to the documentation we're launching. But this action is called save action. You can customize what the button will look like. So you can customize the label for that button, and we're going to call it add to queue. And then you define the action handler. In this case, what you need to do is just say, when the user clicks on a button, I want a post request sent to my URL. So you send us this markup. You set up a servlet that can handle this request. When Gmail sends you a request in the background, you will have to handle the request, in this case, add the movie to the queue, and respond with a standard HTTP response code. So if the action is performed correctly, you respond with a 200, and Gmail will show it as successfully executed. If there is an error, for instance, the request is invalid, you respond with a 400. Standard HTTP response code. You know about that. So this is a common structure. Entity, action, action handler. And you will see the same structure in the second type of action we are defining here. This is RSVP action. The main difference here is that Gmail knows that an RSVP action deserves a special UI, which is not a button, but it's instead a drop-down with some information about the entity, which is an event, and then buttons for you to reply. You as a developer can choose if you want yes, maybe, no, all of them, just yes and no. You can customize the look of this small drop-down. And once that is rendered, the result is always the same. Gmail renders it. The user clicks on one of the actions, one of the buttons. Gmail collects the input from the user, sends that as a post request to your endpoint with the parameters you want. You process it and respond with the appropriate response code. So on your side, you will still have to implement some servlet, some backend that can handle this. And then Gmail will talk to this directly. Now that you know two of them, this is going to be super easy to understand. Rate and review. You saw that in the first demo. We showed Seamless, which is one of our partners, using this technology to review restaurants from the inbox. What you can customize here is the scale. And in our case, that was 1 to 5 stars. And you can also tell us if you want an optional text feedback or if you want a required text feedback. It's up to you. Some companies need that. Some websites need both a text comment and a rating. Some others do not. Of course, the easier it is for your users, the better it will be, the more responses you will get. So that's basically it. You configure it, and then same thing. You get a request from Gmail, you respond to it, and that's it. And we render the response. The only action type that is slightly different is the go to link, go to action. This is rendered as a button with a link. In the case, we talked about check-in. Check-in is not an action that can be performed easily in the inbox. You have to select seats, buy upgrades, select food, meal, whatever. You have to do many steps, and that doesn't really apply to inside your inbox. So we can take you directly to the page where you can do that. Another example, and we have it here, is a request for you to sign some documents. The documents are not sent in the email. You can click on the link and be brought to the page where you can sign the documents. So we strongly recommend you to use and implement the in-app actions like RSVP, review, or one-click action, because with those, users do not have to leave the inbox. For all other cases, you can use a go-to action if that is the best user experience for your user. Of course, we plan to add more actions, and we want to listen from you about what you think might be useful to add. So we'll talk about it later, but we want to know what you plan to do with this. So we saw all the 4 types of actions. The other thing we're launching is structured data for specific items. And we talked about flights. A flight is a easy to understand piece of structured data. A flight has some specific properties. So we know about those properties. We know that a flight has a departure airport, an arrival airport. If you mark up those properties in the emails you send, then we can show that as a card in Gmail and in Search and in Now. We can also add buttons to that, like check-in if you want. But another important thing here is that Gmail will use the markup you send us to show the card. But also Gmail will update the information for a flight once we know that that is a flight with live data. So you send us information about a flight that leaves tomorrow at 8. If tomorrow we realize that the flight is delayed, Gmail will know that. And when you open the card, you will see the live information. It will say that the flight is delayed to 9. And same thing will do the other properties, like Google properties will do. So we have these 4 types of actions and flights. And you might have recognized some names in the slides that I showed you. That's because today we're launching with many partners. We've been working with partners in the past few weeks and months. And today we're very happy to have many, many partners ready to support this technology. You probably know and use some of these products. Some of these names are here at Google I/O and would be very happy to talk about their integration and their experience with this. They are upstairs on the 3rd floor in the Chrome and App Sandbox area. And after this talk, Shalini and I, the rest of the team, and the partners that are here, will all be upstairs for you to talk about this. So if you want to know more about this, please join us right after this on the Chrome and App Sandbox area. So okay, you know about what you can do. You've seen what other people have done. You might wonder, how do I join this? How do I do this myself? Well, first of all, there is the documentation we're launching right now. It's probably live already. And that documentation is at developers.google.com/gmail/schemas. So you can go there and find all documentation about all the types we support, all the actions. There are examples, there are tutorials, anything you need to get started now. And I want to stress this. You can start now, because when you go home tonight, you can test this yourself by sending emails with markup to yourself. This is a very, very easy way for you to test it. So we care about user experience. So we need to make sure that what lands into production, what lands into everyone's inbox is safe. But if you want to test it yourself, you can just send emails to yourself, and those will be processed and rendered. So you have an immediate, easy way to test it now. Once you test everything, and you have a compelling use case, and you want to launch this to production, please go back to developers.google.com/gmail/schemas. There is a page where you can sign up. At that page, you will find a form where you can tell us about your use case. And you can tell us about how that works and what is the advantage the user have. Because what we want here is not just to add buttons everywhere, because that doesn't really help the users. What we want here is to add exciting use cases, exciting features, better ways for your users to do stuff inside Gmail. So please get back to us. And we promise to review your application and get back to you as soon as possible. We promise to be very quick. So everything is at developers.google.com/gmail/schemas. And with that, I think that's it. We showed you everything we wanted you to know about this for this launch. I just want to remind you that we're going to be upstairs after this talk. The whole team is going to be there. But we still got 10 minutes for questions. So Shalini and I will be really happy to get your questions. Thank you. Do we need microphones? Can you step to the microphone? I think it's going to be recorded. So yeah. It's actually live streamed. Hey, Mom.
So we have a service that sends out event recommendations to people, but we've tried really hard to make sure we don't overwhelm people's inbox by bunching those all together, so you get 5 or 6 recommendations in one email. Can we have more than one action associated with an email, or do we need to send a single email for a single entity that can have an action against it?
So right now, what we're going to launch is a single action, but that can be related to a group of things. So the action, the single call to action is unique. 1 per email. But the entity can be actually a group of entities or multiple things. Of course, the action then has to either refer to one of them or to all of them as a group.
You showed some interesting examples of cards that sound like they're mapping to specific actions like rating or RSVPing. What is the capacity for more free-form customization to build sort of our own more customized type of forms that may be presented in that format?
Right. So over time, we'll be adding more types of actions, but right now, there's not that much. The customization lies within the box that you saw in terms of, can you, for RSVP, can you say yes or no or maybe, or what are the options? And the reason for that is that we want to make sure that we provide a consistent user experience, because if we allowed the UI to be completely customized, every email would look different, every box would look different, and it would again be difficult for users to figure out what to do and get things done. But we definitely want to hear about your use cases, because we do want to add more types of actions.
I think the bottom line there is that we want to add more actions, and we want to talk to you about them, what you actually need. But we need to find the fine line between adding a new action and allowing everyone to do anything.
Thanks. Hi. If Outlook.com or Yahoo Mail wanted to add schemas, could they?
You mean add to their emails, or?
Yeah, so you could actually do the same kind of things. So if I write one email with schemas, then it would work in Outlook and in Yahoo Mail.
So as I said, this technology is open, and we actually would like them to support this.
So it is open?
Yeah, it is open.
Oh.
It's based on schema.org. And we are in talk with some other companies. Mm-hmm. So some other big names know about this already. And then, of course, it's up to them to implement it or not.
Of course.
But yeah, it's open. That's a short answer.
Hi, what other applications other than Gmail will these actions become available within the Google product offerings? For instance, voice, or Google, will it tie in with Google Voice? Obviously, Google now has access to that information. Are there other places we should look for to be able to provide cards?
So right now, this schema is supported by Gmail, Search, and Now. And not all of them support the same entities and the same actions. So the first step for us would be to have all of them support the same entities and same actions. Of course, it makes sense for each client. Another Google property that uses schema is Google+. So we're also standardizing the entities we support together with the Google+ team. And we realize that schema helps the web, helps other properties. So we're adding schema support to properties that, where that makes sense. So far, we have identified these 4, so Gmail, Search, Now, and Plus. But if it makes sense for other properties to support schema, we'll be really happy to do it, and everyone at Google will be.
I guess my, for instance, would be the ability for not only Gmail to be able to show a card, but for other applications within Google to be able to take the same action. That's what I understand the schemas generally, could be parsed by anything. But from an action execution standpoint, you're saying that's still underway or not necessary?
It's underway. We're definitely thinking about adding actions to other properties.
Okay.
One, let's say, implementation detail is that we share the parsing technology. So, at Google, of course. So it's easier for other properties to use it.
All right, thanks.
Thank you.
Hi. In your example, say, where you reviewed a restaurant, and at the end of it, you're done, but the email's still in your inbox. Is that going to be archived automatically at some point?
So right now what happens is that once you complete the action, the email is marked as read. We do not auto-archive the email at the moment. If we see that as a strong user request, we'll think about it. But right now, as we roll this out, we want to be sure that users understand what's happening. So that's not going to happen right now.
Hi, I saw screenshots of the list view, and I saw a card in a body view, but do the other buttons appear in the body view as well? So for example, like do the review.
Oh, you mean when the email is open?
Yes.
Yeah. So all in-app actions will appear in the body view as well.
Okay.
So the one-click action will appear, and rate and review has a nice card just like the flights does. RSVP has a nice card just like the flights does.
Got it, thanks. Sorry, one other question. The go to action button, building on the previous question, does it show completed even if you have to go to an external website to complete the action? Or does
the go to action doesn't really have a completed state.
Okay.
So it doesn't really change.
All right, great, thank you.
Hi. For the developers that are building on top of Gmail, like third-party clients, how can we make sure that these emails are actually useful to the user? And do you have any help for the developers to implement the same type of actions depending on the schemas?
Well, one thing is that the vocabulary, the schema, is public. So in the documentation, we explicitly say which types we support, and all the additions we added, like all the new things we added to the schema, are being added to schema.org, so that the public vocabulary, or at least are being considered by schema.org. Okay. So then on a third-party side to support this, what it takes is extracting the markup and supporting those specific types. Then the rendering.
Yeah, do you have any specific guidelines for how it should be rendered and how it should behave?
I would say not really, because what we want is that the user interface is consistent within the client. So for Gmail, of course, we know how that should look like, but another client, like the same drop-down we use for Gmail, might not be the best UI. So we will not ask you to implement any specific UI. Okay. And the only recommendation is, which is like a standard recommendation, is to make sure that that provides the best user experience and matches the consistent user interface.
If we have is there a developer support group that we can talk from the client side, not from the sender side?
You mean as a user that gets this actions?
Yeah. Well, for the third-party developers who are building email clients on top of Gmail, how can we get help from you?
So we have a page in the docs that also says that. But as we're doing with many other products at Google, we decided to support developers where they already are, which is Stack Overflow. Okay. So we're there. Okay. And another thing that I was advised is that is my Google Plus handle. Reach out to me directly. I'll be really happy to talk to you, like all developers, and I'll point you to the correct resource.
Thank you.
This is a quick question. I was just wondering if you guys are
looking at bringing this to the mobile interfaces, so these actions on the iOS and the Android apps?
Yeah, so we are working on mobile as well, but it'll take time to get out.
Okay.
I agree that it's very useful on mobile.
How do you manage the authentication? Because all the action comes in an email that can be forwarded or anything. How do you manage how do you identify that the email you sent the action is completed by the person that you intended to do the action?
So we require emails to be signed, DKIM or SPF, to be signed so that we know who the sender is and we can guarantee that the sender is who the sender pretends to be or says is. And at launch, what we're doing right now is that we have a whitelist. So you as a developer, in order for your markup to be shown to all users, will have to be added to the whitelist. So we will have you to talk to us, tell us about your use case, show us what you do. We will add you to the whitelist. Then we know who you are. You sign your emails, and that proves that you are who you say you are.
Okay, just one other question. Are you considering more complex actions like kind of rating, but for e-commerce, when you rate that you bought something, but in the action maybe you are confirming that you bought that item, and that could cause a charge to be billed to the seller? And sometimes you can write positive only if you bought the item. Some logic inside the action. Are you considering that cases?
Not at this moment, I would say, but yeah, that's another use case we would like to talk about. Let's talk about it later if you're still around. Thank you.
Sort of related to the last two questions about lack of mobile and another need for degradation. If the recipient is not in a supported mode or the sender is not authenticated, is the degradation just that the actions don't show?
Yeah. So essentially, we're just being ignored.
And another question is, does that affect the SMTP envelope contents at all? You know, for like enterprise use, none of this is going to be archived as part of the email itself, right? Or yes?
Doesn't affect anything.
So,
I mean, it's part of the HTML body. So it's like extra markup in the HTML body, unless there's some other part where that is stripped or prevented or blocked or anything. We don't do anything to prevent that. So it shouldn't affect it.
It should get delivered like any other message at that point.
Yeah. Thanks.
Recently, you added a feature in Gmail where you can add to calendar. Does that use schemas?
There are two things there. The add to calendar or the integration with calendar that you saw today and you will see in the next days are based on schema. That part is also uses some intelligence data, because that is, I think what you're talking about is the feature where Gmail understands you're talking about a date or an event, right? So that is actually based on some other machine learning things where we try to understand that email is about an event invitation.
Gotcha.
If we get that, because that is not really in the email. That can be triggered by me sending an email to you with no markup and saying, hey, can we go have a beer tomorrow?
That's what I thought.
So yeah, Gmail will understand that with machine learning technology.
Thank you.
Thank you.
Great. I think we have another question.
I have a question. You have, there's Gmail gadgets. I was wondering if you were thinking of, in the future, of implementing a way to launch a Gmail gadget from these actions.
I don't think we have any plans to do that.
You're talking about the gadgets on the right-hand side of Gmail?
Okay, sidebar gadgets or contextual gadgets?
No, the Gmail gadget.
Yeah, there's both. There's the full pane view that you can get, and then there's also sidebar gadgets. I was wondering if there was a way to interact.
Right now, there's no plans to do that, but tell us about what you'd like to do, and we can always...
Widgets.
Yeah.
Sorry.
Okay. Yeah, no plans. If there is a specific use case you have in mind, let us know, please. Thank you.
All right,
Well,
I think we're out of time, so
yeah.
thank you very much.
And
If you have any questions, again, we'll be in the sandbox
yeah, we'll be
area.
upstairs, third floor, Chrome and App Sandbox.
Google Now.
Yeah, go ahead. We'll jump into the slide deck and have a conversation.
Sounds good. So we started Google Now to help you at just the right time by giving you the information you need right when you need it. But before I start and talk about Google Now, I think it helps to think about how search has evolved over time to lead us to where we are now. So we started in 1998 with the concept of keywords. And when users type in a keyword, our users were delighted to find all of these links, the 10 blue links on the web. But of course, immediately they started asking for more. So we started adding things like images and videos so they get a much richer experience when they search for something. And recently we announced the knowledge graph. The knowledge graph is our ability to understand semantically about things, places, and people, and the relationships between them, so we can answer questions directly and in a lot more detail. And of course, afterwards came mobile, right? With mobile, it's really, really important that we understand conversation, and it's really important that we understand natural language. So that's what we focused on, and then we launched it and as part of Google Now. If you think about both of these directions, it's all about giving you the right answer really fast when you need it. Especially with mobile, giving you the answer fast right away is very important. And Google Now is a great evolution into this next step. It gives you the information you need before you even ask. So think about it as trying to understand your context and giving you the information that's relevant for that context. So we think about Google Now as a way to give you just the right information at just the right time. It's supposed to be very contextual, and if you take a step back, it really fits in well with what we want to do in Google. At Google, we want computers to do all the hard work so you can focus on what matters to you most. Google Now embraces that and tries to use the power of Google with thousands of computers and also have this powerful machine that's very contextual, your phone, that you have a personal relationship with, and combine the two to give you the information you need at just the right time. So it helps to have users walk through a day of life in Google to even visualize what Google Now does. And the first step is Google Now helps you organize your day. So imagine that you woke up in the morning and you're sipping your coffee. Chances are you care about what to wear that day and you care about the weather. So we'll just have the weather ready so you know what to wear, and if you need an umbrella, you can take the umbrella with you. As you're getting ready to leave home, we'll tell you about traffic. Chances are you care about traffic, of course, and you know that you need to leave a little early if there's traffic on your way home, on your way to work. And when you get to work, the types of things you care about are when my next meeting is. So we'll make sure that we tell you when your next meeting is and tell you that you need to leave now so you're not late. We don't want our users to be late ever. So we're very proactive about telling our users, taking into account where they are and where they need to go, and taking into account the traffic. We also want to make sure that we remove friction. As you're going through your day, there's a lot of different things that you have to worry about. And we want to make sure that we assist the users when they need assistance the most. Travel is one such case. When users are traveling, they need a lot of information. They'd like to get a lot of suggestions for their travel. So Google Now is a great assistant for travel as well. For instance, when you're traveling and you're waiting for the train to come, we'll tell you that here's the next train. It's going to arrive in 5 minutes. So you know that you need to hurry up a little bit to get to your destination. Or when you arrive at your airport, we'll have your flight status, so you know that you can take your time and grab a bite before you get to your gate. We'll also have your boarding pass ready, and when you take that flight and land at your destination, we'll help you get to your hotel. So that's one less thing to worry about. Another thing that we really want to do is we want to help you discover new things as well. So, for instance, when you're at a symphony with a loved one and your mind is back at home about the sports team that you care about, we'll keep you updated about live scores. And when you're traveling and you are wandering around, we want to make sure that you don't miss that cool photo spot that everyone is taking pictures at. So we'll show you where that photo spot is. And as you're getting ready for the weekend, we also want to help you find cool things to do for Saturday evening. We'll show you comedy shows or concerts that weekend. So that's broadly what Google Now does. It's very contextual. It tries to understand what you need and try to provide you the information before you even ask.
And, having looked at the keynote today, we looked at Amit and some of his vision. He called it the Star Trek computer to bring on the future of search and getting the content to you at the right place at the right time. And some of the words he talked about was assist and really trying to find the next step to be able to get it to you exactly when you need it. I had this interesting experience when Google Now first came out. It's been about a year. And I remember I was at home one Saturday in the middle of the day and my phone buzzed and it said, you need to leave right now to get to, and at the time I called it unknown location. And it said, you have 25 minutes. And like I said, what are you talking about? And I realized every Saturday around that time, I had gotten in my car and driven to take my kids to baseball practice. And somehow Google knew this. And it alerted me without my having to tell it anything that I should go immediately if I'm going to get there on time, because I always go on Saturday at that time. And that was my aha moment, that Google Now was really impressive. From a geeky perspective, we call it persistent implicit search. It's constantly searching for you, and you might not explicitly tell it what you want, but it's always looking on your behalf to find you the right content at the right time.
That's right.
And so what is your view on that in terms of the future of search? How is Now kicking that off?
So we have all of this, you have all of this interaction with your phone, right? You carry it with you everywhere you go. But yet, it's very, very important for us to understand that and then help you right at just the right time. So in your case, for instance, being able to tell you that, hey, there's traffic, you should leave now because you're always there at the time, is the aha moment. For a lot of our users, things like when they search for a restaurant to go to and then they hop onto their car and the directions to that restaurant is right there. These little things are these magic moments that our users really love. If that answers your question.
Yeah, absolutely. And one thing you talk about Google Now, originally it was all on mobile, and it's really having glass. It's been a really impressive thing to find the content exactly what you want with just a swipe of the finger. But we saw some really incredible additions today to search. And maybe you can talk to me a little bit about how some of that voice search is coming to either Chrome on the desktop, but as well as the new cards that came out at Google I/O. Yeah,
so the voice search coming into Chrome is quite exciting. We announced that with what we call a hot word, you can just, start talking to your desktop or laptop right away. All you need to do is when you're on google.com, just say, OK, Google, and start speaking what you'd like to get. We think that's really, really exciting, and it's again in that evolution where the Star Trek computer is slowly becoming real. You need to be able to talk to your computer and have it do things for you. So we think that's really exciting, basically bringing the power that we have with our devices to also other platforms like the laptop and the desktop. In addition to that, we also announced that we're going to have reminders on Google Now, which I'm really, really excited about. We want our users to rely on Google when they need to be reminded of things. So if you are going to, if you need to remember to buy eggs when you go to Safeway, all you need to do is just say, remind me to buy eggs at Safeway, and the reminder will be there contextually right at the right time.
So when I get next to Safeway, it'll say, hey, buy eggs?
When you're at Safeway, it will say buy eggs. That's
nice.
right. And also because Google now semantically understands the locations that you care about, you can also say things like remind me when I'm at home to do something, or remind me when I get to work to talk to my colleague. So it's basically time-based reminders and location-based reminders. Another thing that's really, really important is that we're also enabling an integration of reminders in your search experience. So let's say you're searching for a movie that's upcoming. On the knowledge graph, you'll be able to see a button that says, remind me when this movie comes out, and we'll remind you when that happens. Or when you are searching for a date, when are Oscars? When you see that date, also you'll have a reminder to be reminded when that becomes available.
Now, I think one of the things we talked about was that Google Now really started as a 20% project here at Google. And for those who are a little familiar with Google's culture, that's when an employee essentially dedicates one day of his or her week to a new project and focuses on it all the time. And what that really means is usually an employee has a full-time job and another job, which is the 20%. Can you take me through that? Like, how did that become a 20% project of yours and then consume you fully?
Yeah, absolutely. It's really exciting. Even though we're betting really big on Google now, it had its humble beginnings as a 20% project, as you said. It started when our engineering lead was thinking about how do you make sense of the location information. And then he launched the location history analysis, basically understanding that we show our users, here's how much time you spend at home and at work, and here are the places that you go to frequently. Then we gathered a group of engineers, volunteers, volunteering their time in addition to their full-time job, and we started putting demos together. These demos got our executives really excited. And when we went to our executives and said, hey, here's something we have, they were so excited that they said, great, launch it in a few months. We have I.O. coming. And the rest is history. We launched it in 4 months, and the reception has been great. We're really
coming
excited.
up on that 1 year. I mean, it's amazing to think that it only launched at I.O. last year.
That's right.
To me, it felt like we've always had it. I've been an Android user. We've always had the cards. It's really easy to kind of look and see what the sports scores are. Mm-hmm. And it learned really quickly. It says, hey, this guy likes, I like the A's, you like the Giants. We can still be friends. But you still get to see that content, the sports scores and the stocks and the news and the weather. And it's been really interesting to see that kind of recommendation pop through and get exactly what you want. Mm-hmm. Now, I.O. is a developer conference, so I'm going to ask you a geeky question again.
Please go ahead.
You look at this, it's really got to pull from a lot of different places. You talked about location history being the first one. So you've got to pull from the Directions API, Calendar API, Google Translate API. How did you go about looking at all of these different APIs to make one cohesive service? Mm-hmm. And did having those APIs in play make it a lot easier and a lot faster to ship? You only had 4 months.
Absolutely, yes. So we have a huge benefit of sitting on top of all of the Google services that our users use and love every day. So when we started, we rely on a lot of core, core services that Google has. Location is one of them, but also calendar, email, and the searches that you have. So we have the benefit of all of these teams thinking really hard about those instances when users use those products. And what we do is we bring information from those products to the user proactively at the right time. So we did have a lot of benefit from all of those APIs that are available to us.
Right, and I think what I saw with Google Now, you look at today's keynote, and a lot of it was about having the same environment on desktop, on mobile, on tablet. Android introduced the capability to dismiss notifications across each of these devices. Is that something where we're looking at having a unique, a similar interface on each of these devices as well with Google Now?
That's right. So we announced availability of Google Now on iOS, iPhone, and iPad recently. So we want to make sure that we bring our services to where our users are, regardless of the platform. So starting with Android, we brought it to iOS, and now part of it is also available on the desktop. So we want to make sure that our users get the best of Google, regardless of where they are.
Now I'm going to bring up the Giants one more time,
sure,
but in a different way. So a few months out of the year, I'm intensely interested in a couple sports teams because I'll play fantasy football, right? And so I'll find myself constantly checking on the scores for the Washington Redskins and the New York Giants because I've got a couple of their players. And then after that, I don't care. And so how easy is it for somebody to dismiss something where Google Now infers an interest, but it might be a temporal interest? What kind of information can they do to help teach Google Now and make it better?
So we do various things. We try to understand the likelihood that you're interested in something. So things like time decay, for instance. The last time you were doing a search and you were engaging with Ace or Giants, if it has been a long time since you've engaged, then we'll take that into account in understanding whether you care about seeing that information. There's also things you can do, like dismisses, for instance. We'll learn from your dismisses. We give a lot of control to our users, so they can also tweak the cards that they're seeing. They can add more sports teams. They can remove sports teams. So all of those in combination are the things. Either implicitly we try to understand that was temporal, or explicitly you can teach the system by dismisses or saying, no, I don't want this anymore.
Now, is there a Google Now API? Is there a way for developers to tap into that and make their own custom cards, or ways for the applications to interface with that?
So we have a couple of partnerships that are already live. For instance, with United Airlines, when you check in, you'll have your boarding pass ready when you arrive at the airport. or when you purchase a ticket through Fandango, that ticket will be ready when you arrive at the movie theater. We also have a partnership with Zillow. If you're in the market for a home, we'll show the open houses in the area you're looking. In addition to all of this, today we are also announcing that with our select partners, they can mark up their emails so we understand whenever there's a flight or whenever they have a hotel or a reservation coming up. So all of those are ways where we engage with our partners to provide more information into Google to show to their users.
So what type of information goes into Google now to improve recommendations? You talk about location, you talk about possibly search history. What else does Google take from the different pieces that you're watching on the mobile phone to make your cards even more smart?
Right, so location is a core component, and we want to be able to help you, get to your next destination and tell you traffic about it. So location becomes a very core component of Google now. Searches are quite important, and we'd like to help you, continue researching, or we'd like to help you, get to your next destination because you've been researching that place. So search is another component. Calendar is really important, right? Because with calendar, you're explicitly saying, I have this meeting that I need to get to. So there are many things that we can help with that experience. So we focus on that as well. At large, what we try to do is we try to think about what are the instances in which our users need assistance the most, and could we predict and help in those instances and prioritize that way.
So I had an incident recently when I was traveling. I flew over to Paris and I opened up my phone, and first time I get Wi-Fi access, I look at my new cards, and it was really incredible to see how not only did the phone know what I was doing, but it had all this helpful stuff. I know your demo basically talked about places to take photos, and for me, I'm not really a huge photographer, but I appreciate knowing that. But it had stuff like conversions. It would say how many dollars a euro is, and other bits. What are the things that play into travel? Like what kind of really cool cards can come up when I travel 3,000 miles?
Yeah, so when you travel, there are a couple of things we show. We show you time at home, so you know when to call back home. We'll tell you things like conversion rates, the currency conversion rates. We'll give you information about translation, so you have a translation tool at your fingertips. We'll also show you attractions if you're new to that city. If you've been to that city multiple times, chances are you don't care about attractions anymore, so we won't show it. Also, we'll help.
How many times is a number of times? Is 3 a lot? Is 5 a lot?
5 is probably a lot, right? Basically, the way we try to think about it is showing this card to the user, adding value. And if you've been to a place 5 times, if you've been to London 5 times, for instance, showing you, hey, there's Big Ben, doesn't really matter anymore, so we stop showing it. We also want to make sure that throughout the process of traveling, we help with various things. For instance, if you were searching on Google a week before you go there about getting to a destination, for instance a restaurant that you're going to meet your friend at, we'll show you directions to that place when you're there. So it's basically a collection of things that we want to help you manage your day-to-day life, as well as little tools that will also help with the experience, in addition to helping you discover new content like photo spots nearby or attractions.
And we talked a little bit about the genesis of the product as a 20%. So I'm really intrigued by the amount of content that is flowing through mobile devices, the amount of mobile web tracking that's happening, the amount of mobile web browsing that's occurring. Would this project even have made sense in a world without smartphones? Like, would it even have happened? Like, what were those trigger points that says, aha, we've got to do this?
I think mobile is critical, right? Because mobile, first of all, it's a very contextual device. It has location in it. It's also connected and it's with you all the time. Another aspect of mobile is that users have this very personal connection with their devices. They're constantly using their device. I think mobile is key in helping us understand what your context is, helping us understand in what situations you need this type of information. So without mobile, I think this product would have been much less powerful.
Do you find sometimes that people confuse Google Now with voice search, and they'll ask you one or the other? Do you see them as being completely intertwined?
I think the whole search experience is we think of it as a whole. So Google Now is part of the Google Search app on Android as well as on the iPhone. You can search with your keyboard. You could also do a voice query and it will assist you with that query. And we'll also try to infer whether what your search is and try to show you information. So I see all of this as a collective assistant trying to help you, either before you ask or when you ask. We want to make sure that we have the best experience for you.
Right, and I think you put on a key word, which is assist. You know, there's assist and there's anticipate. You know, anticipating what you're going to ask before you even ask it. You know, going back to voice search, I'm a parent. I've got 3 kids that are 5 and under. And for them, every screen should have everything in the world available to them. They can't believe it if they can't find exactly what they want. And I'll often run into my daughter holding up a Nexus 7 tablet to her face and saying, Google, show me videos of sea turtles.
That's great.
And if it doesn't load, like if there's a problem with the cloud, she's like, ugh. She's like, Google, show me videos of sea turtles, until they all come up and, you know, she's on her way. And so it's just been, you look at the evolution of it and the fact that we're able to take all of these things for granted to be right there is just stunning. And I look at Google now with its cards and the fact that it is only a year old and how far we've come. And it's been really incredible to watch. I definitely appreciate you coming on the GDL at I/O stage to talk about it. And I hope we can see really incredible stuff for year 2. And when we definitely will be bringing you back.
Yeah, I can't wait. We believe the potential is so high and we're just starting, so looking forward to it.
Yeah, so definitely thank you for taking all the time with me, Barish. I really appreciate that. For those of you on the live stream, if you want to see great GDL content the rest of the year, subscribe to Google Developers on YouTube and check out developers.google.com/live. We'll be back here at 4:30 talking about performance on Chrome.
Several of the new features, but not go into a significant amount of technical depth on them. We have additional deep dive sessions about everything we're talking about today, and we'll give you pointers to the sessions at the end of our talk.
And we also have a Q&A at the end, so you can ask as deep a technical question as you want then. Okay, so let's start talking about infrastructure. So this is a picture of data set.
Speed of scaling is important, because it turns out that you don't always get a heads up about load that's coming your way, right? By the time you know you need to scale, it's often too late. And so when you need to scale, you want to be able to spin up virtual machines as quickly as possible. And so we've focused on making that spin-up process quick and painless so that you can scale up quickly and effectively on Compute Engine. So how does that reflect in the product that you get to use? Well, so a great example is our partner MapR Technologies, who used our off-the-shelf virtual machines to run the benchmark called the minute sort benchmark. Now, this benchmark measures how much data you can sort in a minute. It's kind of the gold standard for big data processing. And MapR was able to sort 1.5 terabytes of data in 1 minute on Compute Engine, beating the previous record that was set on dedicated, tuned physical hardware. So I hope that gives you a sense of what you can do when you have access to not just fast virtual machines, but to a fast network connecting those virtual machines.
All right, another core principle is openness. We start by providing an easy-to-use API layer that we expose to you, the developers. Now, that is also the same API layer that we use as we build higher level tools. For example, command line tools, or the Cloud Console is built accessing the exact same APIs that you have access to. Another form of openness is we really want developers and partners to be adding to the ecosystem, building solutions on top of Compute Engine and the greater cloud platform. And so we've worked with the with the community to provide both CentOS and Debian images as part of Compute Engine.
Now, all that doesn't really mean very much unless it translates into benefits that you can see and that benefit you. And we're very happy that our customers and partners have noted that our focus on performance and security address what they're hearing from their customers as their top concerns when they move to the cloud. Here's a quote from Thorsten von Eichen, the CTO of RightScale, one of the largest providers of cloud management software.
So Compute Engine is not an island. I spoke earlier about the cloud platform. So to build really sophisticated services, you often need to use multiple different pieces in order to build a complex application solution. And so we're really excited that today we announced that Cloud Data Store is basically taking what has been the world's largest hosted NoSQL database, which is App Engine's data store, processing more than 4.5 trillion operations per month, and making that available through a public API. So you can access it from Compute Engine or indeed from anywhere. And so you can build applications comprising front ends using App Engine, communicating and sharing data in the middle with the Cloud Data Store, and having backends on Compute Engine, for example, all being synchronized and accessing that data. So there are a lot of possibilities with Data Store. So we think it's a great addition to the family.
And that pattern that Martin talked about is also a great pattern, one that we recommend because it lets you get the best of both worlds, App Engine for your scalable front ends and Compute Engine for the heavy lifting. Now, it turns out that not all workloads are created equal. Some, like databases, benefit from lots of memory. Others, like rendering or processing geographical data, require lots of processing power. When we launched Compute Engine, we launched with what we called our standard family of instances, which had a good mix of both processing power and memory. But we quickly specialized to offer instances that actually are more suited to these specialized workloads that require more of memory or compute. And so we launched instance families called our high CPU and high memory instances. So you have a good diversity of instances to suit a broad array of workloads. And the standard instances are available in 1, 2, 4, and 8 core variants. And the high CPU and high memory instances are available in 2, 4, and 8 core variants. But that's not all. Today, we are also announcing 2 new instance types, our small and micro instances that are designed for workloads that don't need as much processing power. So for example, if you want to run a development or test workload in the cloud, or you just want to experiment, you can do so with these instances for less than 2 cents an hour.
So as you design your clusters and think about how you're going to orchestrate and get a large number of machines understanding what their roles are, we produced a metadata server, which is a simple HTTP server that's exposed into the guest environment. So you can just use a simple HTTP GET request to get metadata that is passed. Now, we had 2 forms of metadata. One was project level, which all of your instances would see the project level metadata. And then we also have instance level metadata, where each individual machine can have custom metadata for just that instance. Now, one of the things that we've now added is the ability to mutate this metadata and add more metadata on the fly. So you can use this to pass in changes to your configurations while your system is running. You can also use it, the instance itself can also make changes to that metadata to pass information out to some process on the outside that wants to understand what's going on with the instances.
Now, it turns out that a lot of people, try to solve these problems in their own self-built clusters by using things like agents to configure and to update instances when things change. And with Compute Engine, because you have access to a metadata server that's very easy to program to, you don't need to do that. It's built into the service. Another thing people think about a lot when they think about how they deploy sort of highly robust and scalable architectures is how to make their applications restartable, repeatable, and resumable. And so from the get-go, we provided a highly reliable persistent disk solution to let people store their critical data so they could do these things. And our customers really liked it, and they wanted more. And by more, I mean more storage. And so today, we're happy to announce that you can now attach up to 10 terabytes of persistent disk to any Compute Engine virtual machine, which really lets you unlock the power of crunching large amounts of data and storing that data reliably. But it's not just about your actual application data. It's also about your virtual machines, too. And so we've made it possible for you to use a persistent disk as the root file system for your virtual machine. What that means is that if you deploy a virtual machine as a component in your architecture, and that component happens to fail, because they do, that's Murphy's Law, you can always bring that component back up in practically the same state where it left off, because all the configuration tweaks you made to that virtual machine in the root file system, all the changes you made to it were preserved, and you just spun up a new instance using the same persistent disk, and it's effectively the same instance. Take that one step further, and think about what you can do when you can actually attach and detach these persistent disks on the fly to your virtual machines. Because now you can think about architectures like having a hot standby where you can quickly swap a persistent disk to a hot standby and have very low downtime if a component fails. Or think about what that means in terms of how you scale. So it's quite easy to scale horizontally, but if you want to scale vertically, you can even do that. So let's say you're running a database on a standard instance, and you decide that you could probably use some more RAM because your queries are not performing as well as they could. So you spin up a high memory instance, and you detach the persistent disk from your standard instance. You attach it to the high memory instance, and you've just scaled vertically. So persistent disk makes building these architectures really easy. And with these changes, we hope that it'll make your applications ever more robust and easier to build.
Right, so the cloud is all about flexibility. And so you can spin up a single instance or 1,000 instances at the drop of a hat as your workload demands. Now with sub-hour billing, which we announced today, you pay for per minute increments. And this gives you flexibility also in the time dimension. No longer do you need to think about utilizing the full hour that you will pay for, and you can instead focus on exactly what your workloads require. And so we anticipate that this will enable new types of use cases when you can spin up your virtual machines really, really fast, and when you turn them off, you only pay for the time that you actually used.
And when you combine that with the fact that virtual machines spin up really fast in Compute Engine, that can actually enable new kinds of architectures, as Martin said, that we've seen at Google, and in fact, it's how we build our applications, but we haven't really seen much of in the cloud, and we hope that this enables you to build using on-demand kind of architectures, which you couldn't earlier. Now, a lot of our customers told us that they don't look at the cloud as a silo. They want to build applications that span their local infrastructure, their own physical data centers, and the cloud. Or in some cases, they want to build applications that span clouds. And so we've announced a new feature called advanced routing. It's a very deep networking feature that lets you do lots of things, including this. You can actually spin up gateways and VPNs, so you can connect your data centers to the cloud and sort of share IP spaces so that you can do things like augment your on-premise capacity with capacity in the cloud, build multi-cloud deployments, share data between applications that might live in different locations, and more. You can also do things like, as Martin mentioned earlier, if you remove the public IP from an instance, you can cut it off from the internet but make it accessible from inside. And now using advanced routing and the fine-grained packet level routing control you get, you can do things like deploying a proxy server or a gateway to mediate access to those instances. So it makes some very, very cool and powerful and highly secure architectures possible when you take full advantage of this capability.
All right, what I want to do now is to give you a little demo of some of the features that we've talked about. So I'm just going to switch to this one. Uh-oh. Yeah, I know, but it's, no, it's not refreshing. I broke it, Joe.
Well, you know it's a live demo when stuff breaks, right?
Totally blank. Oh, I moved to that one, but. Open up another tab.
All right, we'll try and get this fixed. In the meantime, we'll just move on to the next segment, and we'll come back and get the demo going. I'd like to invite Sebastian Stadel, the founder and CEO of Scalr, to talk to you about what he thinks is cool about Compute Engine.
All right, thank you very much, Navid, for inviting me. So it's very exciting to be here. I'm super pumped about getting a Chromebook and all that. So I hope you guys are as excited as I am. So I'm here to talk about a couple use cases that we've seen from our experience at Scalr with working with hundreds of customers across many different clouds for the past 5 years now. And there's a lot of features that Compute Engine has that basically allow us to solve real customer problems with greater ease. Yeah. So here's a few of the customers that we've worked with in the past 5 years. Companies big and small. You can one of them that I'd like to point out is Samsung. They run something like 22% of the world's Android phones. They build applications to manage all of that, and infrastructure for it is just huge. And I'd like I'm super excited because right now, as I speak, there's the Eurovision contest, which is a, how many of you here are from Europe or have heard about this contest? Awesome. So it's like the world's second largest annual event, annual televised event, between 100 and 120 million televised viewers. And the voting for it is extremely spiky. Now, the viewership on any given day for this is 4x what you could find at the Olympics on any given day. The scale of this event is so huge, I could even say it exceeds Michael Arrington's ego, but maybe that's a bit. So Ralph Rothman, the infrastructure director for Compute Engine, that was retained by Eurovision to run the backend for this, has the following to say of Compute Engine. Google Compute Engine rocks. Basically, what he loves about it is it's not just fast, it's Google fast. There's a few recent benchmarks that we ran to evaluate the speed of different services. And one of the figures I'd like to show is that for sequential I/O on persistent disks. You can see here in blue is Google, higher is better, and it's compared to a well-known competitor. You can see that, and you can see here that for sequential writes, you get about 3 times the amount of throughput. For reads, you get about twice the amount. This type of performance is something that's really valuable when you're using Cassandra or anything that writes sequentially. But Compute Engine isn't just about the speed, although we love it. It's also about the features. And there's this use case that we see recurring in the enterprise, which, think about it this way. You're building an application on the cloud, and that application needs to access some resources that you have in your corporate network. Now, normally you'd have to build a whole series of things to get that and secure that and go through all sorts of different vendors. Compute Engine's routing capabilities allow you to do that really, really easily. They allow you to build that highly secure tunnel between Compute Engine and your corporate network for your application. Another use case that we see very often is the opposite. When you have applications that are in your corporate network, but don't have enough capacity for them to run because they've increased in size. And what you have here is you usually have something called cloud bursting, where you're extending your corporate network with cloud resources. Again, routing makes this really, really easy. A second use case that we run into quite frequently is the processing of large amounts of data. The folks at CERN, specifically from the Lawrence Berkeley labs just across the bay, they're working on the Atlas experiment, which is responsible for managing all the giant Condor clusters that are crunching huge amounts of data. And that eventually led to the discovery of the Higgs boson particle. Now, they crunch huge amounts of data, and when you're able to mount a persistent disk to multiple instances, and when you couple that with the new limit of 10 terabytes per persistent disk, it makes it really, really easy to crunch a huge amounts of data across the large amounts of nodes without having to manage a very large number of volumes and having to version what's what, where, and all that. So the use case of crunching large amounts of data is very much facilitated. Now, there's another use case that, I like to talk about. So this is the third one. And I'm sure if anybody here has used one of the leading competitors, a couple years ago, there were 2 major outages that pretty much took a lot of people offline. And when we had some customers that were telling us, well, this is unacceptable, there's a lot of components that are not reliable, so we need to architect around that. And architecting around those things is very, very difficult. For example, if you can't rely on a region being up, if you can't rely on remote disks being accessible, then you have to architect around that. And that's really, really, really tough. It's very painful. I'd say it's like probably even more painful than sitting through a Twilight movie, but I don't know. Yeah, so the fact that you have that in Compute Engine, you're able to have every resource that's either a global resource or a regional resource, that allows you to plan what will go down in the event of a regional outage and what won't. So you can plan your architecture and build your infrastructure in a much, so it makes it much easier to build highly available systems. And finally, the last thing that of course, as a startup that I'm very much appreciate is the by-the-minute pricing. We have this customer that has very, very erratic scaling patterns. They're very hard to predict, but when they happen, they're just explosive. So they go from X to 20X in the matter of minutes. Now, what's awesome about by-the-minute pricing is that it dramatically reduces the risk of scaling up. If you only need to pay for that 10-minute block instead of the whole hour, then you can start scaling at the slightest hint of having that peak. So we're looking at about 6 times lower cost of a false positive here, so that's huge. And eventually, that's all that money that you start saving, and you might be able to do cool things like buy a WinZip license, or I don't know, but that money ends up. So that's the 4 use cases that we see Compute Engine being really powerful, and we're super excited about what you guys are building. So I'd like to hand it back to Martin.
Thanks very much.
All right,
Thank you.
Thank you, Sebastian. All right, Joe fixed it. Thank you, Joe. I was going to show you a little demo here, highlighting some of the features that we have. And I'm just going to start by kicking off a bunch of VMs, and I'll talk through what's happening here. So what you're looking at here is a web page that is backed by an App Engine application that is controlling the Compute Engine API, Compute Engine through the API. And so what it did is on the left-hand side, it started up a cluster of 1 instance, and on the right-hand side, it's a cluster of 8. And so you can see, as it's coming up here, the green means that these VMs are actually running, and they are now just getting ready to be able to serve tiles in a Mandelbrot set. So we basically are going to show you some cool Mandelbrot fractals here. And so on the right-hand side, this 8-machine cluster has shown up, and here on the left-hand side, we have the single instance has launched. So you see, that's how fast we can launch a bunch of instances on Compute Engine. And these are now 2-core high CPU instances. So let me show the map. So we're using the Maps API here to basically just jump around and get some tiling behavior. And you can see that the right-hand side is a lot faster. Now, I'm just a single user using this, and so it doesn't demonstrate the full scalability of this. And so if it was a multi-user, multiple users hitting this at the same time, you would see the scalability much better, but it's pretty cool anyway. Ooh, this is one of my favorites. This is pretty complex. This one takes much longer to render. All right, so one of the interesting things here is that the virtual machines are vanilla images that we launch, and all of the configuration data, all of the instructions for what they should be doing are passed into the virtual machines through our metadata server. And so, in fact, since this is a Go program, we're actually passing the source code of the Go program in one of the metadata values, and that gets read by the virtual machine as part of the startup script, and it compiles it on the fly, and then renders these things. So that's an interesting use of our metadata server right there. So let me show you what happens if I go over to the Cloud Console. So the Cloud Console is a new home, and actually let me go back here, a new home for all of our cloud services where you can manage and see all the resources that you are using. You can see billing information and all this kind of stuff. And so I'll just jump back into the compute engine piece. And here we see a list of our instances. And so right now I have 8 instances here, and then I have a single one over here. Now, what I can do is I can add virtual machines, and we've programmed this so I can just click this button, and it'll start spinning up virtual machines here. And one of the things that I'm previewing for you here today is it says using load balancer up at the top. And so this is a upcoming feature of Compute Engine that we are showing you where it's a load balancer as a service. And so adding virtual machines is really easy. You just spin them up and add them to your pool of servers for that work. And similarly, you can remove machines. And so as I click around, those things will be spun up, and I should have been doing this while it was coming up. But as they get health checked, that's what the white check mark means, they basically get included into that. Another fun thing I can do is I can, of course, just go into any one of these instances. We can look at this, and here you can actually see the Go program. It's really quite long, but we can't see the whole thing. It's one of the metadata pieces. And I can just simulate a failure. So I'm just going to delete this instance. So we'll blow that away. And now, as I'm scrolling around and doing stuff here, you'll notice that everything still keeps working, and our application detects that that machine is gone. So it highlights, it updates the little graphic we have there. And then, of course, I can just spin everything down by hitting the stop VMs right here. And as you see, in this view, you'll start seeing these things terminate and disappear. One other thing I wanted to point out here is that you'll see a metric being shown on this graph, which is CPU utilization. And so this is another preview feature of an upcoming Compute Engine feature, which is a monitoring API, where we will expose a number of metrics out of the virtual machine, and we will add to those metrics over time as well. And now all our instances have shut down. So I think that's it for the demo, and we'll switch back to slides.
Thanks, Martin. And thank you, Joe. So as I mentioned earlier, this is an overview session. We haven't had time to go into much technical depth about any of the features, but we wanted to give you an overall flavor of Compute Engine. But we have deep dive sessions into a number of things that we've talked about today. Speed, efficiency, and control is a deep dive session on our advanced networking stack. I highly encourage those of you who are interested in this stuff to go and attend. It's going to be a really cool talk. We have a great talk on persistent disk later this evening, actually, where they're actually not only going to tell you how to use persistent disk and talk about using it in an application, but even give you a little bit of a behind-the-scenes glimpse at the architecture and the product itself. We have a session that is focused on how you can build robust, high-availability applications in the cloud. It's called When Bad Things Happen to Good Clusters. And then we have a code lab on Friday morning, which will help you get your hands dirty with Compute Engine, play around with some astronomical data, and just get a feel for the product. It should be a really cool, fun session. And of course, we have some time for questions today. But we'll also be at the sandbox from time to time, and we have office hours tomorrow. If you want to come by and chat one-on-one, ask any question you have of us, we'll be available to you. So one more thing. So we're happy to announce that Compute Engine is now available to sign up online. We'll be flipping the switch shortly after this talk. You can go online, sign up for Compute Engine, play with it, spin up a virtual machine for under 2 cents an hour. Tell us what you think. Tell us how we can make the service better for you. We'd love to have you play with the service, give us feedback, and tell us what you need from it. Now, if you're interested in playing with the 2 new preview features Martin talked about earlier today, the load balancing capabilities, as well as the monitoring APIs, we actually have them available to a small set of customers. And we'd love to have more people come play with them, give us feedback, help evolve these features, tell us what matters to you. So we have an early access program. The URL is on the screen up there. Come apply, give us feedback, be vociferous, tell us what you like, tell us what you don't like, especially what you don't like, so we can make it better for you. Thank you very much.
All right, thank you. And I think we can take questions now. I would like to invite Sebastian back up on stage, and also Joe Bida, who is the tech lead on Compute Engine, who will field the most difficult technical questions.
So, why did it fail? Does anybody want to know? I was running it on an unpaid App Engine instance, and I hit a quota limit. And so I entered my credit card up here frantically while you guys all watch. So, and in that vein, I'm going to be hosting the robustness talk later.
All right, we can start with you.
Maybe this is a question better for the persistent disk session, but I'll just ask it anyways. What's the consistency semantics associated with multiple Google engines writing to the same persistent disk? Let's say they're writing to the same file.
So you can only attach a persistent disk read-write to a single instance at a time. Okay. We do have the capability of mounting read-only a single persistent disk to many VMs at the same time, but that's in read-only mode. So you can share data across them that way.
And you're free to do something like run an NFS server on an instance hosting a persistent disk and then export that to other virtual machines if you need to share a file system.
In our benchmarks we run, there's no degradation of performance when you're reading it from multiple servers.
Thank you.
All right, over here.
What is your plans with Google's customer support surrounding this whole thing, given the history of Google and customer support?
So we've already launched the ability to get premium support. We have a gold support program. We launched that about a month and a half or maybe 2 months ago. So you can actually get developer support, talk to a real person on the phone, as well as submit tickets. So that's already a capability you can have. We're also very responsive to feedback, and we watch Stack Overflow and stuff as well. So if you have sort of non-urgent development questions, we're quite responsive.
All right, that's fine.
You mentioned the performance difference between Compute Cloud and other cloud providers, but what's the performance difference, if there is any, between the compute server and App Engine?
That's a great question. So I think you're comparing apples and oranges, right? There's no such thing as a compute engine performance, right? You deploy Apache, you deploy Node.js, you deploy something else. Performance varies, right? It depends on the entire stack you build. With App Engine, you get a fully managed stack where performance is taken care of for you, scalability is taken care of for you. So think about sort of the platform versus the infrastructure. So you can do a lot of things with Compute Engine, but if you write bad code, it won't do very well, right? So it's kind of, you just can't compare the two. It's not a fair comparison.
I mean, we invite you to try.
Yeah.
If you have workloads that could be suited for either, then if you want to manage the infrastructure and you need that control, then Compute Engine is probably your choice. But if you would be happy with having all that managed for you, and you get the performance and the price points and everything else, I mean, all the different factors are what you want, then you should make that trade-off, right? So we offer multiple products so you can use whatever is best in your particular situation. Right, over here.
Hi, you mentioned that security was sort of like a major point of Google Compute Engine. I was wondering when you might be going through any of the certifications, for example, FedRAMP?
So the ISO 27K is probably one of the most common certifications around information security. And I didn't mention it today, but we actually have recently gotten ISO 27K certification. So that's one of the areas we've done. We're also looking at additional areas where certification matters to our customers, and you'll hear more about that in the days and months to come.
Anything specifically on FedRAMP?
I am not sure about that, but if you come and find me at the sandbox, I'll get you an answer.
Thank you.
Right, over here.
If I want to connect from Google Compute Engine instance to the Cloud Data Store product, is that going to have better latency significantly compared to connecting to that from another cloud?
In general, connecting from Compute Engine to other Google services, you're going to get the fastest connection from within Compute Engine. Not everything is hosted everywhere. These things have physical locations and there's the speed of light, but we're continually working on optimizing the connection between Compute Engine and other Google services, whether they be cloud services or other APIs or services at Google.
And you know, as you access other Google services, your traffic stays on the Google network. So you know, it won't be subject to, you know, the variance in the general internet in those cases as well. All right, over here.
So beyond Debian and CentOS, anything for Ubuntu or Microsoft OSs?
So right now our focus is on working with the community to provide community-supported distributions as part of our images. We've worked with both the Debian and the CentOS communities to bring those images to Compute Engine. We'd be happy to engage with any of the other free Linux providers who want to make the images available sort of as part of our default images in Compute Engine. In terms of Microsoft, we've heard that from customers. We'd love to chat with you more about your use case and see, you know, where that falls on our priority list.
Great, thank you.
Hi, my question is the App Engine data store being renamed or rebranded as Cloud Data Store? If the answer is yes, how do I get my existing data that is being accessed by an App Engine application to be accessed from a Google Compute Engine application? If the answer is no, how do I copy the data from an App Engine data store to the Cloud Data Store?
I actually don't know. I think, why don't you grab us afterwards and we'll find the right people who can give you that
I will
answer.
hang it on. Thank you.
Is there a session on the app?
Yes, there's definitely a session on data store.
Yeah, and I think you definitely, you know, go to that session and they're going to go into the cloud data store a lot deeper.
But you can also find us and we can, you know.
Yeah, we can find the right person.
I think I know the answer, and I think it's the answer you want, but we need to verify that.
I will hang it on. Thank you.
You talked about the advanced routing. Is it very similar to your favorite competitor's virtual private cloud, or it's not there yet?
Advanced routing, so in general, I would think of advanced routing. So, you know, if you've looked at the abstractions in Compute Engine at all, there's always been this hint that there's this virtual router behind the scenes, a software-defined router. We never gave any knobs and sort of, you know, ways to configure it. And so advanced routing actually makes that virtual router configurable by you. So it lets you do all those things, but it's not a hosted service per se that does higher level things. It gives you the tools so you can do the stuff yourself. So it's very powerful, but it takes some work on your part. But you can do a lot with it. Does that answer your question? Yeah. Thank you.
I'd like to add to that, that I assume that you're referring to some service that starts with a V. That particular service is very complex. Compared to that, routing is very easy to work with. That's been our experience.
Okay, thank you.
So I apologize, we're out of time. We'll just head to the back and you can chat with us outside if you have any more questions. All right. Thank you.
Thank you again for attending.
Welcome back to Google Developers Live at I/O. I'm Louis Gray from GDL, and I have with me two distinguished guests, Colt McCandless and Ilya Grigorik. Thanks for coming, gentlemen.
Thanks for having us.
Thanks. And we're here to talk about web performance today. And if you remember from the keynote, it seems like so long ago now, but it was only about 5 to 6 hours. We were talking about performance and speed and simplicity and all those things that really are part of Chrome and really part of everything that Google is doing with our approach to the web. And so I'm really happy to have Colt and Ilya on here. Both of them have spoken a lot about making the web faster and Chrome tools that'll get the job done to make everything go more quickly for the web platform. So I wanted to just get really started. You know, web performance is really all of what we do at I/O and through the rest of the year. You guys even have a booth upstairs. I just checked it out, which is great. Why so much attention on web performance, Colt?
Well, so as every app developer knows, as we start to bridge into mobile, it's not just about network performance anymore, about how fast your page loads. It's about how fast the page is to respond to the user once they're in it, right? So we have to feel like apps, which means developers have to worry about the 3 pillars of performance now: network, rendering, and compute. And because of this, we've got a lot of presence here, a lot of great talks going on to try to help developers start talking about this, bring this mental model to the table, and show them what tools they need to get things done.
It's interesting you bring up networking, rendering, and computing. I came from a world where computation was always the bottleneck, and it was the server that was slow. And I think what you've seen with networking has grown exponentially, 10x each round, and it's really become something where the data center kind of becomes a cloud, and you don't think about the server anymore, and it's the network that's the bottleneck. And that, as you mentioned, it can be really difficult and different and complex. So what are you guys doing up at the booth to take all that complexity and make it simple?
Well, we absolutely are sure that it's super complex, right? I mean, we as the Chrome developers spent a long time architecting this stuff, right? What we've actually done is we've assembled all of the brains at Google who deal with performance on a day-to-day basis, and we basically have them standing around for about 8 hours answering questions, right? In addition to that, they're going to be walking you through the tools that we use for our internal analysis and all of our profiling and showing you how to use them, and at best, if you bring us one of your sites, we'll actually tell you what's wrong and how to fix it as soon as possible.
And so that's Performance Alley upstairs.
Absolutely.
So I like the idea of hearing a bunch of gurus standing around like at my service. So what exactly are they going to be doing? Is it like I show up with my laptop and they're going to tweak my browser settings, or what's the deal?
We won't tweak your browser settings necessarily, although maybe we could, because as you saw in the keynote, we have the Chrome data compression, right?
Yes.
So that's already a nice win that you can enable. But as a web developer, I think another thing that we can take away from the keynote is not only is the web getting faster, it's also getting more ambitious in terms of the applications that we're building, right? Which is why we care about rendering performance, like 60 FPS in a browser. For game developers, this has been a day-to-day thing. For a lot of web developers, this is a new concept, right? So upstairs, we're talking people through kind of the steps of what are the tools in Chrome that can help you figure out what are the rendering bottlenecks. Maybe you have a CPU bottleneck, a compute bottleneck, or maybe it's networking. Right? So for example, for networking, we have a suite of tools called PageSpeed, which is basically like a performance linter. You run analyze, and it tells you, here are the 10 things you should fix right now. And then we can also provide some tools to help you automate that web performance best practice, which is great.
Isn't it true? You never really eliminate the bottleneck, you just move it to a different place?
Absolutely, that's what happens, right.
And that's the way we always learn that. I mean, if you get it out of this spot, you're going to find something else that's hot.
Yep.
So you're talking about really like a performance analysis service. And kind of finding the best stuff and finding how you can optimize for that. I know we often have you online at GDL. I appreciate you coming on and talking about making the web fast. What are those things that web developers can really key on to try and make their pages load more quickly? What are the things that really are the slowdowns? I think one of the pieces was touched on the keynote was the option to get away from possibly JPEG and moving to WebP.
Yep.
Can you talk a little bit about that compression and things that are out there?
It's a really cool example. So it turns out for an average page on the web today, over 60% of all of the data transferred is actually images, right? So we're building pages which are very media heavy, lots of images. And with WebP, we can actually give or provide about 30% better compression over JPEG. And what we didn't mention in the keynote was 80% win over PNGs, right? Which we often use for alpha channel and transparencies, which are very popular in games and other places. Yeah. So you put those two things together, by using something like a WebP format, and you get a huge savings, which fewer bytes transferred, which makes the page load faster. It also decreases the cost of your page, right? I think it's something that we forget, on a 4G connections. For a lot of users, bytes are expensive, so reducing that amount is actually very, very beneficial.
Well, you mentioned 4G connections. I'm going to date myself a little bit and go back and talk about modems.
Sure.
So the web they just announced its 20th anniversary, essentially. And so some of us have been using the web for a long time. And some of us were using Mosaic and Netscape Communicator and all those cool things where you had essentially gray pages with blue links, and when you click through, you would get to text files. And you had to do that because the downloading speed wasn't even possible to load an image, and it was painful to download hundreds of kilobytes of data, which are things we absolutely take for granted. And I think often what we run into is if you have a pipe and you make that pipe bigger, the people who are designing your apps are going to fill that pipe. And so how do you manage that kind of one-upmanship on the equipment side that's really sucking down the data to the people that are creating bigger and more greater apps?
So I think it's a challenge to both us developers, on Chrome and at Google and all the rest to make. So we want to build more ambitious applications. We want live streaming, right, to happen. We want to deliver rich media, rich games in the browser and all the rest. So developers keep pushing us to build more ambitious applications, which means we need to improve the performance of the web, performance of the browser. But it is a collaboration, right? We can't fix everything within Chrome, which is why we have the performance area, where developers can come, show us their application, and it gives us feedback as browser developer, right? To say, here are the things that we need to address, help developers fix, or vice versa. Like, we were not educating developers about something really
What
well.
is it about Chrome specifically that makes you say it's speedier? What is it that we can test on, and what's different about that browser?
Well, from the ground up, we always focus on performance. I mean, that's one of the cornerstones of Chrome that started at the beginning was we need to make a faster, more secure browser for people because that enhances the web experience for everyone, right? The browsers get better, the web gets better, everyone gets happier. So we do a lot of things across network, compute, and render to make sure this happens. V8 is by far one of the top JavaScript VMs out there. The way we handle rendering and our utilization of the GPU is top tier, right? We do things that no other browsers can do just right now. Networking, we do a lot of great stuff like the flywheel technology as well as the way we're compressing the network transfer stuff.
A really cool example with network is Chrome literally learns the topology of the web and it becomes faster the more you use it. Right. We learn your browsing patterns, and next time you open the Google News homepage, we say, hey, we can preload these other pages to make it seem faster, pre-rendering and other tricks under the hood.
So a lot of pre-caching and fetching of pages that I might go to in the future.
Right.
Almost like cheating. Yeah. I think one thing that Linus, I believe, was touched on today, they looked at the performance of Chrome on JavaScript, both on desktop and on mobile.
Yep.
And on the desktop side, year over year, maybe we increased by 50%. And if I apologize if I get the number wrong. And then mobile, it practically doubled. And so when you look at mobile, how important is making the web fast relative to desktop?
Oh, it's everything right now, right? As we've already talked about, the amount of content coming from mobile platforms is eclipsing desktop more and more and more. We're seeing that. And especially it's becoming the life force for a lot of these small businesses that rely on mobile for their input and their income, you know? A user visiting a website has a different sort of expectation when they visit on mobile than they do on desktop. And so decreasing the load time, increasing the performance is going to be critical for these guys to stay afloat as the technology moves forward.
Yeah, cool. Well, I know we actually did this pretty fast. It's good for guys who are doing performance to talk quick. And I appreciate your performance on it. I appreciate you joining us at GDL at I/O. For those of you on the live stream, we're going to get back to your sessions next. And follow us again. We'll be at GDL at I/O again at 5:20 talking about Drive. See you there.
Hi, everyone. Thanks for coming. Please, obviously, leave if you don't. So thank you, everyone, for coming today. Really good to see you all. Today, I'm going to be talking about using Google Drive as the storage solution on Android. Okay? We're not going to be breaking the bounds of modern science. I'm going to talk to you about files and where you can put them and where you should put them. Okay? Personally, I think Drive is the perfect solution for Android. And I'm going to tell you why, obviously. I'm in love. There's a heart for me. That's really great. What will you do with this? You will allow your users to have seamless cross-device, cross-platform, cross-application, cross-user experiences. Okay, sorry that was a big run-through, but that's the essential point of it. Okay? If you do that for people, they will be happy. Put the user first, focus on the user, and the rest will follow. Okay? That's our goal here. Keep the users happy. If I can jump straight into a use case, this is a personal situation I had. I have a child. I'm quite a paranoid parent, and I like taking data about things. There are plenty of applications for Android, for various handheld devices that collect baby data. Okay, can you imagine every time your baby does a poop, you record it. Every time your baby has a nap, you record it. Every time any biological function you can imagine, medicine, this kind of thing. So there are loads of these applications, lots and lots and lots. And I went through them one by one, and I found what I thought was a really good one. Okay, it's called Baby ESP, and it is a really great application. It's perfect for the use case. When you install it, you have to set up some information. So at the start, I set in the name of the child, the date of birth, these kind of things. And that's the configuration it needs. Okay? And you can see along the top there, these are screenshots from the actual application. I removed all the data. So you can track information about your baby. You can see at the top there, they've got nursing and sleeping and diapers and this kind of thing. So really great, has everything I need. This is an example. You record a session, tells you how long it was, what it involved. You can add some notes about it. Another example, you can imagine me geeking out on this, can't you? So I'm collecting data. It's giving me these beautiful reports. Even gives me, look at that, really lovely. So it's fulfilling all my paranoid parent desires, okay? Everything I want. Until one day I bought an Nexus 7. So who has a Nexus 7? Yeah, great. Amazing device, aren't they? Really, really good. So I thought, this is great. I'm going to set this up in my child's room. It will be like the permanent data collection device. This is true. Thanks, guys. Good to see you. Thanks for coming. So really great. And then I found there was a problem, because I installed this, but it wasn't configured correctly, so I had to configure it. Okay, that was a bit of a nuisance. Even worse than that, I found that when I was changing configuration values on one device and then looking on the other device, they wouldn't be updating. So I would get 2 versions of configuration out of sync. That's really starting to get a bit painful. Even worse than that, the data wasn't available. So I was collecting all this data on one device, I was collecting all this data on the other device, and the reports were not collecting the data. So this was really, really painful for me. Okay, really painful. And in fact, I go as far as to say this is a bug. Okay, my data is siloed in 2 separate places, in 2 separate devices. It's not useful to me. What is this application doing? This application is treating my device as the user. Okay, don't treat me as a device, treat me as a person with multiple devices. Okay, that's a holistic approach to who I am and what I'm doing, and that's what you want to do. So Drive is a technology that solves this. So there's a simple drawing. I have data in one place and I have data in another place. If I had something in the middle to synchronize all this data, then that would be great. Now Drive perfectly solves this solution, perfectly solves this problem. And there are loads of baby monitoring software, this could be the difference between your software being 5.0 stars or 4.8 stars. And that makes a huge difference. So treat the user as a user, okay, holistically, and they will install your app. Look, 1,000 results. Okay, I only got through the first 25 before I gave up looking for one that actually did what I wanted it to do. Yay, happy user, me. Synchronized data. Of course, just an aside, Android is just one part of this. I've spoken about cross-device experiences, but obviously cross-platform. Now, the Google Drive SDK is available on any platform that you have. Anywhere you can make an HTTP request, you can have Google Drive. Go and check out our quick starts. Again, you have an application that works on your Android device, but how great would it be if your web version also had synchronized data? So that's just an aside. We're focusing on Android today, but all platforms have this. And multiple devices. Okay, we used to ask the question to the crowd, who has multiple devices? And then one or two people would stick their hand up. Who doesn't have multiple devices? Seriously, who doesn't have multiple devices? Okay. So, you see, my son's mom, who collects data here, does have multiple devices, and it's just a thing. So yeah, everyone has multiple devices, so cater to people. Okay. And I think this is part of a general problem. Where is my data? Where is my data? Where is it stored? And specifically in our case, where are my files? Okay, now I was thinking of a good image to put on this slide, and I was starting to think of my history of files. Okay, go back 20 years when I started collecting, you know, like PDFs of medical data, whatever it was. And I've slowly realized that I've lost all of that stuff. Okay, some of it is on a hard drive of an old laptop that I can't even find the power supply to. I need to unscrew the thing and take the hard drive out and find an adapter and all this nasty stuff. It's all lost. It's all totally, totally lost. The last place I want to store a file is on my hard drive. I don't know if you guys are gradually getting into that same thought. I just don't want it on my hard drive. Even worse than that, I don't want it on my phone's SD card. How am I going to get to that? Okay, I've got old phones. I can't charge them. They won't start. Someone stepped on it. I just can't get that stuff out. So my files are lost. Tears in the rain. I know, really sad. It got me really depressed. I found a sad picture. So that's that. Store my data where I need it. This is somewhat of a plea. Okay, as a user, please store my data where I can get it anywhere. Obviously, the cloud is a perfect place for that. Store it somewhere where I can share it with people, cross-user applications. Okay, Drive is the perfect place for that. Store it somewhere where I can share it with different applications. A file, the abstraction of a file is perfect for this. You have files on your hard drive, you share it with other applications. Again, Drive extends this abstraction into the cloud. You can share your Drive files with other applications. So, Google Drive, store my data where I need it, when I need it. Especially useful on Android. Why? Okay, so I could be talking about any cloud file storage solution, and you know there are plenty of them out there. Why is it especially useful on Android? Well, like everyone who's got the phone has already got a Google account with 5 gigabytes of storage. Isn't that obvious? Doesn't that make sense? I think that really makes good, strong sense. Use that storage. It's there. They don't have to sign up again. You will get one permission screen asking for access, and your application can save that authorization and just use it. Yay. No additional sign up, nothing else. Use that data. It's there. So how do we do it? Right, I've got a demo for you, okay, where I wrote a couple of things, and I want to show you the demo. Now, we've had networking issues. So I've actually recorded the demo. I'm kind of hoping we don't have to watch that recording because it's a bit jittery. So let's have a look. Now, the kind of application I wrote is like a baby data collection application. It's nowhere near, I'll turn it on in a second. It's nowhere near as good as the ones you see online, but it gives you a vague idea. Right, hang on. Yes. Okay, so I'm using a wired network connection that has never been tested before. So we may have to jump to the video, and I'm sorry about that. So what is this? Okay, you can see on there, you can see the various things, jigsaw, banana, nap. I've segregated data into 3 different types, either your baby sleeps, or your baby plays, or your baby eats. Pretty accurate if you've got children. So what am I going to do? I'm just going to go right ahead and add, what should he eat? Suggestions from the crowd. Steak. So I add that there, and look, it's appeared on the other device. Step 1 done. So, yeah, thank you. Thank you. I told you, we're not breaking the bounds of modern science, but imagine if that was the real baby ESP as I used it. I've immediately got the data synchronized on both my devices, and we'll talk about how we do that and what backend we use for that in a second. You see it's going a bit crazy, so we'll move straight on. The other part is the settings. Now, this is a pretty standard setting page that you would have for an application. It uses Android's shared preferences. Android people know that's a persistent store by which you can put some key values, essentially, and share them globally across your application. Okay? So we're going to go ahead, and we're going to change some of these. So I'm going to give my son another middle name. James, I think, sounds pretty good. And he's moved on to combination, and let's see. So this sometimes takes a few times. Why? Because we're at the mercy of Android's sync architecture. That's a good thing, being at the mercy of this, but it might mean that it syncs now. It might not sync now. It might sync in like 20 minutes' time. Not exactly great for this demo. So you can see I'm pressing the buttons. Please work, please work, please work. If not, I'll just reset it and do it again. Yep. Let's try again. Obviously, my implementation is bad, okay? But I'm going to tell you the things that I did and why it's useful. So let's try. So they told me to leave it in airplane mode. Oh, there we go. So what's happened here is it's synchronized back to the original version. That's a bad bug. I've got the engineer in the front row. There will be beatings. But you can see. Let's try just one more time. Otherwise, I'm going to have to get you to use your imaginations. Again, not good for geeks, but like, sorry. You're like dying for it to work. Please work, please work. Look at that. Did anyone notice? Yeah, okay. So again, we're at the mercy of the Android sync architecture, so I'm sorry about that. So that's the demo. Really 2 simple things. We'll switch back to the presentation. So that was the demo. I'm going to talk a bit about how we did that and how it relates back to some of the points I made earlier. Oh, this was the video. Look, you can see it's a bit shaky, but we don't have to watch it, which is good. Right, so we're storing data here in 2 different places. Okay, we had 2 fundamentally different paradigms here. We have one where we're regularly collecting data that we can access and use for reports, for various things like that. The other part is application state. And Google Drive conveniently has 2 ways that you can store data, and they match up very well with these 2 things. So the first one is app data. And this is a feature we launched recently, which gives you, the developer, a folder inside a user's Google Drive. And that folder has special properties that make it useful for this. So that's the first part. The second part is the actual data. Now, we can just store that as a regular file in Drive. Okay, in our case, you can see the top one, baby times DB. I'm actually storing it as a Google spreadsheet. Okay, now you might think, oh, that's not really a good solution. Well, we'll talk about it. I think it is actually a very good solution for this. So we have 2 different places, app data for state and Google Drive regular files for actual data or images or notes or videos, whatever you want to put in there. So how does it look? This is a recent screenshot. It just shows exactly what we had there, and it's in Google Spreadsheets. Remember, put my data where I need it. Okay? I want to make graphs, I want to make charts, I want to do cool things like that. Okay? I want to be paranoid and really like soak in this thing. So I think Google Spreadsheets is a good place to put my data there. But I just wanted to illustrate that it's not, don't just have to use Google Spreadsheets. It can be a file that has anything in there. Now, that says binary up there. Obviously, it's not binary. Does anyone know what file format that is? There's a clue. Anyone? Yeah, well, no. Close. So this is a SQLite 3 database. Why have I mentioned this? Because actually, when you're writing Android apps, that's what you do. Now, who's written an Android app that collects data of any kind? Okay, so it's pretty easy. And I wanted to design the application as you normally would. So I create a data schema, it has a single table, and I just collect data into that. That's my app. Okay, that's probably exactly how Baby ESP works and all the other data collection baby apps. The clever thing, the extra thing that we do, is we ensure that that data is regularly synchronized with a Google spreadsheet. Okay, you don't want to do it immediately. You don't want to send it straight up the wire. You want to queue this for later, for when the user has access, when the system decides that synchronization is what you want to do. Android is clever how it does this, how it decides this. So we let that. And it also gives you the benefit of the user being able to select that checkbox that says, do I want to synchronize this app or not? Do I want to synchronize this account or not? So it's really useful to use that architecture. So we write our app. Normally, we just have a single database, a single table in our database, 3 columns, and that's that. And the user input goes straight into there. Okay? So treat it like a local, how you normally would with Android, and the rest will follow. Okay? How do we do the export? Well, now I'm going to show you some snippets of really easy, obvious code. Okay? We use CSV. I know that's a bit embarrassing to use CSV for anything, but actually it's really, really useful. We have a single table, and we want a single sheet. It's pretty much just CSV. So how do we get the data out? We ask for an export link on the Google spreadsheet, and it gives us a URL by which we can download CSV. So we get that, we pass the CSV. You notice I didn't put any commas or quotation marks or anything crazy in my notes because that would break my parser. But that's all we have for now. So export it like that. On the other side, you can give CSV, you can put it into Google Drive, and you ask it to convert. So you say convert. And Google Drive is clever enough. If you're looking at this snippet, the content variable, that is something that knows about the actual content and the MIME type. So Google Drive is clever. It looks at the MIME type, text CSV, and it says, well, actually, I can convert that into a spreadsheet. So it just does. So what have I done here, just with this data? I've made it portable across devices. Okay, I showed you that. That's really, 2 devices, portable data. But it's not just that. It's also portable across applications. What if this schema was public? What if all baby data applications used the same schema? Well, then I could share my data in between each one of them. I know, you're smiling. That's amazing, isn't it? Now you're talking. Now you're talking proper sharing data, making the data useful, putting it in a place that is useful. And finally, just wanted to mention my wife. She wants to get involved in this. So, it would be nice if we could share the single database. Sometimes I'm not at home, sometimes she is. So the data is now portable across users as well. Okay? Really, really important, really useful. A file on my hard drive, I can't give that to someone. I have to attach it to an email, just like really bad. So now let's switch back over to app data. When you save data for your user as app data, it appears like this. Okay, you can see the top row is baby times, the name of the application, and you can see that I've got 1 kilobyte stored. It's actually less. How do we do it? It's a chunk of JSON as key value pairs. They identically reflect the shared preferences on the Android device. It's so simple. When something changes, we generate a chunk of JSON, we push it to the file. Obviously, it's not a whole K big. I think that's the lowest thing it can say. What does this allow? Well, it allows the user to manage this data. And I'm going to talk about a couple of important points with app data. And that's what can the user do. So I still strongly believe the user owns this data. The user can decide what they do with it, so delete it essentially, and also see how much quota it's got. What they can't do is view this data and edit the data. So you might think that's a bit evil, but I don't think it is. I think it's really useful. It means the application can put data in there and make some assurances that nothing else, no other applications can get at the data, no user can modify the data. Okay, so it's a way of being sure that the data will have a certain format or a certain structure, really useful. But of course, it uses up your quota. So if someone's storing hundreds of gigabytes in there, you might think, I'm going to clear out that app because it doesn't need all this data, or I might get a different app. So those are the things about app data folder. Apart from that, it's just a regular folder in Drive. So if anyone's used the Drive SDK or the Drive API, you know that there are a few operations that take folders, folder IDs. A few that take folder IDs, and in any situation, you can use app data there. Another really important feature of this is that the app data folder is tied to a project. Okay, it's a bit of a terminology issue, and I'm sorry about this, but a project for Google APIs, is something that can, underneath it, create multiple clients. They're OAuth 2 clients, but these clients can all work as if they're the same app. Why is this useful? Well, because you create a different client for your Android app as the one you create for your web app, or for your iOS app, or for your installed app. They're all different clients, but they are part of the same project, which means your app data can be accessed from an application running on one platform as well as an application running on another platform authorized in a different way. Very, very powerful. Again, cross-platform now. So we've shown you cross-device. This is also cross-platform. Authorization is easy now on Android. Okay, you pass a scope and you pass a user account and it all takes care of it for you. Okay, that's Google Play Services. Fantastic. I'm really happy about that. The scope is a slight thing I just want to talk about. When you ask for access to a user's app data, you have to give this special scope. 2 reasons. The first one is, perhaps you might argue that you could give access for this with, for example, the full Drive scope or other scopes that have access to read all of Drive. Well, I disagree, because people have granted permission to that already. If we were to add some ability, add to the role, inflate the permissions of this, then we could be in a problem because users will be granting access to something they hadn't actually explicitly granted access to. So that's the first problem. The second thing is, how great is it that we have this fine-tuned scope? Because your application, when they're asking for access, says, I want access to be able to write and read configuration data from Google Drive. Nothing more, nothing less. Okay? Absolutely perfect. So the user's much more inclined to click that button if they know that it's just a very, very small scope of access that you're going to give them. So I mentioned the folder alias. It's just a regular folder in Drive, and when you're doing any operation with files or folders in Drive, if you can pass a folder ID, you can just pass app data instead of it. So this is for creating files, for moving files from one folder to another folder, for searching for files, for updating files. Almost any file operation can take a folder. So we just pass app data, and for the developer, the rest is entirely transparent. Of course, this is a real folder in Drive, so it has a real ID, and you can actually use that real ID if you want it to be a bit faster. Okay, that's just an optimization that I would recommend you did. So a little bit of Java code, but we'll just run through this. We get the shared preferences. If you've used Android, this is very common for you. You get the shared preferences for that actual call, gets the shared preferences for every activity running in your application. And then we subscribe a listener to it. Really cool feature of the shared preferences. This listener just logs something, but actually we respond to this notification by creating the JSON and then uploading it. So we listen to those changes. I mentioned we use a sync adapter, and that's probably the best way to do it. Come and have a chat to Virtue afterwards, because she wrestled with this a bit. So you create a sync adapter. That just defines how you're going to do the sync, when you're going to do the sync, that kind of thing. And it just takes care of the whole thing for you. I think that's really the best way of doing that. And this is just an example of the start of that. And then we find the correct file in your app data folder. Because this is a folder, and because slightly unhelpfully here, Google Drive allows you to have multiple files of the same name in a folder. So this implementation is a bit naive. It does a query. It looks inside app data. If you see app data in parents, it looks inside there for the right name, the correctly named file, and grabs it. Obviously, there could be more than one file, so this implementation just uses the first. As I say, slightly naive, but you could easily improve on that. So we grab that file. When we want to upload new content, I mentioned this earlier, we create something that knows about the data and the MIME type. In this case, the MIME type is application JSON. We put it all together, and send it in a single API request to Drive. Done. One API request to get the data. Here's this one. This just grabs the raw data, just makes an authorized GET request, and gives it back. It's really easy. We've made 3 API calls to the Drive API, and that immediately we have all this functionality. We also run this little loop that detects changes. So if it's changed locally, we send the data to the remote source. If it's changed in the remote place, we suck the data down and just upload it. So this is almost the entire code to implement this. Okay? Fortunately, Virtue has released it on GitHub. So if you want to use it, grab it. It's very simple. You pass a shared preferences instance to the library, to a singleton in the library, and it just does it for you. Synchronizes all your shared preferences. I suggest you have a look at the code. You could extend it. You can throw it away. You can do whatever you like with it. But it's there, and I suggest everyone has a look at that. I hope throughout this talk, I've somehow got across to you that it's not just about baby monitors. Okay, I hope. I know I added this later because I was thinking, hang on, do people just think I'm talking about baby monitors? Anything, any file that you have, any data that you create, I think you should put that in a place where the user wants it. You should put that in Google Drive. You're taking notes. You're making images. You're modifying images. You're downloading videos. You're uploading videos. Anything that involves a file, put that data put somewhere where it's useful. Okay? Put the data where I want it. When I'm in the supermarket looking, I wonder which food my child likes the most. I know, I'll check. Put that data where I want it. Okay? This is a plea from me as a user. Please treat me as a user. Okay? Treat your users as users. Don't treat the individual device as a user. You've got to start planning your applications to be resistant to changes in device, changes in location. Your applications really must do. I think not to do that now when all the technology is available, I think it's a bug. I really do. And I think if you do that, you will create your cross-platform, cross-device, seamless experiences, and I think Google Drive is a way to do that. Okay, so my challenge to you guys, please, go ahead, do these, make these seamless applications. Everyone will thank you. Thanks very much. Questions? Oh, I should say before the questions, I'll be available on the Chrome and Apps sandbox on level 3 if you want a longer question or you don't feel like getting up in front of this crowd and talking.
Okay, question. How does the shared data get deleted from Google Drive if somebody uninstalls the app? Does that data just live there forever?
So when you uninstall an app, we have a nice flow there. The user is prompted to say, this app still has some hidden application data. Would you like to delete it or not? Okay, so we cover that case. You might consider an instance where you say, I don't want this app installed, but I want to keep the data around in case one day I do install it again. So that's that case, but we cover that. But the user is prompted, delete this data if you're going to install it, uninstall the app.
Okay, thanks.
Thanks.
This isn't a question. It's just a
tip. For a really good example of an app developed by one guy who does this, Sleep as Android is a sleep data collection tool with a plugin called Stats as Android, which gives you the charts inside the app but uses spreadsheets for the raw data.
Okay, uses Google Spreadsheets? Or?
Yeah, uses Google Spreadsheets.
Wow, okay.
So if anybody wants to see an example, that's an app that might be worth.
So I wish you'd told me this before, because that would have saved me writing an app, but like. But thank you. Sleep has Android.
Hi. In terms of compliance, and I'm thinking about Google Apps Enterprise. Could it be possible for me to, have the control over that properties file, over that configuration file, to make, a revision, inspectioning that file for complying purposes?
Yeah. So you're talking about the configuration file in app data.
Yeah. Because
sorry, go on.
Because I saw that you can actually view or edit the contents for the file.
So the user can't, but the developer can. Okay. So the application can. And it's a regular file in Drive, so it has all the other features. You can't share it. That's one feature it doesn't have. But you can look at revision history and other things like that. So actually, this is a nice version file in your Drive. It's useful and definitely covers that case.
What happens if two users modify at the same time? How do you handle the conflicts on Drive?
So you don't, and the world just explodes. So in this use case, and I specifically avoided this, so two things. One, the use case, we don't really cover it. The last change wins in this case, and that's not exactly good for this. But if you look at the use case, I'm not really going to go around with two devices in one hand, one device in one hand and one device in another hand and start like changing the configuration. It might happen that we're collecting data. So I don't think that particularly fits the use case. But what we do have is this awesome product called the Real-Time API. Anyone heard of this or seen the Real-Time API? Yeah. So this is specifically designed for that use case. I suggest you go and read about it. It provides all the conflict resolution, all the updating, everything there. And we have a session about that tomorrow. So we have a session, so please come along. Two of the hardcore engineers are going to tell you how it works, so that's exciting.
Thank you.
Thank you.
Hi. I want to ask a question. What can you do for the interconnection of Google Drive and Microsoft Office 365? And what's in my T-shirt?
So we had this chat earlier today, but I'll just go over what we said. So this gentleman is really interested in writing some kind of interconnection software between Google Drive and Office 365. Is that right?
API can just transfer document in one direction.
Right.
Cannot.
So the Google Drive API allows you to import and export data. Okay, so it's a two-way data transfer. And the formats that we use, we have some proprietary formats that belong to Microsoft, for example, docx and this kind of thing, which I think would be perfect for interfacing with Office 365. But there are other formats. I showed you CSV. There's HTML, of course, import and export from there, PDF, various formats, all the OpenOffice formats. So I think you can write that connector. I don't think you're going to have a problem there.
I submit an IETF Intellectual Chapter and about this topic. Please pay more attention to.
Sure.
Yeah.
So you've got my email address. We'll keep talking about this. Don't worry.
Yeah. Thank you.
Thank you. Any other questions? Brilliant. Thank you for coming. Come and chat to me later. Oh, you've got a question. Sorry.
Yeah.
Hold the applause.
Sorry. So actually there are two questions. One is, are you planning some support in terms of patterns or APIs for third-party like iOS or Microsoft Stack apps to use Google Drive? Second question is, if I write an app and I want to give the user both the privacy of their own Google Drive, but still I would want to cover the quota of them. You know what I mean? So I don't run into trouble when they hit the 5 GB limit.
Right.
Is there anything you're thinking about that?
So let's start with the first question first. Okay. Essentially, yes. Okay. We want to make the experience as easy as possible. Okay. We launched the Drive API actually a year ago. So still at the moment, it's pretty raw state. We're still trying to work out the use cases. And of course, in an ideal world, and I can't really comment on our future plans, but in an ideal world, if priorities were logically designed, yes, we would have libraries that make it crazy easy, as my colleague Stephen says, crazy easy to do this stuff. Just a single call, nothing else. So it's definitely in our plans. We want that to be as simple as possible. Right, second question.
It was about the quota on and the app owner, who owns the quota, and if the app owner can take over.
So I'm quite strongly of the belief that this is the user's data and the user should pay for the quota. Actually, all the smart people in the audience will notice that this application didn't cost the user any quota because it's using Google Spreadsheets as a backend, which can be as big as you like, and they don't take up any quota. So I'm not suggesting you go out and do that, but this app doesn't use any of the user's quota. It uses 1 kilobyte, and you know that's nothing.
All right, thank you.
Thank you. Thank you, everyone.
Welcome back to Google Developers Live at I/O from Moscone here at Google I/O 2013. I'm Louis Gray from Google Developers Live, and my guest right now is Nicolas Garnier.
Hi, Louis.
On the Drive team. He comes to us from Zurich, Switzerland. So that's quite the trip. Definitely appreciate you coming by. And today we're here to talk about the first year of Google Drive. It's hard to imagine it's only been 1 year, but it came out last year. Last time we were here, we were talking about docs and spreadsheets, and each piece in its own little slot. So maybe you can give us a little understanding of what's happened in the last 12 months. How has Drive evolved?
Well, 12 months ago, basically, we launched Google Drive, right? And people were really anticipating this launch. It's really what people expected, right? it's really a service for people to back up all of the files that they have on their desktop and upload them online and basically allow them to like share these files with their friends, for example, or their colleagues. But really, lots of the effort we have put in, and lots of I would say the groundbreaking features that we've been working on are really related to the SDK of Google Drive. So the SDK that's basically the API and a bunch of other features that I'm going to tell you about.
And that really sets it up for developers who want to develop against the Drive API.
It's really for apps to really build on top of Google Drive and really use Google Drive as basically the file system for the web platform, right? You can find nowadays really cool, really powerful apps online. For example, photo editors, I don't know, even faxing applications or diagram editors. All of that. So even Google Docs, right? All of these apps that run online that are great editors, we hope for them to actually use Google Drive really as the central place to read files and basically save files too. So that users have like this central place to really hold and manage and organize all of their files, not only the files that they have on their desktop, but really use that for really the web platform, as I said, all of the apps that are out there that needs to save files, that need to read files.
Basically. And you talked about, you look at a differentiation between backup, which is essentially a passive environment where you just send files from one place and put them in another to retrieve later, to more of an active, interactive piece with applications touching those files, sharing with other people. One thing that I've enjoyed is you essentially have, whether it be Chrome OS or any other application, if you log into your account on Google, your Drive documents are everywhere, wherever you follow. And it makes it really feel like any computer in the world is my computer. It's no longer that my files are on my desktop living somewhere. Do you feel like that's really changed the way users perceive it?
Yeah, I think that's really one of the big reasons why people are really moving away from the desktop and doing more and more things online, basically. So alongside with all of the cool apps that are available, and but to actually make these web apps better and make them actually want to use Google Drive as a SDK. We've been launching a bunch of features throughout this year. I can just mention a few ones really quickly. There's now a way for people who have files on Google Drive to publish their files as a website, basically. That's one of the really interesting features. We launched a real-time API allowing apps to build real-time collaboration feature, web apps, right, that are using Google Drive. Real-time collaboration feature that would be similar to Google Docs, for instance. We've seen some really cool apps there using that feature. What else?
One of the good things about being on Google Developers Live and getting to see the Google Drive team present is I've seen a lot of these real-time interactive features with the real-time API. I've seen a number of the developers out there who have tapped into it for the first time. And we've been able to see a lot of the tips, be it Claudio or Steven and the members of your team, talking about how to drive your first Drive apps, be it in Java or C++ or JavaScript. It really seems like the Drive APIs are exceptionally flexible for any type of code that comes in there.
Yeah, I definitely, actually, most of our APIs at Google have this really wide set of client libraries. We're really trying to make it easy for everyone to integrate with us. I think we have client libraries in 8 or 9 languages, iOS and Java, Python, PHP, etc. Right? JavaScript. And for JavaScript developers, and for web apps in general, we're really trying to make it even easier, right? We launched, for example, a bunch of widgets. Widgets that's basically, really common UI components, features of Drive that we don't want, developers out there to have to rebuild everything again, right? So we provide a bunch of widgets to them, like for example, the picker, which is like this file explorer, little file explorer they can embed in their website, so they don't have to build that, right? People can just trigger that widget. It's just a few lines of JavaScript, and people can go ahead and select a file in their Drive. It's like this little UI popping up. It's pretty nice. We have the same for sharing a file, right? So we allow developers to actually embed that, sharing widgets, the same one we use in Google Docs or Google Spreadsheet or Google Drive, to embed that UI directly into their website. So they don't have to rebuild that feature again.
And so in what fashion would somebody use Google Drive as the backend for their website? I've seen the feature launched, and it's really interesting to understand what kind of actual deployments have you seen so far?
So, I think the best suited apps for this currently are productivity apps. That's really the type of application, online productivity apps, right? That's really the type of application that, can really use the most of our features that are out there, right? For example, I forgot to mention that we have this really, really great feature that was available at the launch of the API a year ago. It's the ability for application to integrate directly with the user interface of Google Drive. So application can basically register just like they would on your local desktop computer. They register to open certain MIME types. They tell us, hey, I can open image. I'm an image editor, so I support opening JPEG and PNG images and stuff like that. So when people are actually installed that web apps or connected, we call that web apps to Drive, then from within Drive, they can, for example, right-click on an image or directly open an image with that image editor. For example, I can cite a few ones, Pixlr Editor or PicMonkey. Those are the few cool image editors that you can find online that have a very, very deep integration with the Google Drive SDK, basically, the Google Drive user interface.
And you mentioned Pixlr. They were actually one of the first developer partners that I asked Ali to take a look at. As somebody who uses Chrome OS every day, I want to have the ability to get into image editing, get really deep into it, do the cropping and all those things that you would do typically with a native desktop application. It's been great to see the integration with Drive there, where you can take content that is stored in Drive and pass it right through a system like that. Now, we have only a couple minutes. I definitely wanted to say thank you very much for coming through and talking with us about Drive and giving us an update on the 12 months of advancements that have happened.
Thanks for hosting me.
Absolutely. I appreciate you coming on GDL@IO. For those of you on the live stream, we're going to cut over to the sessions momentarily. And when we come back to GDL@IO, I'll be joined with the team working on games, which were all announced this morning, as you have incredible demos coming up.
All right, thank you.
Platform, getting your maps into iOS.
So back in December, we released the Google Maps for iPhone, an application that allowed you to use the Google Maps app directly on the iPhone. And it was a major update to Google Maps. Much like we had on Android, the Google Maps app on the iPhone used vector rendering to deliver a really powerful immersive experience in Maps that you could view Google Maps data on top of. Now, when we released it, as soon as we released it, we actually released an SDK because developers were clamoring for it right away. And the reason was because it allowed them to embed Google Maps data and Google Maps services on top of applications in their on top of their applications. And it took advantage of the same rendering engine that we used in the Google Maps iPhone application to render data within the SDK. So we basically got all that for free.
So when we launched the SDK in December of 2012, we launched in limited preview. But then in January of 2013, we launched publicly. And as you can see, we've had about 2 releases every month. And today, as was announced in the keynote, we have a special version 1.3 release where we're going to have some cool features to show off.
Yes, we'll get to that later.
We're not going to tell you exactly how to get started because there's some documentation here. You can go to developers.google.com/maps and have a read up. We'll talk a little bit about what to do with the SDK, but we're not going to talk to you about how to download it and get all that little stuff going.
So the first thing to note is that the Google Maps SDK is a static library. It's a framework that you download and incorporate directly into your applications. This gives you some advantages. That is, if we make an update to the SDK, you don't have to update immediately. You can take time to evaluate the update and change your code and change it in your next release. Therefore, your app will continue to work. Although we will give you a warning if you're developing in Xcode and using the simulator, we will log a warning that says, by the way, there's another version of the SDK. On the other hand, the basic services that we're working will continue to work, and the maps themselves will continue to update as we get new map data, much like all the other platforms.
We also have a notify group that you can join, which you can find the link on our developer site. And that's where we'll email you every time we do a release, and so you can actually get notified of when to go and download the new SDK, what's changed, and then what you need to do.
Right. So there's a little bit of confusion about this on Stack Overflow and various developer communities that there's a bit of myth around storyboards. Google Maps SDK does actually work with storyboards, unlike some people think that it doesn't. We are very happy to develop with storyboards, and that's personally my favorite way of developing a UI. When you go into Interface Builder, you simply create a new view, and then you make it of type GMS map view. And then that allows you to do any of your normal sort of delegating and flow through that you might do using storyboards.
You can also add a UI view and set that type to be a GMS map view as well, and then you can resize it and do all the things you're kind of used to when playing with storyboards.
Right.
I'll show you a little bit of super simple code. For those who are coming from JavaScript maps, this might be a little different. We've now got what's called a camera, and I'll show you a bit more about a camera later on because I find it really fascinating about all the cool things you can do with it. But what we do is we create a camera at a latitude and longitude and a zoom level, and then we instantiate a new map with that camera and a size. Here we're doing a rect 0, but because it's a UI view, it'll fill out the whole view. And then we create a marker where we add it to the map by setting map equals map view. If you've come from some other mobile mapping APIs, you may be used to asking the map to add things to the markers to the map for you. But with the way we're doing this is kind of following what we've done in JavaScript v3, where you have a marker and then you just tell it what map to be on. So if you want to have multiple maps and then just move that marker around, you can.
And this allows you to do interesting things like you can do your own marker management. So say you wanted to create 2 separate arrays of markers or dictionaries that had different properties associated with different markers. This would allow you to implement that kind of thing, say a cluster management tool or something like that within your code.
We should talk a little bit about the features.
Right. Let's talk about the features. It's a map. And these are some of the basic features that you expect when you get a map, right? You want to put a marker on your map. That I think pretty much on any web application, any SDK, you'd expect that, right? We also have polylines. Again, pretty basic. Here you can see we have a demo of a polyline that goes across the international date line. It's a geodesic, so it follows the curvature of the globe instead of the direct Mercator line. And then we also have polygons. And of course, all of these overlays support touch events.
And we also have the camera. So with the camera, I'll actually get into more detail later on about the camera. But you can show you, we can have the camera, we can control it. We also have a traffic layer. Obviously, this isn't a live feed because if it was around Moscone, it would just be red.
Yeah.
And we also have compass and my location. So the compass is where you can re-rotate the map back to pointing to north, and the my location will just move the map to where the user actually is. And we have all the map types you're used to enjoy. We've got road maps, we've got satellite maps, we've got hybrid, which is a combination of satellite with the layers on top, and we also have our terrain maps.
Right, so these are the basic map types that you would expect in any Google Maps app. It's used the same map data that you would get in the JavaScript Maps API on maps.google.com and the Android API. And we also have the largest imagery collection in the world that is available on all three platforms, as well as our terrain layer. We also, by the way, if you don't want to use the SDK, we do have a URL scheme that allows you to open up, if you use this URL scheme, you can open up the Google Maps for iPhone application that, if it exists on the device, or you can use the same URL to then send a query to maps.google.com if the app does not exist.
So I said I'd talk a bit about the camera because I find it really fascinating, being able to do all interesting things. With the camera now, we've got this thing called a target. So if you're coming from the JavaScript maps, this is what would be something like your map center. But instead we call it a target, and this is where you're looking at on the world. So you can use the target to look down and move it around. We also have a bearing. So the bearing is the rotation of the map. So you can rotate the map between 0 and 360 degrees, with 0 being north. And you can see as the map rotates, the labels move nicely, they get out of the way, or they just kind of shift around. So that's all taken care for you. We also have the viewing angle. So the viewing angle is the angle at which you're looking at your target. So you can see here we're kind of tilting the angle, tilting the camera to look at the Earth at a different angle. So if your angle is 0, you're looking straight down, and you can tilt it to about 45 degrees, and then you can get a really cool perspective of the Earth. And then
you see the 3D building zoom out of the map when you get that close.
Yeah, and we also have zoom. And because it's all vector data, we can do this really nice smooth zooming in and out. We also have the discrete zoom levels that you're used to, so we've got zoom level 2, 3, 4, but you can also go to 2.6, 9.12, and have little bits in between. And then
Not 9.12, because nobody goes there, right?
And then you can do like really cool, interesting things. And then see, as we zoom more into the map and get closer to the Earth, the 3D buildings appear. And then as we zoom out, the 3D buildings go away. And then combining all these things, you can do really interesting implementations on your map. So you can see here, as we move into Melbourne, we kind of rotate the map. We're angling down a bit more to get more perspective of what we're looking at. And then as we get closer, the 3D buildings grow out of the ground. And we're also kind of shifting to where the camera is looking and then kind of moving around. And then we could just sit there and look at this all day.
And as Luke said, this is all because we have these vector-based maps. We're basically passing map data down to the SDK, and the SDK is rendering it on the fly in the position, the angle, the bearing, the zoom, everything that you want to have.
And these are all programmatically done at the moment. But we also have all of these controls in gestures for when the user is actually interacting with your application. So we have what you're used to. You can pinch to zoom. You can kind of fling and have a little bit of inertia. You can use the 2 fingers to tilt and then go in more, and then you get your 3D buildings, and you can rotate around and kind of move. And it's all the things that you're used to in a Maps application, and especially in a Google Maps application.
So we also have something new. We promised this to you at the beginning. We're now delivering a new feature in the Maps SDK as of today. Version 1.3 of the SDK has tile overlays. So tile overlays are the ability to add your own map tiles on top of our maps, or in the case of this one, in place of our maps. And we will then use the SDK to render those map tiles. And in this case, we're using raster tiles and then putting them on top of our vector data that's already been rendered. And you can see here, this is geothermal estimates of geothermal capabilities in the United States. So these are where we believe there are reservoirs of geothermal energy in the US. And the previous one was actually the world at night, the NASA black marble data. And we believe this is a really tremendously powerful way for you to bring in your own kind of data. Some examples are you may use this for generating heat maps or showing off old old maps that are scanned from sort of historical map archives. And this last feature basically brings us to feature parity with the Android API.
A little bit of code here. We don't like showing too much code, but we wanted to show how simple it is to add a tile overlay to your map. What we can construct here is, all you're doing is requesting a URL with a X, a Y, and a zoom value, and then we will request that and we'll put it in the right spot. So here we create just a block that takes these values and returns a URL string, an NS URL, and then we pass that to the tile layer, and then we add that tile layer to the map.
So let's talk a moment about extending the platform. So the Google Maps has a ton of data that we provide to you aside from what's provided directly through the SDK. We have a number of different web services that you can use to add data to, regardless of which platform you're displaying the map on. And because these are Google Maps, you can use them to display this Google data.
The first one I like to show off is Places. So we've got a Places API which has access to millions of points of interest around the globe, and we can do searches for it and then get more rich information to add to your map. So here I did a search for Mexican food around San Francisco, and then based on all the points that came back, I tapped on one, and then I could load more information about that. So here we're just getting a bunch of photos. We can flick through, we can get the name, but we can also get reviews, the address, and other interesting information about that. We also have a couple of other searches. We've got nearby search, we've got radar search, and we've got a query complete implementation for you.
And autocomplete, yeah.
Autocomplete, yes. Here's a bit of code. Don't be too scared about this. We're just doing an async request with a URL. All the web services we're going to show you are kind of going to follow the same fashion. You do a request, and you can ask for JSON or XML to come back. And then based on the data that comes back, we can loop through, and then we can add the markers to a map.
So another key service that we don't provide directly in the SDK, but we do provide on a web service, is the Directions API. And in this sample, what we're showing you is the ability of the Directions API to adjust depending on the number of waypoints that you want to put in between. So if you've heard of the traveling salesman problem, we basically help you solve that by taking a starting location and an ending location, and then if you throw waypoints at us and tell us to optimize the route, we will find the fastest route between them. We allow in the free API up to 8 waypoints aside from the start and end location, and in the Maps API for Business, we allow up to 23. So this is again a really nice way to give information to your users, and it's quite snappy.
And so in the same fashion as the other Places API, we just do a URL request, the URL fetch essentially, to the Directions API. And what I want to point out here is what we're getting back is an encoded polyline as part of the request. And encoded polyline, you might think it's just my cat walked across the keyboard, but it's actually the way we encode polylines. So instead of having a whole lot of latitude and longitude points, we can just send this string down and then decode that and then put the path on the map.
Right. You actually do get direct access to all the coordinate pairs if you want those. We can also, through the SDK, re-encode polylines if you want to use them here, or perhaps store an encoded polyline or pass it to somebody who might be using it in the JavaScript Maps API. So we also do geocoding. Geocoding is the art of taking an address or a place and turning it into a latitude-longitude pair. So here it's actually pretty simple. We're seeing, well, of course, Perth. You did Perth, didn't you?
It's the best place in the world.
So we start with Perth and demonstrate Perth, and it's, as you can see, just returns back the geocode. And then the next one is Paris, and which always looks good on a big screen. So a very simple method of getting these of getting a latitude-longitude pair, and we will actually, if the result is not 100% clear, we'll pass back to you some alternatives should you ask for them.
Also on the platform, we have reverse geocoding. So it's the implementation of taking a latitude and longitude pair and actually converting it to an address. Here's a bit of code where we can set up a handler for when someone actually taps on the map. And then when someone taps on it, we send off a request to do a reverse geocode. And then based on the result, we'll put a marker on a map.
So this is actually built into the SDK. Pretty standard on a lot of platforms. So let's talk a little bit about making these maps your own and jazzing them up using some capabilities that are built into the platform as well as the SDK.
So the first one I want to show is marker animations. So in the iOS app that we relaunched, we had these marker animations where the marker just kind of grew out of the ground, and we thought that was really cool. So we decided to add it to the SDK. So as you can see here, when a marker is added to the map, it kind of pops up out of the ground, which is a really good way of drawing attention to the piece of information that you've just added to the map. We also have the ability to color our maps, our markers. The default markers. You don't actually have to supply a new image every time. You can use our base image, but you can change the hue and saturation and alpha values to have it colored however you want.
This is a change for those of you who may have started with the SDK when we first released it, where we only had the default red marker.
So you can see here, I've got a little magic function which will return me a random value for the hue, but then based on that, I can create a marker, and then I just set the icon to be the color, and I also set the animated to be yes, and then it will grow out of the ground when it gets added to the map. I also want to talk about core animations. You can see all these demos I did had really nice camera movement. It wasn't just a standard move from A to B. I used core animation for a lot of these to be able to define that I would like the camera values to move from one specific value to another one, and I can define the style of curve of animation that I'd like, and also what kind of values I want. So you can see here I got a little tour that flies around the world on my next trip that I'd like to go to. And then what we're doing is I'm just zooming out the camera, and then as I get to between two locations, I can actually ease in and ease out and then move the thing, and then I have a marker that flies in. So a little bit about the code. This is not too scary as well. We can use the curve, the animation timing curve. So here I'm defining an ease in and ease out function. And then using that, we can actually create an animation. And for here, I'm actually saying I'd like the latitude key to be animated over 5 seconds. I'd like to use this curve, and I'd like to move it to this value. And then we add it to that. The same thing goes with the keyframe animation, but here we can define steps of values we'd like to go through. And we can do this for the latitude, longitude, and zoom, bearing, and camera angle.
So the final thing is, you might have seen this during the opening when we were actually introducing ourselves, the little puzzle that solves itself. And actually, I'm going to challenge you. I want you to do this on the phone. This is actually an app. It looks like it's something that we just created, but I'm going to challenge Luke to try and actually.
No.
No.
There's a reason why I did a video.
Neither of us can actually solve that puzzle. But that actually is an application. And it takes advantage of, again, taking advantage of the iOS platform and its ability to generate images.
Yeah, so what we can do is we can use this rendering context method to actually render an image of the map as it is in its current state, and then return a UI image with that. So if any of you have seen something where you got fancy foldy maps where it comes in from the side and you just pull it out, they're usually going to use the same idiom because that's kind of how it's done on the platform. And so using these values, using this method, we can actually extend the platform to be able to, so you can actually do interesting things with it. And as long as it kind of ends up as a Google map that you can interact with, then it's really cool.
Right. So, we hope that what we've been able to show you in this presentation is how you can take advantage of both the native iOS platform as well as Google Maps and some of our Google services to generate a really rich and also very familiar experience to your users. Whereas your users are looking at a Google map, which is what most of them will be expecting to see pretty much for any map. And you take advantage of our rich amount of data and imagery that you can incorporate into your own application. So to get started, developers.google.com/maps for our developer documentation. We also do Google Maps Developer Live. So part of the Google Developer Live program, just do /live/maps. And often it's Luke or I doing a little 5 or 10 minute map shortcut on iOS issues. So thanks very much, everyone, for coming. And you can of course find us on Google+. So we'll take questions now. If you want to ask a question, please come up to the microphone, and we will take the question there.
Hi, I'm Alex from HTC.
Hi.
And I'm wondering, so the previous slides about rendering into UI image, is it possible to point top left geo coordinate and bottom right and zoom level and render exactly, not exactly the screen, but something bigger?
No, currently that's not possible.
No, it's not
but
possible.
you could do something interesting by using the projection object to kind of work something out, if you wanted to. But obviously you can't take that image and store it and keep it forever.
Yeah, okay, thank you.
On sort of on a similar note, is there a way to do the render an image and get an image of a map, but do it on a background thread? So if you had like a quickly scrolling UI and you wanted to like put a map inside of that scrolling UI or something, to be able to like have it render on a background thread so you don't block the UI?
No, currently the map runs on the UI thread, so there's currently no way of doing that.
Okay, thanks.
Two questions related to availability with this new API that's out there. The offline maps feature and Maps engine layer or map data layer, are either of those available in the iOS platform?
Neither of those are currently available in the platform.
That is correct. We do, the Google Maps engine, if you use that, does have a WMS output, and that's actually what we used for this tile overlay demo. We used a publicly available map in the Google Maps gallery for the world at night, the so-called black marble imagery, and then generated WMS tile overlay. And what was interesting about that is WMS doesn't come out exactly how our tile overlay expects to see it, and because you can implement that, you can subclass. Thank you. It's like my brain just shut off there for a second. Because you can subclass the tile renderer, you can just say, you can fudge it so that gets the right URL and pulls it into the tile overlay. It works the same way that you would expect it to work in the JavaScript or Android API.
You can basically take the same URLs from Android and JavaScript and use them in this.
Yeah. Is that app you had with the fudging then available in the Git repository, or do you?
Yeah, I'll put that. We'll put that code up somewhere.
Okay. Thank you.
Hi. I have two questions. One is about the geofencing. In the morning, there's some demos, I think, for the Android. How about for the iOS?
Well, so geofencing was released as part of the Google Play Services, which was only available on Android. You certainly could implement it yourself. I understand it's pretty battery intensive to do it yourself, but currently we don't have it available in the Google Maps SDK.
Yeah. Okay. Second question is, how about the indoor maps?
Indoor maps?
Yeah.
Currently we don't have indoor maps on the iOS and the iOS SDK.
Okay, cool. Thanks.
Sure.
We need to animate our markers. Can we do that with your SDK?
Currently the only animation that we actually have is the grow animation. We haven't got any other animations, and you can't supply your own yet.
So we can't supply new images regularly, or?
You can change the marker image and have whatever marker image you want. If you want to do that, like what sort of animation are you interested in doing?
Well, there's a few things. We need to flash some of them, and we also need some of them to rotate reasonably often. So what we can't have is something that flickers with destroying and remaking new ones.
Yeah, so you don't actually have to destroy or remake the marker. Because you actually keep a reference to that marker now, it's not actually added to the map and then forgotten about. You can keep that marker and you can keep changing the icon.
Okay. Yeah. And another question is, can we add our own vector layers?
Not yet.
No. But you said yet?
Well, no. You pushed me.
Okay, thank you.
Luke? Yeah. Are there any more questions?
Cool. All right, thank you, everybody.
All right, thank you.
just an example of a really big idea that doesn't sound possible. Let's move on to the second big principle that we think of. Now, when I work with teams and they are considering a new product, have some idea, want to staff it, want to build it, I ask them, what is it? Tell me something why you're doing it, why you observe something in the world. What's your and I found that if you do that, and I think about the insight that because there's so much technology, the world that we live in needs so much. If we go around and look really carefully at the world, we see technology such that we can be conscious of how the world is. And if we see that glimpse, then we can build out the answer, we can build it. We can build it. So I'm going to give a few examples of insight that has been really important to me in my process development. And again, a lot of things in one sentence, but they're powerful because nugget. So I would work with Google Base, and when I was working at Google Video, we were working with video who had great products, and we were working with cost. But at the same time, after we had just gotten online, we had other videos that were very, very popular. The numbers were significantly larger. Video made me realize power. So, all right, let me show you a few, just like 15 seconds of it. But it was this video that really gave me that insight. What I love about the video is that there's really background the entire time and doesn't know. But this was an insight. I realized, wow, this user generated content is really, really powerful. And today we all know that because that's what the world has become. User generated content has its place, it's very valuable. So all kinds of other content that's produced perhaps is really new. But it was that video that really gave me the confidence that YouTube, the big advocate of $6 So sometimes we have one little insight, and from that little insight, you make really great decisions. So I want to talk about another insight that's near and dear to our ads. Now, we did an ad system when Google had nothing. I would say over 30 people. And we didn't really let alone had to build ads where nobody knew anything about ads. Nothing was ever. But we had an insight. And that insight that I really did today was about ads build. And the insight's very basic, but it's ads are. Now, if you think about ads being interesting, you think about that we think about commercials, then we have to develop ads being useful, ads being the right person, right time, just like so that meant we build our own ads. That meant that if we had some problem, ads several people here who know me really well. And, so you'll appreciate when I say that John McCarthy made me do. So he made me look into this area called where you're given facts and relationships. And then when you learn new correlations, you can explain these new correlations. But everybody was leaving the department. And I co-founded in 1998 a web mining company. Because the web was so big at 5 million pages, we thought, how are we going to be able to get around it? And so we had an idea to make an automatic taxonomy. I tried to lead people to what questions were answerable on the web and what questions weren't. Because in those days, trust me, there weren't really recipes on the web, but the taxonomy around it was key. So we got angel funded to do this just in time for the .com crash. So I tried to figure out what the crash was, and I said, mobile is just about to start. So I moved into the mobile area in 1999, just in time for the telco crash. So after killing 2 industries, I was actually had a 1-year-old, and I was 4 months pregnant. And of course, I was unemployed, and I was actually living in Australia. And so the doctor said, you know, you need to be on bed rest. And I said, have you ever and I said, it's a lot like that. So I volunteered at the Internet Archive, and they have snapshots of the web over time. So as such, especially in 2001, it was much bigger than the web. It had 30 billion web users. And the live web at the time maybe had 5 billion. So I did a history-based search engine that was launched at like 12 billion pages. And you could look, you could dial back to 1997 and search for and you see all these and then moving forward to today, everything. So this is a project, and various companies talk about so volunteer.
Hi there, I'm Daniel Seberg with Google Developers Live here at I/O 2013, and I am joined right now by a couple of gentlemen from the Google Play Games team, I want to say, if that's accurate. Lead PM Greg Hartrell and PM Duncan Curtis. Thank you both for joining us here.
Thanks for having us, Dan. Happy to be
So
here.
let's start by talking about what Hugo announced today, Hugo Barrow, when he was up on stage, talking about Google Play Games service. What is it exactly? What does it mean to developers? Give me kind of the nuts and bolts here.
Okay, what we learned today in the keynote is, there's incredible momentum around Android in terms of the sheer number of installs, and particularly around, it's shown itself to be this tremendous gaming platform for game developers. And so what we've announced today is a set of services as a part of Google Play services that allow us to effectively bring games to the next level on Android and a number of cross-platform scenarios. It's really around 4 pivots. The first is achievements, so you can have badges, that virtual trophies that increase engagement in your game. Social and public leaderboards that leverage G+ circles, so you could be, number 1 amongst your friends and maybe not necessarily number 1 in the world. We have a set of APIs that we just affectionately refer to as Cloud Save that effectively squirrel away state for your game, save game progress, settings, number of other virtual progress that's in games. And the last part on Android, we have real-time multiplayer, which allows up to 4-player simultaneous play with more support for more players coming soon. And the theme around this is really, we're bringing the best of Google to gamers now, right? The things that we're good at, which is mobile and cloud, and allowing game developers to do what they do very well, which is make fantastic entertainment and fantastic gaming experiences.
And just to be clear, you mentioned this cross-platform idea, but Android, iOS, these are services that are going to work across all these devices. We saw it today in some of the demos where they were actually working with each other.
Yeah, that's right. Part of the services is actually providing native SDKs for both Android and iOS, and then our REST APIs effectively allow any developer to integrate across any interconnected device. And what's fantastic about this is just, giving game developers the ability to build a community around their games across any number of screens. So it's also demonstrative of our commitment to being a cross-platform play for game services as well.
Now, I heard reference to you're talking about the leaderboard idea. Far be it from gamers to be competitive. I'm sure we all know that that's a big appeal to any gamer to be listed in a leaderboard. You mentioned, between your friends, but between sort of the all-time list as well. Tell me about the fact that, when somebody beats someone's score or you get higher up on the leaderboard, this gets posted on Google+. I can actually brag about my score.
Look, of course, you can always brag about it on Google+, but what we're really doing is we're using it as a set of social discovery mechanisms, social play mechanisms around your Google+ circles. So this is how you're going to find your friends to play with, and who you're going to game with and who you're going to compare yourself against. You can also compare yourself against anyone who wants to put their score out there publicly. As I said, you can definitely still brag on G+.
Okay, that's good to know. And then what about the idea that, as you use different devices, if you do achieve or get to a certain level on one device, you go to another one, and sometimes you end up having to play that level again, which can obviously be a little frustrating. As much as you may love the game, you want to kind of move on. But now that will not be the case, right? You can actually have that kind of move from one device and pick it up where you left off.
Yeah, absolutely. And this goes into those Cloud Save APIs we were talking about, is that because they're cross-platform, game developers now can basically squirrel away the game save data, such that way, if you've won level 14 on your game and you on your phone, and then decide to go home and pick up a tablet, or if you lost your device or have a new device, you can effectively pop open that game and pick up where you left off. And we think that's a really powerful scenario. Specifically to that service is that game developers will get basically 4 keys that they'll be able to squirrel away 128K of data. And that's pretty good, simple surgical tool for game developers to maintain that state. And then because, again, it's available on Android, iOS, and effectively interconnected device, we think that game developers will be able to use that in really creative ways to solve this problem that you just described, and probably quite a few others.
Let's step back just a little bit. If you could sort of talk to me about the game developers community on Play. Where is this going? What are some of the sort of exciting innovations that you've seen in mobile gaming? Are there some examples you can point to that are really cool these days?
Yeah, I think we've seen a number of partners. We have over 30 launch titles, currently that have started using Google Play services. I think Duncan and I have seen some incredible implementations of the game services that we've launched today. One of my favorites is a title called Frozen Front, where they've taken our real-time multiplayer and they've effectively created a turn-based atmosphere. So this is my definition of it. It's a bit of a real-time strategy game where you move around pieces on a board, and then similar to the way like a tabletop game would work, I would send my moves to you, and then you see my moves play out on your screen. So I think that's a really clever implementation and kind of like a really engaging experience that comes from that.
I would say the same. But for me, I really do like Frozen Front's implementation, but I really like World of Goo's leaderboard.
Yeah.
So as you play through World of Goo, it's sort of a building mechanic game. And as you proceed through the levels, you get more building materials for your leaderboard. So the way you compare yourself against the other people in your circles is you actually get to build your tower. So the more skillful you are with just the few pieces of building material you have, you can actually build a better tower, or you can try again. Maybe a slightly different structure will actually get you further along. And since you're there, since they actually get your friends to show up in that level with you, your friends' pictures appear on little clouds for the taller your building goes. The little friends' faces are on clouds so you can see who you're actually beating. And it really drove me personally to want to just get that, those extra few meters or feet so that I could beat Greg in this case.
Not that you guys are competitive.
No.
Duncan hands down beat me in that game.
And what about that multiplayer component? I mean, how much is that becoming a part of the gaming experience within what we're talking about today and going forward?
It's really becoming an important element. I mean, one of the really key things that we're launching is auto matching. So you'll be able to not just play with your current group of friends on G+, and in your circles. You'll actually be able to play with other people within the world. So you can jump in and be like, wow, I'd really like to play a game of Riptide 2. But, I know my friends aren't around at the moment, so I'm just going to jump in and choose an auto match player, and I'll get matched up with someone elsewhere around the world.
And how does that work? I mean, if I'm that other person somewhere in the world, do I get a notification that someone wants to play?
We'll be matching people up who, at a very similar moment, have pressed, hey, I would like to play a game with another auto match person.
Okay.
And it would be really nice for players to be able to jump into those gaming experiences whenever they want. Sometimes it's hard to get your friends to play at exactly that right moment. So when it is one of your friends, so let's say I invited you to come play a game and you're in my circles. I said, let's play a game of Riptide 2. You'd get a notification. It'd be like, bing, Duncan Curtis would like to play Riptide 2 with you. Click, assuming you've got the game installed, you'll press play and straight into the game, and our game will begin. So this is going to be a really powerful tool for developers to re-engage audiences with a game that they may have lapsed from playing, or as a really great discovery mechanism for me inviting friends who haven't played the game yet. Because if you haven't had the game installed when I send you the notification, you'll be able to go check it out in the Play Store.
Right. And let's go back. I want to go back to that cross-platform or cross-device kind of an engagement. I'm forgetting the name. Forgive me, the name of the game that was demoed with the cars racing on the track and it was going across to different screens. I mean, that was fascinating to see how that worked.
Nostalgic about it. It was
right. I know it was meant to sort of recreate the idea of the race cars with the we had the trigger car. But anyway, talk me through what that.
Yeah, absolutely. I mean, we have a sample app that is called Nostalgic Racer that allows you to have like a little bit of a retro feel to it that way. And what's great about that is just having the ability to use those services across a variety of platforms, right? And so achievements, leaderboards, and cloud save are APIs that any game developer can take and with our samples or in some of the demonstrations that you've seen, integrate those into the title and basically have it work on an Android device, an iOS device, or any other interconnected device, as it were. And we think that cross-platform play creates demonstrations like those and adds a little bit of a wow factor that way. But plus what Dunga was saying earlier, right, is that it's really about developers creating a really strong community of gamers that they have across whatever device they happen to have access to. And we know that developers have told us that that's a really important thing for them. And that's kind of been a guiding principle for us designing what we've designed.
I think a good way to put it as well would be to say that not only will we enable developers to actually connect people across devices where they want to play, but for the first time you'll really be able to add your G+ friends on your iOS device or on your Android device or on the web, and all of those communities will be able to feed into each other, so people will be around when you want a game. I think that's really important.
Agree, absolutely.
And tell me, if you could sort of look into your crystal ball, where is this headed? What are sort of like the sort of coming developments here? I mean, for any developers thinking, all right, this is awesome stuff today, but even beyond this, is there anything you can kind of point to?
Yeah, I think today what we focused on is building this really strong foundation for game developers, and we think of it as kind of a first step in many things. And so what we've heard from our developers is that integrating with our game services have been really fantastic. One developer specifically turned to us and said, wow, with multiplayer it would have taken me weeks, if not months, to be able to integrate something that complex and frankly deal with the server configuration, setting up peer-to-peer sessions, all of like the really hard networking problems that come with that.
Yep.
And that developer specifically was able to do it in a day. And we were pretty impressed when we had heard that, and they were really obviously relieved that it was that easy. So I think that looking ahead, what we plan on doing is listening to our developers who put together these services in their titles and launch it, learn from that, and a frame of reference here is to think about Google Play is really only it's just over a year old now, and the momentum that Google Play has created is indicative of the way that Google executes and the way that we deliver on a lot of our services. We want to maintain that momentum with games, listen to our developers, and improve the services as we go forward.
I can't wait till we look back in a year and be like, look how fast we've come forward.
Yeah, absolutely.
Yeah. And we'll be developing features based on our developer feedback and our community feedback as well. Those are really important to us to choose what those sort of next features and wins for us are going to be.
That's great. And tell me a little bit about that, the experience of working with these 30 partners and how they've been to work with. I mean, I'm imagining that this has been kind of an exciting opportunity for them, but also for us.
Yeah, absolutely. I mean, we have a fantastic roster of partners. They come from actually very different types of studios. I mean, game developers, are very large outfits, or a guy literally in his basement.
Small, scrappy developer.
Yeah,
Are most of them from a sort of a traditional game development background, or were some of them almost starting up in a way looking at this opportunity? Or
the truth is that it's actually been a really healthy mix. We've been working with developers like Glue and Gameloft, right, who have some fantastic, really, rich experiences that you really feel like when you play them on a tablet or some high definition experience. But then Duncan brought up titles like World of Goo, and we have titles like Mega Jump that launched today. I think the other one that we were playing around the office was Plague Inc.
Plague Inc. was really good. Yeah, we've been playing Virtual Families 2 as well. We've been playing a lot of these games.
Be honest, that's all you guys do all day long is just to play games, right?
It's hard.
You
I
must
don't know how we
about
survive
this.
on a normal day.
Somebody has to do it.
Right. Someone's got to do it.
Yeah. Anything else you guys wanted to mention while we've got you here?
No, I think it really just comes down to we're really excited to see our partners launch their games today and create some of the fantastic gaming experiences they have. Hearing their feedback around what game services provided them, giving them opportunities to engage players, retain them, build discovery mechanisms for them to get their games known, and then frankly just having fantastic experiences that players are going to know and love for many months and years.
Sure.
This is just the start.
So if this is a race, I mean, we're going back to the car race then. We've just gone off the
Literally
start line,
just
really?
gone off the start line.
Okay.
We're excited.
I'm excited to see what's going to come out of all of this.
As are we.
All right. Well, Greg and Duncan, thank you both for joining us here. We really appreciate it.
It's a pleasure. Daniel.
That's going to do it for us here at Google Developers Live for now. Hang tight because we are going to be right back to talk about cloud. Guys, thanks again for joining us. Appreciate it.
Thanks.
Welcome back to Google Developers Live at I/O. This is our last session on the evening for day one. Louis Gray here with my co-moderator Daniel Seberg, who has returned. Thank you very much.
Happy to be here.
And Greg DiMichele from the Cloud Platform team. He's Director of Product Management on Cloud.
Hey guys.
And Cloud has had a really solid update here at Google I/O. A lot of good information. And so we want to take this time at the end of day one to really walk through those updates and understand from you what's going on with Cloud at Google and what do people need to know?
Sure. Well, as you mentioned, it was a pretty big day for us here. And when I think about what we're doing in the cloud at Google, it really comes back to the fact that, over the past 14 years at Google, we've been building this amazing infrastructure for our own use. And whether people knew it or not, when they used Maps and Gmail and Search, they've been using this incredible infrastructure. But until now, it's been something that's only available for Googlers. And now with the cloud, we're actually letting third-party developers, any developer out there, run their applications on this same world-class infrastructure. And I think that's probably the biggest, most exciting thing. About 11 months ago, we were here at Google I/O, and we first launched the cloud platform, and it's been a busy 11 months since then. We launched, I think, something like 163 new features in the 11-month period, which is really phenomenal if you think about it, but that's because we get to build on top of this incredible infrastructure that already exists within Google. So I then look at and think about what we actually announced here, and there's sort of a couple big issues. I mean, the biggest one is probably Compute Engine. For those folks who know, Compute Engine is our infrastructure as a service product. It allows people to run virtual machines, running operating systems of their choice in our infrastructure. And as of today, in fact, about 40 minutes ago, it's live and open for signups for any developer. So any developer out there who wants to can go to cloud.google.com and sign up and start firing up virtual machines and playing with what we can do in the infrastructure. So that's probably the single biggest announcement. We also talked quite a bit about App Engine. And again, for people who've been using the cloud platform, they know that App Engine is a platform as a service. Basically, it allows developers to concentrate their code on the part that makes their app different, and to not write that boilerplate code that just makes sure that it scales up when I get traffic and scales down when I don't get traffic. App Engine handles all that. App Engine's been usable for Java and Python and Go, and we announced today that we're adding PHP to the mix, which we think is a pretty big move in terms of millions of developers out there who now can use App Engine without having to learn a new language.
And so PHP is one of those things that comes up. Now, why PHP? Why are we doing that now?
Yeah, I mean, that one's actually pretty easy. If you look at any of the statistics out there, 3/4 of the world's websites are powered in some form by PHP. So it's just incredibly widely used. And so that made it a real obvious target for us. We really wanted to take and not just build your father's PHP. So we wanted to take PHP, which people know and love, but bring to it the App Engine magic, which is lets you build websites that scale up much faster than with any other technology. And equally important, when there's no traffic, we scale everything down to 0 and you have absolutely no charge when there's no traffic.
Excellent. Now, one thing I noticed, and Daniel and I were talking about it earlier, which is probably where he was going, we look in the keynote where cloud started to be part of the announcements from the other teams, and two parts in particular. One, we were looking at Android, where we talked about Google Cloud Messaging and the sheer volume of updates that are happening every single day with applications on Android. And the second piece was Google+, talking about using a Google data center as your darkroom for photos.
Right.
And I think what I'm hearing from them and from yourself is this real abstraction of where the data actually is and putting the data center to work. Maybe you can talk about that, about how the cloud platform is really benefiting the other platforms here at Google.
It all comes back to the fact that at Google, to do the amazing things we do at Google, we've had to invent new technology. We've had to invent new data center technology. We've had to invent new file systems with things like GFS. And what people don't even understand is
that's Google File System.
Google File System. We've, 2002, 2004, we wrote these papers that really changed the way data centers are run. What people don't realize is that Google, we've actually already moved a generation beyond those. We actually now use even more powerful technology on our infrastructure. I think what you're seeing across Google is, whether it's in Google+, whether it's in Android or in the cloud, it's all helping customers and developers do things that they never could do before. And in the cloud platform, very few people could afford to build the kind of data centers we can. I'll give you one example, networking. Everybody knows how important networking is to application performance. At Google, we led a partnership that actually we are the only non-ISP to have laid submarine cable under the ocean across the Pacific Ocean. And we did that because high quality networking bandwidth is critical to our core products. And what we're doing with cloud is now other developers can just come along for the ride and get the advantages of the networking and the performance and the data centers we're doing. And I think you see that across Google, the investments that we've made in infrastructure pay off across the whole company.
Now, for people who aren't here at I/O, they may not know that there's actually a cloud. We're part of the cloud in a sense right here because of the data sensing experiment that's going on. And in fact, there's one just below our feet right now. Talk a little bit about what that is here at I/O. What are we learning from that? What is it all about?
Yeah, this is cool. One of the things we wanted to do was we wanted to build a real world example of the cloud platform, and we wanted it to be part of Moscone Center. So all across Moscone Center, there's 525 of these little sensors. And they are running open source Arduino processors, open source software, and they're collecting data on things like the humidity and the temperature and the noise level, which is a little quieter now than it was a few minutes ago, but you can imagine when tracks are out. So we're measuring just the ambient information about the volume and the temperature, and there's pressure mats counting how many people walk by. Now you can imagine there's 525 of these collecting multiple data streams per second, and we're all funneling that into a Google Cloud Platform application. And we're collecting that data and using App Engine to ingest it. We're using Compute Engine to do some analysis for it. We're using our big data products to allow people to query it and visualize it. And if people come over to the sandbox over here, they can actually explore and visualize some of this data and see where were the popular places that people were hanging out, where and when was it really noisy. And again, this is all done in a way that when we're done, the data is all going to be turned over to the community and the tools so that people can continue to examine and look at this data. So I think it's just a really cool example of the physical world meeting the cloud platform in a way that allows developers to really see a truly large-scale application.
You mentioned big data. It's a term that gets thrown around a lot.
Sure.
You had an announcement today, which was a cloud data store.
Right.
Maybe you can walk us through that and help us understand how it fits with the other storage options.
Yeah,
that are
that's
out
a
there
great
at Google.
example. The cloud data store, let me back up for a second. At Google, if you think about it, we've had to build technologies with very big databases and data sets to do things like search the web. And from the beginning, we knew that SQL databases were just not going to cut it. So we've built what is probably the world's largest NoSQL data store for our own use at Google. And we had previously made that available just through App Engine. And to give you a sense of the scalability of this data store in App Engine is currently processing 4.5 trillion requests per month. Not billion, trillion requests per month. And the big news now is that data store is now not just available from App Engine, it's available from Compute Engine, or actually any place with a REST API. So any developer, no matter what programming language you're using or environment you're in, you now have access to this incredibly high performance, highly scalable data store. And we think that's also a big step forward because NoSQL databases really are at the heart of a lot of modern, highly scalable web applications. I don't think people understand when we say Google scale, what we mean. We count in trillions, not billions.
Right, and trillions, the joke would be, I've forgotten how to count that low.
Right, even Carl Sagan would call a trillion a big number, right?
Right, absolutely. You were saying what it can do for our partners. What are some interesting implementations that you've already seen with Cloud Data Store?
Yeah, so there's a couple really good examples of the cloud platform. A couple of them have been around mobile. I mean, not surprisingly, there are a lot of people out there building mobile applications, and almost any application you immediately need to have some sort of a back end. Whether it's a game because you want to connect people together, or whether you just want to collect information about what features are being used or not, any mobile application worth its salt has a back end. So some of the examples we've seen are Fresh Planet, which is a company that makes a mobile app called Song Pop, which I don't know if you've seen. You challenge your friends, and it will play little snippets of a pop music, and it's in different categories, and the first one to identify the song wins. They currently are built on App Engine, and they're really proud to say that they have only 2 developers who build their back end of the application. despite the application scaling up and being, I think, the 5th most popular application in the store. Another one that's really popular right now for any of our viewers who are in Europe, they might know that the Eurovision Song Contest is going on right now. This is the song contest is very big in Europe, and part of it is voting on what song should be the best. What we've done is they've built the Eurovision backend on top of Compute Engine. And so they're seeing, peak loads of 50,000 requests a second, peak loads. And we're able to meet that, and 90% of those we deliver in under 24 millisecond latency. So think about that. At peak, we're delivering the vast majority of their requests in 24 milliseconds or less.
And what's interesting about that is first we're talking about big numbers with trillions.
Right.
And now we're talking about little tiny numbers like microseconds.
Yeah.
And trying to work even smaller than that.
Absolutely. One of the things that we've really tried at Google is we know that speed matters. So we've tried really hard in the cloud platform to focus on not just fast performance, but consistency. Because it's very frustrating if you're building an application and one day your data performance is just fine and the next day it seems to be slow and you can't figure out why. So it's really been sort of a hallmark of ours to think about not just raw performance, but consistency of performance as well.
Right. Yeah. Louis touched on big data,
yeah.
and I would love to hear from you on what are the sort of secrets to unlocking big data. What are companies doing to kind of make that useful and
yeah,
because people talk about it a lot.
Yep.
But I think that a lot of people struggle with really what to do with it and what it means.
The hard part of big data really comes in a couple forms. One is just the sheer size of the data means that traditional database management tools just don't work. You need to think about the data in a different way. And clearly that's where things like NoSQL data stores, the cloud data store come in. But the other thing about big data is a lot of it is about how you aggregate different data from different sources together. It's how do I take my log data and how do I combine that with my user data and how do I combine that with my sales data and do it in a way that lets a casual business analyst actually make sense of it. And that's where things like BigQuery come in. BigQuery is our product that allows you to almost magically take these giant NoSQL databases and query them as though they were SQL. You write SQL-like queries as though it were a SQL database, but underneath it's in fact automatically sharding and it's a highly scalable NoSQL infrastructure. So I think the challenges of big data really come in multiple dimensions, but mostly it comes back to people wanting a platform that takes care of the grunt work, for lack of a better word. I mean, there's a lot of work in building out big data that's not unique to your data set. And we're really trying to take that away so that developers get to focus on the fun part, if you will, the things that make their app different rather than the things that make their app the same as somebody else.
I'm glad you mentioned BigQuery. One cool thing about Google Developers Live is we don't just start and stop at I/O. We have Google Developers Live events year-round, and we regularly have guests like Michael Manicherry from your team to go ahead and come in and talk about BigQuery. And you mentioned that it's fun. And there's something fun about seeing somebody take a big data set, be it Wikipedia, or something of that order, and running a query against it and seeing those real-time results. So I've enjoyed watching that as we've done our GDL events. And so one thing you also talked about, without getting any secrets away, I don't want Urs to come over here and get us all in trouble.
Thank you, I appreciate that.
But you talked about the uniqueness of Google, and you said sometimes we're working on the next generation of a file system or any other piece of your equipment that people haven't even thought of or caught up to yet. What is it that's unique about the Google environment that gives you access to incredible delivery?
Yeah, I mean, I think if you step back, we invented everything we invented because we had to. Like Google has big goals, right? I mean, when Google set out to say we're going to index the entire World Wide Web, that means you need to store an entire copy of the World Wide Web. And you quickly realize that normal file systems don't work for that. So you have to invent your own file system. It really is a case of us setting huge objectives, having a Gmail system where you can have 25 gigabytes of email. Well, that makes you have to invent new technology. So I think that's one part of the secret at Google is that we aim for big goals, and as part of that, that forces you to invent new computer science and invent new data centers. And the other part is we invest in our infrastructure. One of the things, Urs said this in the keynote, so I feel like I can say it. We spent $2.9 billion on infrastructure last year. That's a phenomenal amount of money, and we do that because it's so critical to our own success. We have to do it to be able to keep advancing the state of what we do. And the cloud platform, we are just really fortunate enough to be able to take these amazing things that Google develops for its own use and offer them up for other developers to use. And that's really where the magic comes in. I think it's fun to see technologies that we develop and to have us not just write a public paper about it, although we do that, we continue to publish academic papers, but to go to the next step and say, here's an academic paper, and here's a running version in Google Cloud that you can play with. I think that's pretty fun. It's pretty amazing at Google. So I really think it's the combination of there's Google big and Google scale, and we aim for that in everything we do. And then in cloud, we get to come along for the ride and invite other developers into the party. And so that's really a lot of fun for me.
Yeah. Earlier we had the team on, we call it Performance Alley. The Chrome team came over, they talk about making the web faster. And one of the things that we touched on is it's an old adage that you don't really solve a bottleneck, you just move it somewhere else.
Yes.
And you continue to find out whether it's a computation or it's a server or it's the network or it's the cloud. And it seems like with the cloud platform and a lot of the work we're doing here at Google, we abstract a lot of that away from the developer, so the developer doesn't have to worry anymore. How do you start that kind of analysis and chase that bottleneck so it continues to move and becomes less of an issue?
Well, no, you're absolutely right. Every time you make one area faster, you now have, there's always one area that's at the top of the stack, that the area you want to work on most, right? And that's the fun, that as you nail one area, then the bar just keeps being raised higher. And I think that's, that notion of constantly chasing the next performance metric is really important. In Compute Engine, for example, we are, as part of the signups, we demonstrated, spinning up 1,000 VMs, or it was a couple hundred VMs, don't want to oversell. And our VMs are currently starting up in the range of 20 to 30 seconds to start up in a VM. When we talk to customers, they say, oh, that's amazing, that's phenomenal. But we look at that and go, okay, that's fine, but that's not really where we want to be. And the reason is we really want to change the way people work. An example of that, one of the things we announced today that I really think is going to change the way people think about cloud applications is this may sound mundane, but it's around billing. Today with almost every cloud provider, your time is measured in hours. So if you make a 15-minute compute job, you pay for an hour. It's sort of like, if I made a phone call for 15 minutes and the phone company charged me for an hour, right? That wouldn't be right. Well, because our VMs start up so fast, we actually charge by the minute. There's a 10-minute minimum, but then after that, you only pay for the actual minutes you use. And we think this really kind of changes the way people think about problems. You can start to throw cores at a problem, if you will. Like, why not double the number of cores and make the job take 20 minutes instead of 40 minutes? Because now I can do that, and it's cost effective to do that. So, we think the performance, the sub-hour billing is going to open up a lot of new ways for people to use computing. So that's probably, in the non-product area, one of the things I think is most interesting, and we're getting a lot of good response for. But you couldn't do that if we didn't nail the startup time and make the performance really fast, right? Yeah. So, but you're right. So doing performance in one area then opens up new possibilities in others.
I know we're running out of time, but I would love if you could address the idea of information security, which is obviously something I'm sure that you think about a lot. But in terms of the ISO standard that's applied to managing data and all of that, I think that's absolutely worth talking about.
So obviously, at Google, it's critically important that we have information security is just a core part of everything we do. But what customers want is they want some external validation of that. And the ISO standard 27001 is that. They come through and they audit your physical security of your data centers, your logical security, your access control privileges. They can come in and do audits at various points in times. And so we have now completed the ISO 27000 certification on App Engine, Compute Engine, and Cloud Storage. And one of the things we've heard from particularly some of the larger customers is that it's a confidence sign. And we're going to continue to do more certifications as time goes forward, because we think they're a good way of demonstrating how important security is and how seriously we take it at Google. But you're right, it's foundational to the whole notion of doing cloud computing. So I was really happy that we did that. And again, stepping back, it's another example where we have to invest in security for our own purposes anyway, for Google, right? And again, then the external developers can just take advantage of that. So yeah, and I was glad that we got that and we were able to announce that today.
That's great.
I'm glad you were able to join us. I really appreciate you waiting to do the last slot of day one.
No problem. I'm in between the attendees and I think like food and drink, so I appreciate the chance to be here.
It's been really exciting to talk about cloud platform. I mean, the kind of scale that we have at Google is really tremendous. I'm really glad to see that we're really taking that to the development community. One thing we do at GDL is we talk to our developers every day throughout the year in their language, in their time zone, from a location that makes sense. We're really excited to do that at I/O.
Yeah, and encourage developers to try it out and give us feedback. You know, we have product forums, we have pre-release forums, we have issue trackers. We want to hear. The PHP is a classic example. PHP was partly driven by the fact we had direct feedback from users saying we want this. So we want to hear from people about what's the next thing that they would like to see us do.
Right. Great. Well, thank you so much. Daniel Seberg and I will be back here tomorrow morning. I'm really looking forward to that. We kick off our GDL at I/O broadcasting even before the sessions kick off tomorrow from 9 to 10 a.m. What we're going to be doing is showcasing a lot of the work you did in the sandboxes.
Yeah, exactly. That's what I was doing for the better part of this afternoon, was wandering around to different sandboxes. YouTube, we talked to some folks about Drive, Google+, and of course Maps. So we're going to bring all of that to you tomorrow.
Absolutely. So we're going to run through those sandbox partners, and we have a really special treat. We're going to have Bradley Horowitz from Google+ to do a deep dive around lunchtime tomorrow for those of you on the Pacific side. So we welcome you coming back and talking GDL at I/O. In the meantime, subscribe to Google Developers on YouTube. You won't miss a single thing from us throughout the year. And check us out at developers.google.com/live. We'll see you tomorrow morning.
Are wearing pants. We have an audience question. How does that affect the way you evaluate potential investments, especially at the seed level?